Chapter 38, Part 1 of Principles of Geology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Principles of Geology by Charles Lyell. Section 86. Laws which regulate the geographical distribution of species. Continued. Geographical distribution of animals. Buffon on specific distinctness of quadrupeds of Old and New World. Doctrine of natural barriers. Different regions of indigenous mammalia, Europe, Africa, India and Indian Archipelago, Australia, North and South America. Quadrupeds in islands. Range of the Cetacea. Dispersion of quadrupeds. Their powers of swimming. Migratory instincts. Drifting of animals on ice floes. On floating islands of drift timber, migrations of cetacea, habitations of birds, their migrations and facilities of diffusion, distribution of reptiles, and their power of dissemination. Geographical distribution of animals. Although in speculating on philosophical possibilities, said Buffon, the same temperature might have been expected, all other circumstances being equal, to produce the same beings in different parts of the globe, both in the animal and vegetable kingdoms. Yet, it is an undoubted fact that when America was discovered, its indigenous quadrupeds were all dissimilar to those previously known in the Old World. The elephant, the rhinoceros, the hippopotamus, the camelopard, the camel, the dromedary, the buffalo, the horse, the ass, the lion, the tiger, the apes, the baboons, and a number of other mammalia were nowhere to be met with on the new continent, while in the old, the American species of the same great class were nowhere to be seen. The tapir, the llama, the peccary, the jaguar, the cougar, the agouti, the paca, the coati, and the sloth. These phenomena, although few in number relatively to the whole animate creation, were so striking and so positive in their nature that the great French naturalist caught sight at once of a general law in the geographical distribution of organic beings, namely the limitation of groups of distinct species to regions separated from the rest of the globe by certain natural barriers. It was therefore in a truly philosophical spirit that, relying on the clearness of the evidence obtained respecting the larger quadrupeds, he ventured to call in question the identifications announced by some contemporary naturalists of species of animals said to be common to the southern extremities of America and Africa. The migration of quadrupeds from one part of the globe to another, observes Dr. Pritchard, is prevented by uncongenial climates and the branches of the ocean which intersect continents. Hence, by a reference to the geographical sites of countries, we may divide the earth into a certain number of regions fitted to become the abodes of particular groups of animals, and we shall find on inquiry that each of these provinces, thus conjecturally marked out, is actually inhabited by a distinct nation of quadrupeds. It will be observed that the language of Buffon respecting natural barriers, which has since been so popular, would be wholly without meaning if the geographical distribution of organic beings had not led the naturalists to adopt very generally the doctrine of specific centers, or, in other words, to believe that each species, whether of plant or animal, originated in a single birthplace. Reject this view, and the fact that not a single native quadruped is common to Australia, the Cape of Good Hope, and South America, can in no ways be explained by adverting to the wide extent of intervening ocean, or to the sterile deserts, or the great heat or cold of the climates through which each species must have passed before it could migrate from one of those distant regions to another. It might fairly be asked of one who talked of impassable barriers, why the same kangaroos, rhinoceros or llamas should not have been created simultaneously in Australia, Africa and South America. The horse, the ox and the dog, although foreign to these countries until introduced by men, are now able to support themselves there in a wild state, and we can scarcely doubt that many of the quadrupeds at present peculiar to Australia, Africa and South America might have continued in like manner to inhabit each of the three continents, had they been indigenous, or could they once have got a footing there as new colonists. At the same time, every zoologist will be willing to concede that even if the departure of each species from a single center had not appeared to be part of the plan of nature, the range of species in general must have become limited under the influence of a variety of causes, especially in the class of terrestrial mammalia. Scarcely any one of these could be expected to retain as fair a claim to the title of cosmopolite as man, although even the human race, fitted as it is by its bodily constitution and intellectual resources to spread very wildly over the earth, is far from being strictly cosmopolite. It is excluded both from the Arctic and Antarctic circles, from many a wide desert and the summits of many mountain chains, and lastly from 3/4 of the globe covered by water, where there are large areas very prolific in animal life, even in the highest order of the vertebrate class. But the habitations of species are, as before stated, in reference to plants, circumscribed by causes different from those which determine their stations, and these causes are clearly connected with the time and place of the original creation of each species. As the names and characters of land quadrupeds are much better known to the general reader than those of the other great families of the animal kingdom, I shall select this class to exemplify the zoological provinces into which species are divisible, confining myself, however, to those facts which may help to elucidate some principle or rule apparently followed by the author of nature, in regard to that mystery of mysteries, the first peopling of the earth with living beings. First, then, the European region comprehends, besides Europe, the borders of the Mediterranean, and even the north of Africa, and extends into Asia beyond the Ural Mountains and the Caspian. Although the species are almost all peculiar, the number of characteristic genera is remarkably small. The bear, the fox, the hare, the rabbit, the deer, and almost every European form is found equally in several of the other large provinces of Mammalia, where the species are distinct. Even the mole, talpa, although confined to the northern parts of the Old World, ranges eastwards as far as the Himalaya mountains. Secondly, the African fauna, on the other hand, is singularly rich in generic forms, not met with in a living state in any other region. The hippopotamus, for example, of which two very distinct species are known, the giraffe, the chimpanzee, the blue-faced baboon, the four-fingered monkeys, colubus. Many carnivora, such as proteles, allied to the hyena and a multitude of other forms, are exclusively African. A few of the species inhabiting the northern confines of this continent, such as the dromedary, lion, and jackal, are also common to Asia, and a much larger number of forms belong equally to the great Asiatic province, the species being distinct. The elephant, for example, of Africa is smaller, has a rounder head and larger ears than the Indian one, and has only 3 instead of 4 nails on each hind foot. In like manner, not one of the 3 African species of rhinoceros agrees with one of the 3 Indian kinds. Thirdly, the southern region of Africa, where that continent extends into the temperate zone, constitutes another separate zoological province, surrounded as it is on 3 sides by the ocean, and cut off from the countries of milder climate in the northern hemisphere by the intervening torrid zone. In many instances, this region contains the same genera which are found in temperate climates to the northward of the line, but then the southern are different from the northern species. Thus in the south we find the quagga and the zebra, in the north the horse, the ass, and the jigetai of Asia. The south of Africa is spread out into fine level plains from the tropic to the Cape. In this region, says Pennant, besides the horse genus, of which 5 species have been found, there are also peculiar species of rhinoceros, the hog, the hyrax, among the pachydermous races, and amongst the ruminating, the Cape buffalo, and a variety of remarkable antelopes, as the springbok, the oryx, the gnu, the likoufe, the pigarga, and several others. Fourthly, the assemblage of quadrupeds in Madagascar affords a striking illustration of the laws before alluded to as governing the distribution of species in islands. Separated from Africa by the Mozambique Channel, which is 300 miles wide, Madagascar forms with 2 or 3 small islands in its immediate vicinity a zoological province by itself, all the species except one, and nearly all the genera being peculiar. The only exception consists of a small insectivorous quadruped, Centetes, found also in the Mauritius, to which place it is supposed to have been taken in ships. The most characteristic feature of this remarkable fauna consists in the number of quadrumana of the lemur family, no less than 6 genera of these monkeys being exclusively met within this island, and a 7th genus of the same called Galago, which alone has any foreign representative been found, as we might from analogy have anticipated in the nearest main island. Had the species of quadrupeds in Madagascar agreed with those of the contiguous parts of Africa, as do those of England with the rest of Europe, the naturalist would have inferred that there had been a land communication since the period of the coming in of the existing quadrupeds, whereas we may now conclude that the Mozambique Channel has constituted an insuperable barrier to the fusion of the continental fauna with that of the great island during the whole period that has elapsed since the living species were created. Fifthly, another of the great nations of terrestrial mammalia is that of India, containing a great variety of peculiar forms, such as the sloth bear, Proculus, the masked deer, Moscus, the nilgau, the gibbon or long-armed ape, and many others. Sixthly, a portion of the islands of the Indian archipelago might perhaps be considered by some geologists as an appendage of the same province. In fact, we find in the large islands of Java, Sumatra, and Borneo the same genera, for the most part, as on the continent of India, and some of the same species, for example, the tapir, Tapirus malayanus, the rhinoceros of Sumatra, and some others. Most of the species, however, are distinct, and each island has many and even a few genera peculiar to itself. Between 80 and 90 species are known to inhabit Java, and nearly the same number occur in Sumatra. Of these, more than half are common to the two islands. Borneo, which is much less explored, has yielded already upwards of 60 species, more than half of which are met with either in Java or Sumatra. Of the species inhabiting Sumatra and not found in Java, Borneo contains the greater portion. Upon the whole, if these three large islands were united, and a fusion of their respective indigenous mammalia should take place, they would present a fauna related to that of continental India, and comprising about as many species as we might expect from analogy to discover in an area of equal extent. The Philippine Islands are peopled with another assemblage of species, generically related to the Great Indian type. Seventhly, but the islands of Celebes, Amboina, Timor, and New Guinea constitute a different region of mammalia more allied to the Australian type, as having an intermixture of marsupial quadrupeds, yet showing an affinity also to the Indian in such forms as the deer, cervus, the weasel, vivera, the pig, sus, the macaque monkey, Cercopithecus, and others. As we proceed in a southwesterly direction, from Celebes to Amboina, and thence to New Guinea, we find the Indian types diminishing in number and the Australian, that is, marsupial forms, increasing. Thus, in New Guinea, 7 species of pouched quadrupeds have been detected, and among them 2 singular and 3 kangaroos. Yet only 1 species of the whole 7, that is, the flying opossum, Petauris ariel, is common to the Indian archipelago and the mainland of Australia. The greater the zoological affinity, therefore, between the latter and the New Guinea fauna, although it seems in some way connected with geographical proximity, is not to be explained simply by the mutual migration of species from one to the other. Eighthly, when Australia was discovered, its land quadrupeds belonging almost exclusively to the marsupial or pouched tribe, such as the kangaroos, wombats, flying opossums, kangaroo rats, and others, some feeding on herbs and fruits, other carnivorous, were so novel in their structure and aspect that they appear to the naturalist almost as strange as if they were the inhabitants of some other planet. We learned from the recent investigations of Mr. Waterhouse that no less than 170 species of marsupial quadrupeds have now been determined, and of the whole number, all but 32 are exclusively restricted to Australia. Of these 32, 9 belong to the islands in the Indian archipelago before mentioned, and the other 23 are all species of opossum inhabiting the tropical parts of South America, or a few of them extending into Mexico and California, and 1, the Virginian opossum, into the United States. Ninthly, it only remains for me to say something of the mammiferous fauna of the North and South America. It has often been said that where the 3 continents of Asia, Europe, and North America approach very near to each other towards the pole, the whole Arctic regions forms one zoological and botanical province. The narrow straits which separate the Old and New World are frozen over in winter, and the distance is further lessened by intervening islands. Many plants and animals of various classes have accordingly spread over all the Arctic lands, being sometimes carried in the same manner as the polar bear, when it is drifted on floating ice from Greenland to Iceland. But on a close inspection of the Arctic mammalia, it has been found of late years that a very small number of the American species are identical with those of Europe or Asia. The genera are in great part the same or nearly allied, but the species are rarely identical and are often very unlike, as in the case of the American badger and that of Europe. Some of the genera of the Arctic America, such as the musk ox ovibus, are quite peculiar, and the distinctness of the fauna of the great continents goes on increasing in proportion as we trace them southwards, or as they recede further from each other, and become more and more separated by the ocean. At length we find that the three groups of tropical mammalia, belonging severally to America, Africa, and India, have not a single species in common. The predominant influence of climate over all the other causes which limit the range of species in the mammalia is perhaps nowhere so conspicuously displayed as in North America. The Arctic fauna, so admirably described by Sir John Richardson, has scarcely any species in common with the fauna of the state of New York, which is 600 miles further south and comprises about 40 distinct mammifers. If again we travel further south, about 600 miles, and enter another zone running east and west in South Carolina, Georgia, Alabama, and the contiguous states, we again meet with a new assemblage of land quadrupeds, and this again differs from the fauna of Texas, where frosts are unknown. It will be observed that in this continent there are no great geographical barriers running east and west, such as the high snow-clad mountains, barren deserts, or wide arms of the sea, capable of checking the free migration of species from north to south. But notwithstanding the distinctness of those zones of indigenous mammalia, there are some species, such as the buffalo, Bison americanus, the raccoon, Procyon lotor, and the Virginian opossum, Didelphis virginiana, which have a wider habitation, ranging almost from Canada to the Gulf of Mexico, but they form exceptions to the general rule. The opossum of Texas, Didelphis carnivora, is different from that of Virginia, and other species of the same genus inhabit westward of the Rocky Mountains, in California for example, where almost all the mammalia differ from those of the United States. Tenthly, the West Indian land quadrupeds are not numerous, but several of them are peculiar. And eleventhly, South America is the most distinct, with the exception of Australia, of all the provinces in which the mammalia can be classed geographically. The various genera of monkeys, for example, belong to the family of Platyrrhini, a large natural division of the Quadrumana, so named from their widely separated nostrils. They have a peculiar dentition, and many of them prehensile tails, and are entirely unknown in other quarters of the globe. The sloths and armadillos, the true blood-sucking bats or vampires, Philostomidae, the capybara, the largest of the rodents, the carnivorous Quatimondi, Nasua, and a great many other forms are also exclusively characteristic of South America. In Peru and Chile, says Humboldt, the region of the grasses, which is at an elevation of from 12,300 to 15,400 feet, is inhabited by crowds of llama, guanaco, and alpaca. These quadrupeds, which here represent the genus camel of the ancient continent, have not extended themselves either to Brazil or to Mexico, because during their journey they must necessarily have descended into regions that were too hot for them. In this passage, it will be seen that the doctrine of specific centers is tacitly assumed. Quadrupeds in islands. Islands remote from continents, especially those of small size, are either destitute of quadrupeds, except such as have been conveyed to them by man, or contain species peculiar to them. In the Galapagos archipelago, no indigenous quadrupeds were found except one mouse, which is supposed to be distinct from any hitherto found elsewhere. A peculiar species of fox is indigenous to the Falkland Islands, and a rat in New Zealand, which last country, notwithstanding its magnitude, is destitute of other mammalia, except bats, and these, says Dr. Pritchard, may have made their way along the chain of islands which extend from the shores of New Guinea far into the southern Pacific. The same author remarks that among the various groups of fertile islands in the Pacific, no quadrupeds have been met with, except the rat and a few bats as above mentioned, and the dog and the hog, which appear to have been conveyed thither by the natives from New Guinea. Rats are to be found even on some desert islands, whither they may have been conveyed by canoes which have occasionally approached the shore. It is known also that rats occasionally swim in large numbers to considerable distances. Geographical range of the Cetacea. It is natural to suppose that the geographical range in the different species of Cetacea should be less correctly ascertained than that of the terrestrial mammifers. It is, however, well known that the whales which are obtained by our fishers in the South Seas are distinct from those of the North, and the same dissimilarity has been found in all the other marine animals of the same class, so far as they have yet been studied by naturalists. Dispersion of quadrupeds. Let us now inquire what facilities the various land quadrupeds enjoy of spreading themselves over the surface of the earth. In the first place, as their numbers multiply, all of them, whether they feed on plants or prey on other animals, are disposed to scatter themselves gradually over as wide an area as is accessible to them. But before they have extended their migrations over a large space, they are usually arrested either by sea or a zone of uncongenial climate, or some lofty and unbroken chain of mountains, or a tract already occupied by a hostile and more powerful species. Their powers of swimming. Rivers and narrow friths can seldom interfere with their progress, for the greater part of them swim well, and few are without this power when urged by danger and pressing want. Thus, amongst beasts of prey, the tiger is seen swimming about among the islands and creeks in the delta of the Ganges, and the jaguar traverses with ease the largest streams in South America. The bear also and the bison cross the current of the Mississippi. The popular error that the common swine cannot escape by swimming when thrown into the water has been contradicted by several curious and well-authenticated instances during the floods in Scotland in 1829. One pig, only 6 months old, after having been carried down from Garmouth to the bar at the mouth of Spey, a distance of 1/4 of a mile, swam 4 miles eastward to Port Gordon and landed safe. 3 others of the same age and litter swam at the same time 5 miles to the west and landed at Blackhill. In an adult and wild state, these animals would doubtless have been more strong and active, and might, when hard-pressed, have performed a much longer voyage. Hence, islands remote from the continent may obtain inhabitants by casualties which, like the late storms in Mauritius, may only occur once in many centuries or thousands of years, under all the same circumstances. It is obvious that powerful tides, winds, and currents may sometimes carry along quadrupeds capable in like manner of preserving themselves for hours in the sea to very considerable distances, and in this way perhaps the tapir, Tapir indicus, may have become common to Sumatra and the Malayan Peninsula. To the elephant in particular, the power of crossing rivers is essential in a wild state, for the quantity of food which a herd of these animals consumes renders it necessary that they should be constantly moving from place to place. The elephant crosses the stream in 2 ways. If the bed of the river be hard and the water not of too great a depth, he fords it. But when he crosses great rivers such as the Ganges and the Niger, the elephant swims deep, so deep that the end of his trunk only is out of the water. For it is a matter of indifference to him whether his body be completely immersed, provided he can bring the tip of his trunk to the surface, so as to breathe the external air. Animals of the deer kind frequently take to the water, especially in the rutting season, when the stags are seen swimming for several leagues at a time from island to island in search of the does, especially in the Canadian lakes. And in some countries where there are islands near the seashore, they fearlessly enter the sea and swim to them. In hunting excursions in North America, the elk of that country is frequently pursued for great distances through the water. The large herbivorous animals, which are gregarious, can never remain long in a confined region, as they consume so much vegetable food. The immense herds of bisons, Bos americanus, which often in the great valleys of the Mississippi and its tributaries blacken the surface of the prairie lands, are continually shifting their quarters, followed by wolves, which prowl about in their rear. It is no exaggeration, says Mr. James, to assert that in one place, on the banks of the Platte, at least 10,000 bisons burst on our sight in an instant. In the morning we again sought the living picture, but upon all the plain, which last evening was so teeming with noble animals, not one remained. Migratory instincts. Besides the disposition common to the individuals of every species slowly to extend their range in search of food in proportion as their numbers augment, a migratory instinct often develops itself in an extraordinary manner, when, after an unusually prolific season, or upon a sudden scarcity of provisions, great multitudes are threatened by famine. It may be useful to enumerate some examples of these migrations, because they may put us upon our guard against attributing a high antiquity to a particular species merely because it is diffused over a great space. They show clearly how soon, in a state of nature, a newly created species might spread itself in every direction from a single point. In very severe winters, great numbers of the black bears of America migrate from Canada into the United States. But in milder seasons, when they have been well fed, they remain and hibernate in the north. The reindeer, which in Scandinavia can scarcely exist to the south of the 65th parallel, descends, in consequence of the greater coldness of the climate, to the 50th degree in Chinese Tartary, and often roves into a country of more southern latitude than any part of England. In Lapland and other high latitudes, the common squirrels, whenever they are compelled by want of provisions to quit their usual abodes, migrate in amazing numbers and travel directly forwards, allowing neither rocks nor forests, nor the broadest waters to turn them from their course. Great numbers are often drowned in attempting to pass friths and rivers. In like manner, the small Norway rat sometimes pursues its migrations in a straight line across rivers and lakes. And Pennant informs us that when the rats in Kamchatka become too numerous, they gather together in the spring, and proceed in great bodies westward, swimming over rivers, lakes, and arms of the sea. Many are drowned or destroyed by waterfowl or fish. As soon as they have crossed the river Peginsk, at the head of the gulf of the same name, they turn southward and reach the rivers of Judoma and Okhotsk by the middle of July, a district more than 800 miles distant from their point of departure. The lemmings also, a small kind of rat, are described as natives of the mountains of Kolin in Lapland, and once or twice in a quarter of a century they appear in vast numbers advancing along the ground and devouring every green thing. Innumerable bands march from the Kolin through the Norland and Finnmark to the Western Ocean, which they immediately enter, and after swimming about for some time, perish. Other bands take their route through Swedish Lapland to the Bothian Gulf, where they are drowned in the same manner. They are followed in their journeys by bears, wolves, and foxes, which prey upon them unceasingly. They generally move in lines, which are about 3 feet from each other, and exactly parallel, going directly forward through rivers and lakes, and when they meet with stacks of hay or corn, gnawing their way through them instead of passing round. These excursions usually precede a rigorous winter, of which the lemmings seem in some way forewarned. Vast troops of wild ass or onagar of the ancients, which inhabit the mountainous deserts of Great Tartary, feed during the summer in the tracts east and north of Lake Aral. In autumn they collect in herds of hundreds and even thousands and direct their course towards Persia, to enjoy a warm retreat during winter. Bands of 200 or 300 quaggas, a species of wild ass, are sometimes seen to migrate from the tropical plains of southern Africa to the vicinity of the Malalavin River. During their migrations, they are followed by lions who slaughter them night by night. The migratory swarms of the springbok or Cape antelope afford another illustration of the rapidity with which a species under certain circumstances may be diffused over a continent. When the stagnant pools of the immense deserts south of the Orange River dry up, which often happens after intervals of 3 or 4 years, myriads of these animals desert the parched soil and pour down like a deluge on the cultivated regions near the Cape. The havoc committed by them resembles that of the African locusts, and so crowded are the herds that the lion has been seen to walk in the midst of the compressed phalanx, with only as much room between him and his victims as the fears of those immediately around could procure by pressing outwards. Dr. Horsfield mentions a singular fact in regard to the geographical distribution of the Medeos melicepts, an animal intermediate between the polecat and the badger. It inhabits Java, and is confined exclusively to those mountains which have an elevation of more than 7,000 feet above the level of the ocean. On these it occurs with the same regularity as many plants. The long extended surface of Java, abounding with conical points which exceeded this elevation, affords many places favorable for its resort. On ascending these mountains, the traveler scarcely fails to meet with this animal, which, from its peculiarities, is universally known to the inhabitants of these elevated tracts, while to those of the plains it is as strange to an animal from a foreign country. In my visits to the mountainous districts, I uniformly met with it, and, as far as the information of the natives can be relied on, it is found on all the mountains. Now, if asked to conjecture how the Medus arrived at the elevated regions of each of these isolated mountains, we might say that before the island was peopled by men, by whom their numbers are now thinned, they may occasionally have multiplied so as to be forced to collect together and migrate, in which case, notwithstanding the slowness of their motions, some few would succeed in reaching another mountain, some 20 or even perhaps 50 miles distant. For although the climate of the hot intervening plains would be unfavorable to them, they might support it for a time, and would find there abundance of insects on which they feed. Volcanic eruptions which at different times have covered the summits of some of those lofty cones with sterile sand and ashes may have occasionally contributed to force on these migrations. End of section 86.
Chapter 38, Part 2 of Principles of Geology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Principles of Geology by Charles Lyell. Chapter 38, Laws which regulate the geographical distribution of species, continued, Part 2. Drifting of animals on ice floes. The power of the terrestrial mammalia to cross the sea is very limited, and it was before stated that the same species is scarcely ever common to districts widely separated by the ocean. If there be some exceptions to this rule, they generally admit of explanation, for there are natural means whereby some animals may be floated across the water, and the sea may, in the course of ages, wear a wide passage through a neck of land, leaving individuals of a species on each side of the new channel. Polar bears are known to have been frequently drifted on the ice from Greenland to Iceland. They can also swim to considerable distances, for Captain Parry, on the return of his ships through Barrow Straits, met with a bear swimming in the water about midway between the shores, which were about 40 miles apart, and where no ice was in sight. Near the east coast of Greenland, observes Scoresby, there have been seen on the ice in such quantities that they were compared to flocks of sheep on a common, and they are often found on field ice above 200 miles from the shore. Wolves, in the Arctic regions, often venture upon the ice near the shore, for the purpose of preying upon young seals which they surprise when asleep. When these ice floes get detached, the wolves are often carried out to sea, and though some may be drifted to islands or continents, the greater part of them perish, and have been often heard in this situation howling dreadfully as they die by famine. During the short summer which visits Melville Island, various plants push forth their leaves and flowers the moment the snow is off the ground, and form a carpet spangled with the most lively colors. These secluded spots are reached annually by herds of musk oxen and reindeer, which travel immense distances over dreary and desolate regions to graze undisturbed on these luxuriant pastures. The reindeer often pass along in the same manner by the chain of these Aleutian islands from Bering Strait to Kamchatka, subsisting on the moss found in these islands during the passages. But the musk ox, notwithstanding its migratory habits and its long journeys over the ice, does not exist either in Asia or Greenland. On floating islands of driftwood. Within the tropics there are no ice floes, but, as if to compensate for that mode of transportation, there are floating islets of matted trees, which are often borne along through considerable spaces. These are sometimes seen sailing at the distance of 50 or 100 miles from the mouth of the Ganges, with living trees standing erect upon them. The Amazon, the Congo, and the Orinoco also produce these verdant rafts, which are formed in the manner already described when speaking of the great raft of the Atchafalaya, an arm of the Mississippi, where a natural bridge of timber, 10 miles long and more than 200 yards wide, existed for more than 40 years, supporting a luxuriant vegetation and rising and sinking with the water which flowed beneath it. On these green isles of the Mississippi, observes Maltbrun, young trees take root, and the pistia and nenuphar display their yellow flowers. Serpents, birds, and the cayman alligator come to repose there, and all are sometimes carried to the sea and engulfed in its waters. Spix and Martius relate that, during their travels in Brazil, they were exposed to great danger while ascending the Amazon in a canoe from the vast quantity of driftwood constantly propelled against them by the current, so much so that their safety depended on the crew being always on the alert to turn aside the trunks of trees with long poles. The tops alone of some trees appeared above water, others had their roots attached to them with so much soil that they might be compared to floating isles. On these, say the travellers, we saw some very singular assemblages of animals, pursuing peacefully their uncertain way in strange companionship. On one raft were several grave-looking storks, perched by the side of a party of monkeys, who made comical gestures and burst into loud cries on seeing the canoe. On another was seen a number of ducks and divers, sitting by a group of squirrels. Next came down, upon the stem of a large rotten cedar tree, an enormous crocodile, by the side of a tiger-cat, both animals regarding each other with hostility and mistrust, but the saurian being evidently most at his ease, as conscious of his superior strength. Similar green rafts, principally composed of canes and brushwood, are called camelotes on the Parana in South America, and they are occasionally carried down by inundations, bearing on them the tiger, cayman, squirrels, and other quadrupeds, which are said to be always terror-stricken on their floating habitation. No less than 4 tigers, pumas, were landed in this manner in one night in Montevideo, latitude 35 south, to the great alarm of the inhabitants, who found them prowling about the streets in the morning. In a memoir lately published, a naval officer relates that, as he returned from China by the Eastern Passage, he fell in among the Moluccas with several small floating islands of this kind, covered with mangrove trees interwoven with underwood. The trees and shrubs retained their verdure, receiving nourishment from a stratum of soil which formed a white beach round the margin of each raft, where it was exposed to the washing of the waves and the rays of the sun. The occurrence of soil in such situations may easily be explained, for all the natural bridges of timber which occasionally connect the islands of the Ganges, Mississippi, and other rivers with their banks are exposed to floods of water densely charged with sediment. Captain W. H. Smith informs me that when cruising in the Cornwallis amidst the Philippine Islands, he has more than once seen, after those dreadful hurricanes called typhoons, floating masses of wood, with trees growing upon them, and ships have sometimes been in imminent peril, as often as these islands were mistaken for terra firma, when, in fact, they were in rapid motion. It is highly interesting to trace, in imagination, the effects of the passage of these rafts from the mouth of a large river to some archipelago, such as those in the South Pacific, raised from the deep, in comparatively modern times, by the operations of the volcano and the earthquake, and the joint labors of coral animals and testacea. If a storm arise, and the frail vessel be wrecked, still many a bird and insect may succeed in gaining, by flight, some island of the newly formed group, while the seeds and berries of herbs and shrubs, which fall into the waves, may be thrown upon the strand. But if the surface of the deep be calm, and the rafts are carried along by a current, or wafted by some slight breath of air fanning the foliage of the green trees, it may arrive, after a passage of several weeks, at the bay of an island, into which its plants and animals may be poured out as from an ark, and thus a colony of several hundred new species may at once be naturalized. The reader should be reminded that I merely advert to the transportation of these rafts as of an extremely rare and accidental occurrence, but it may account, in tropical countries, for some of the rare exceptions to the general law of the confined range of mammiferous species. Migrations of the Cetacea. Many of the Cetacea, the whales of the northern seas, for example, are found to desert one tract of the sea and to visit another very distant, when they are urged by want of food or danger. The seals also retire from the coast of Greenland in July, return again in September, and depart again in March, to return in June. They proceed in great droves northward, directing their course where the sea is most free of ice, and are observed to be extremely fat when they set out on this expedition, and very lean when they come home again. Species of the Mediterranean, Black Sea, and Caspian identical. Some naturalists have wondered that the sea calves, dolphins, and other marine mammalia of the Mediterranean and Black Sea should be identical with those found in the Caspian, and among other fanciful theories, they have suggested that they may dive through subterranean conduits and thus pass from one sea into the other. But as the occurrence of wolves and other noxious animals, on both sides of the British Channel, was adduced, by Verstegen and Deschmarest, as one of many arguments to prove that England and France were once united, so the correspondence of the aquatic species of the inland seas of Asia with those of the Black Sea tend to confirm the hypothesis, for which there are abundance of independent geological data, that those seas were connected together by straits at no remote period in the earth's history. Geographical distribution and migrations of birds. I shall now offer a few observations on some of the other divisions of the animal kingdom. Birds, notwithstanding their great locomotive powers, form no exception to the general rules already laid down, but in this class, as in plants and terrestrial quadrupeds, different groups of species are circumscribed within definite limits. We find, for example, one assemblage in the Brazils, another in the same latitudes in Central Africa, another in India, and a fourth in New Holland. Of 26 different species of land birds found in the Galapagos archipelago, all, with the exception of one, are distinct from those inhabiting other parts of the globe. And in other archipelagos, a single island sometimes contains a species found in no other spot on the whole earth, as is exemplified in some of the parrot tribes. In this extensive family, which are, with few exceptions, inhabitants of tropical regions, the American group has not one in common with the African, nor either of these with the parrots of India. Another illustration is afforded by that minute and beautiful tribe, the hummingbirds. The whole of them are, in the first place, peculiar to the New World, but some species are confined to Mexico, while others exist only in some of the West India Islands, and have not been found elsewhere in the Western Hemisphere. Yet there are species of this family which have a vast range, as the Trochilus flammiformes, or Melassuga kingi, which is found over a space of 2,500 miles on the west coast of South America, from the hot dry country of Lima to the humid forests of Tierra del Fuego. Captain King, during his survey in the years 1826–30, found this bird at the Straits of Magellan in the month of May, the depth of winter, sucking the flowers of a large species of fuchsia then in bloom in the midst of a shower of snow. The ornithology of our own country affords one well-known and striking exemplification of the law of a limited specific range, for the common grouse, Tetrascotius, occurs nowhere in the known world except in the British Isles. Some species of the vulture tribe are said to be cosmopolites, and the common wild goose, Ancerleseus lin, if we may believe some ornithologists, is a general inhabitant of the globe, being met with from Lapland to the Cape of Good Hope, frequent in Arabia, Persia, China, and Japan, and in the American continent from Hudson's Bay to South Carolina. An extraordinary range has also been attributed to the nightingale, which extends from Western Europe to Persia, and still further. In a work entitled Spetio Comparatavio, by Charles Bonaparte, many species of birds are enumerated as common to Rome and Philadelphia. The greater part of these are migratory, but some of them, such as the long-eared owl, Strix autus, are permanent in both countries. The correspondence of the ornithological fauna of the eastern and western hemispheres increases considerably, as might have been anticipated, in high northern latitudes. Their facilities of diffusion. In parallel zones of the northern and southern hemispheres, a great general correspondence of form is observable, both in the aquatic and terrestrial birds, but there is rarely any specific identity, and this phenomenon is truly remarkable, when we recollect the readiness with which some birds, not gifted with great powers of flight, shift their quarters to different regions, and the facility with which others, possessing great strength of wing, perform their aerial voyage. Some migrate periodically from high latitudes to avoid the cold of winter and the accompaniment of cold, scarcity of insects and vegetable food. Others, it is said, for some particular kinds of nutriment required for rearing their young. For this purpose they often traverse the ocean for thousands of miles and recross it at other periods with equal security. Periodical migrations, no less regular, are mentioned by Humboldt of many American waterfowl, from one part of the tropics to another, in a zone where there is the same temperature throughout the year. Immense flights of ducks leave the valley of the Orinoco, when the increasing depths of its waters and the flooding of its shore prevent them from catching fish, insects, and aquatic worms. They then betake themselves to the Rio Negro and Amazon, having passed from the 8th and 3rd degrees of north latitude to the 1st and 4th of south latitude, directing their course south-southeast. In September, when the Orinoco decreases and re-enters its channel, these birds return northward. The insectivorous swallows which visit our island would perish during winter if they did not annually repair to warmer climes. It is supposed that in these aerial excursions the average rapidity of their flight is no less than 50 miles an hour, so that, when aided by the wind, they soon reach warmer latitudes. Spallanzani calculated that the swallow can fly at the rate of 92 miles an hour, and conceived that the rapidity of the swift might be 3 times greater. The rate of flight of the eider duck, Anas mollissima, is said to be 90 miles an hour, and Bachmann says that the hawk, wild pigeon, Colomba migratoria, and several species of wild ducks in North America fly at the rate of 40 miles an hour, or nearly 1,000 miles in 24 hours. When we reflect how easily different species, in a great lapse of ages, may be each overtaken by gales and hurricanes, and abandoning themselves to the tempest be scattered at random throughout various regions of the earth's surface, where the temperature of the atmosphere, the vegetation, and the animal productions might be suited to their wants, we shall be prepared to find some species capriciously distributed, and to be sometimes unable to determine the native countries of each. Captain Smith informs me that when engaged in his survey of the Mediterranean, he encountered a gale in the Gulf of Lyons, at a distance of between 20 and 30 leagues from the coast of France, which bore along many land birds of various species, some of which alighted on the ship, while others were thrown with violence against the sails. In this manner islands become tenanted by species of bird inhabiting the nearest mainland. Geographical distribution and dissemination of reptiles. A few facts respecting the third great class of vertebrated animals will suffice to show that the plan of nature in regard to their location on the globe is perfectly analogous to that already exemplified in other parts of the organic creation, and has probably been determined by similar causes. Habitations of reptiles. Of the great saurians, the gavials which inhabit the Ganges differ from the caiman of America or the crocodile of the Nile. The monitor of New Holland is specifically distinct from the Indian species, these latter, again, from the African, and all from their congeners in the New World. So in regard to snakes, we find the boa of America represented by the python, a different, though nearly allied genus in India. America is the country of the rattlesnake, Africa of the cerastus, and Asia of the hooded snake or cobra di capello. The amphibious genera Siren and Monopalma belong to North America, possessing both lungs and gills, and respiring at pleasure either air or water. The only analogous animal of the Old World is the Proteus arganius of the lakes of Lower Carnolia, and the grotto of Edelsberg between Trieste and Vienna. There is a legend that St. Patrick expelled all reptiles from Ireland, and certain it is that none of the 3 species of snakes common in England, nor the toad, have been observed there by naturalists. They have our common frog and our water newt, and according to Ray, Quad 264, the green lizard, Lacerta viridis. Migrations of the larger reptiles. The range of the large reptiles is, in general, quite as limited as that of some orders of the terrestrial mammalia. The great saurians sometimes cross a considerable tract in order to pass from one river to another, but their motions by land are generally slower than those of quadrupeds. By water, however, they may transport themselves to distant situations more easily. The larger alligator of the Ganges sometimes descends beyond the brackish waters of the delta into the sea, and in such cases it might chance to be drifted away by a current, and survive till it reached a shore at some distance, but such casualties are probably very rare. Turtles migrate in great droves from one part of the ocean to another during the ovipositing season, and they find their way annually to the island of Ascension, from which the nearest land is about 800 miles distant. Dr. Fleming mentions that an individual of the hawksbill turtle, Chelonia imbricata, so common in the American seas, has been taken at Papastor, one of the West Zetland Islands, and according to Sibold, the same animal came into Orkney. Another was taken, in 1774, in the Severn, according to Turton. 2 instances also of the occurrence of the leathern tortoise, C. coriacea, on the coast of Cornwall, in 1756, are mentioned by Borlase. These animals of more southern seas can be considered only as stragglers, attracted to our shores during uncommonly warm seasons by an abundant supply of food, or carried by the Gulf Stream, or driven by storms to high latitudes. Some of the smaller reptiles lay their eggs on aquatic plants, and these must often be borne rapidly by rivers and conveyed to distant regions in a manner similar to the dispersion of seeds before adverted to. But that the larger ophidians may be themselves transported across the seas is evident from the following most interesting account of the arrival of one at the island of St. Vincent. It is worthy of being recorded, says Mr. Gilding, that a noble species of the boa constrictor was lately conveyed to us by the currents, twisted round the trunk of a large sound cedar tree, which had probably been washed out of the bank by the floods of some great South American river, while its huge folds hung on the branches as it waited for its prey. The monster was fortunately destroyed after killing a few sheep, and his skeleton now hangs before me in my study, putting me in mind how much reason I might have had to fear in my future rambles through the forests of St. Vincent, had this formidable reptile been a pregnant female and escaped to a safe retreat. End of Chapter 38, Part 2. Recording by Todd.
Chapter 39, Part 1 of Principles of Geology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Principles of Geology by Charles Lyell. Section 88. Chapter 39. Laws which regulate the geographical distribution of species continued. Part 1. Geographical distribution and migration of fish, of testacea, of zoophytes, distribution of insects, migratory instincts of some species. Certain types characterize particular countries. Their means of dissemination. Geographical distribution and diffusion of man. Speculations as to the birthplace of the human species. Progress of human population. Drifting of canoes to vast distances. On the involuntary influence of man in extending the range of many other species. Geographical distribution and migrations of fish. Although we are less acquainted with the habitations of marine animals than with the grouping of the terrestrial species before described, yet it is well ascertained that their distribution is governed by the same general laws. The testimony borne by Messrs. Perron and Lesueur to this important fact is remarkably strong. These eminent naturalists, after collecting and describing many thousands of species of marine animals, which they brought to Europe from the southern hemisphere, insist most emphatically on their distinctness from those north of the equator, and this remark they extend to animals of all classes, from those of a more simple to those of a more complex organization, from the sponges and medusae to the cetacea. Among all those which we have been able to examine, say they, with our own eyes, or with regard to which it has appeared to us possible to pronounce with certainty, there is not a single animal of the southern regions which is not distinguished by essential characters from the analogous species in the northern seas. On comparing the freshwater fish of Europe and North America, Sir John Richardson remarks that the only species which is unequivocally common to the two continents is the pike, Esox lucius, and it is curious that this fish is unknown to the westward of the Rocky Mountains, the very coast which approaches nearest to the old continent. According to the same author, the genera of freshwater fish in China agree closely with those of the peninsula of India, but the species are not the same. As in the distribution, he adds, of marine fish, the interposition of a continent stretching from the tropics far into the temperate or colder parts of the ocean separate different ichthyological groups. So with respect to the freshwater species, the intrusion of arms of the sea running far to the northwards, or the interposition of a lofty mountain chain, effects the same thing. The freshwater fish of the Cape of Good Hope and the South American ones are different from those of India and China, etc. Cuvier and Valenciennes, in their Histoire des Poissons, observe that very few species of fish cross the Atlantic. Although their statement is correct, it is found that a great many species are common to the opposite sides of the Indian Ocean, inhabiting alike the Red Sea, the eastern coast of Africa, Madagascar, the Mauritius, the Indian Ocean, the southern seas of China, the Malay archipelago, the northern coasts of Australia, and the whole of Polynesia. This very wide diffusion, says Sir J. Richardson, may have been promoted by chains of islands running east and west, which are wanting in the deep Atlantic. An archipelago extending far in longitude favors the migration of fish by multiplying the places of deposit for spawn along the shores of islands and on intervening coral banks, and in such places also fish find their appropriate food. The flying fish are found, some stragglers excepted, only between the tropics. In receding from the line, they never approach a higher latitude than the 40th parallel. The course of the Gulf Stream, however, and the warmth of its water, enable some tropical fish to extend their habitations far into the temperate zone. Thus the chaetodons, which abound in the seas of hot climates, are found among the Bermudas on the 32nd parallel, where they are preserved in basins enclosed from the sea, as an important article of food for the garrison and inhabitants. Other fish, following the direction of the same great current, range from the coast of Brazil to the banks of Newfoundland. All are aware that there are certain fish of passage which have their periodical migrations, like some tribes of birds. The salmon, towards the season of spawning, ascends the rivers for hundreds of miles, leaping up the cataracts which it meets in its course, and then retreats again into the depths of the ocean. The herring and the haddock, after frequenting certain shores in vast shoals for a series of years, desert them again and resort to other stations, followed by the species which prey on them. Eels are said to descend into the sea for the purpose of producing their young, which are seen returning into the fresh water by myriads, extremely small in size, but possessing the power of surmounting every obstacle which occurs in the course of a river, by applying their slimy and glutinous bodies to the surface of rocks, or the gates of a lock, even when dry, and so climbing over it. Before the year 1800, there were no eels in Lake Vänern, the largest inland lake in Sweden, which discharges its waters by the celebrated cataracts of Trollhättan. But I am informed by Professor Nilsson that since the canal was opened, uniting the river Gotha with the lake by a series of 9 locks, each of great height, eels have been observed in abundance in the lake. It appears, therefore, that though they were unable to ascend the falls, they have made their way by the locks, by which in a very short space of difference of level of 114 feet is overcome. Gmelin says that the ansares, wild geese, ducks, and others, subsist in their migrations on the spawn of fish, and that oftentimes, when they void the spawn, 2 or 3 days afterwards the eggs retain their vitality unimpaired. When there are many disconnected freshwater lakes in a mountainous region, at various elevations, each remote from the other, it has often been deemed inconceivable how they could all become stocked with fish from one common source. but it has been suggested that the minute eggs of these animals may sometimes be entangled in the feathers of waterfowl. These, when alight to wash and plume themselves in the water, may often unconsciously contribute to propagate swarms of fish, which, in due season, will supply them with food. Some of the water beetles also, as the Dyticidae, are amphibious, and in the evening quit their lakes and pools, and, flying in the air, transport the minute ova of fishes to distant waters. In this manner some naturalists account for the fry of fish appearing occasionally in small pools caused by heavy rains. But the showers of small fish, stated in so many accounts to have fallen from the atmosphere, require further investigation. Geographical distribution and migrations of Testacea. The Testacea, of which so great a variety of species occurs in the sea, are a class of animals of peculiar importance to the geologist, because their remains are found in strata of all ages, and generally in a higher state of preservation than those of other organic beings. Climate has a decided influence on the geographical distribution of species in this class. But as there is much greater uniformity of temperature in the waters of the ocean than in the atmosphere which invests the land, the diffusion of marine mollusks is on the whole more extensive. Some forms attain their fullest development in warm latitudes, and are often exclusively confined to the torrid zone, as Nautilus, Harpa, Terebellum, Pyramidella, Delphinula, Aspergillum, Tridacna, Cuculea, Crassitella, Corbus, Perna, and Plicatula. Other forms are limited to one region of the sea, as the Trigonia to parts of Australia, and the Concholepas to the western coast of South America. The marine species inhabiting the ocean on the opposite sides of the narrow isthmus of Panama are found to differ almost entirely, as we might have anticipated, since a West Indian mollusk cannot enter the Pacific without coasting round South America and passing through the inclement climate of Cape Horn. The continuity of the existing lines of continent from north to south prevents any one species from belting the globe, or from following the direction of the isothermal lines. Currents also flowing permanently in certain directions, and the influx at certain points of great bodies of fresh water, limit the extension of many species. Those which love deep water are arrested by shoals. Others, fitted for shallow seas, cannot migrate across unfathomable abysses. The nature also of the ground has an important influence on the testaceous fauna, both on the land and beneath the waters. Certain species prefer a sandy, others a gravelly, and some a muddy sea bottom. On the land, limestone is of all rocks the most favorable to the number and propagation of species of the genera Helix, Clausilia, Balemus, and others. Professor E. Forbes has shown as the result of his labors in dredging the Aegean Sea that there are 8 well-marked regions of depth, each characterized by its peculiar testaceous fauna. The first of these, called the littoral zone, extends to a depth of 2 fathoms only, but this narrow belt is inhabited by more than 100 species. The second region, of which 10 fathoms is the inferior limit, is almost equally populous, and a copious list of species is given as characteristic of each region down to the 7th, which lies between the depths of 80 and 105 fathoms. All the inhabited space below this being included in the 8th province, where no less than 65 species of Testacea have been taken. The majority of the shells in this lowest zone are white or transparent. Only 2 species of mollusca are common to all the 8 regions, namely Archelactia and Cerithium lima. Great range of some provinces and species. In Europe, conchologists distinguish between the Arctic fauna, the southern boundary of which corresponds with the isothermal line at 32 degrees Fahrenheit, and the Celtic, which, commencing with that limit as its northern frontier, extends southward to the mouth of the English Channel and Cape Finisterre in France. From that point begins the Lusitanian fauna, which, according to the recent observations of Mr. Andrew, 1852, ranges to the Canary Islands. The Mediterranean province is distinct from all those above enumerated, although it has some species in common with each. The Indo-Pacific region is by far the most extensive of all. It reaches from the Red Sea and the eastern coast of Africa to the Indian archipelago and adjoining parts of the Pacific Ocean. To the geologist, it furnishes a fact of no small interest by teaching us that one group of living species of mollusca may prevail throughout an area exceeding in magnitude the utmost limits we can as yet assign to any assemblage of contemporaneous fossil species. Mr. Cumming obtained more than 100 species of shells from the eastern coast of Africa, identical with those collected by himself at the Philippines and in the eastern coral islands of the Pacific Ocean, a distance equal to that from pole to pole. Certain species of the genus Eanthina have a very wide range, being common to seas north and south of the equator. They are all provided with a beautifully contrived float, which renders them buoyant, facilitating their dispersion, and enabling them to become active agents in disseminating other species. Captain King took a specimen of Eanthina fragilis, alive, a little north of the equator, so loaded with barnacles, pentelasmus, and their ova that the upper part of its shell was invisible. The rock whelk, Purpura lapillus, a well-known British univalve, inhabits both the North Atlantic and North Pacific. Helix putris, Succinia putris, so common in Europe, where it reaches from Norway to Italy, is also said to occur in the United States and in Newfoundland. As this animal inhabits constantly the borders of pools and streams where there is much moisture, it is not impossible that different waterfowl have been the agents of spreading some of its minute eggs, which may have been entangled in their feathers. The freshwater snail, Limnaeus palustris, so abundant in English ponds, ranges uninterruptedly from Europe to Kashmir, and thence to the eastern parts of Asia. Helix aspersa, one of the commonest of our larger land shells, is found in St. Helena and other distant countries. Some conchologists have conjectured that it was accidentally imported into St. Helena in some ship, for it is an eatable species, and these animals are capable of retaining life during long voyages without air or nourishment. Perhaps no species has a better claim to be called cosmopolite than one of our British bivalves, Saxicava rugosa. It is spread all over the North Polar Seas, and ranges in one direction through Europe to Senegal, occurring on both sides of the Atlantic, while in another it finds its way into the North Pacific, and thence to the Indian Ocean. Nor do its migrations cease until it reaches the Australian seas. A British brachiopod named Terebratula, caput serpentis, is common, according to Professor E. Forbes, to both sides of the North Atlantic, and to the South African and Chinese seas. Confined range of other species. Mr. Lowe, in a memoir published in the Cambridge Transactions in 1834, enumerates 71 species of land mollusca collected by him in the islands of Madeira and Porto Santo, 60 of which belong to the genus Helix alone, including as subgenera Bolemus and Achatina, and excluding Vitrina and Clausilia. 44 of these are new. It is remarkable that very few of the above-mentioned species are common to the neighboring archipelago of the Canaries, but it is a still more striking fact that of the 60 species of the 3 genera above mentioned, 31 are natives of Porto Santo, whereas in Madeira, which contains 10 times the superficies, were found but 29. Of these, only 4 were common to the 2 islands, which are separated by a distance of only 12 leagues, and 2 even of these 4, namely Helix, Rhodostoma, and H. ventrosa, are species of general diffusion, common to Madeira, the Canaries, and the south of Europe. The confined range of these mollusks may easily be explained if we admit that species have only one birthplace, and the only problem to be solved would relate to the exceptions, to account for the dissemination of some species throughout several islands and the European continent. May not the eggs, when washed into the sea by the undermining of cliffs or blown by a storm from the land, float uninjured to a distant shore? Their mode of diffusion. Notwithstanding the proverbial slow motion of snails and mollusks in general, and although many aquatic species adhere constantly to the same rock for their whole lives, they are by no means destitute of provision for disseminating themselves rapidly over a wide area. Some mollusca, says Professor E. Forbes, migrate in their larva state, for all of them undergo a metamorphosis either in the egg or out of the egg. The gasteropoda commence life under the form of a small spiral shell, and an animal furnished with ciliated wings, or lobes, like a pteropod, by means of which it can swim freely, and in this form can migrate with ease through the sea. We are accustomed to associate in our minds the idea of the greatest locomotive powers with the most mature and perfect state of each species of invertebrate animal, especially when they undergo a series of transformations. But in all the mollusca, the reverse is true. The young fry of the cockle, for example, Cardium, possesses, when young or in the larva state, an apparatus which enables them both to swim and to be carried along easily by a marine current. These small bodies here represented, which bear a considerable resemblance to the fry of the univalve or gasteropodous shells above mentioned, are so minute at first as to be just visible to the naked eye. They begin to move about from the moment they are hatched by means of the long cilia placed on the edges of the locomotive disc or velum. This disc shrinks up as they increase in size, and gradually disappears, no trace of it being visible in the perfect animal. Some species of shell-bearing mollusca lay their eggs in a sponge-like nidus, wherein the young remain enveloped for a time after their birth, and this buoyant substance floats far and wide as readily as seaweed. The young of other viviparous tribes are often borne along entangled in seaweed. Sometimes they are so light that, like grains of sand, they can be easily moved by currents. Balaene and Serpulae are sometimes found adhering to floating coconuts, and even to fragments of pumice. In rivers and lakes, on the other hand, aquatic univalves usually attach their eggs to leaves and sticks which have fallen into the water, and which are liable to be swept away during floods, from tributaries to the main streams, and from thence to all parts of the same basins. Particular species may thus migrate during one season from the headwaters of the Mississippi or any other great river to countries bordering the sea, at the distance of many thousand miles. An illustration of the mode of attachment of these eggs will be seen in the annexed cut, Figure 100. The habit of some testacea to adhere to floating wood is proved by their fixing themselves to the bottoms of ships. By this mode of conveyance, Mytilus polymorphus, previously known only in the Danube and Volga, may have been brought to the commercial docks in the Thames, and to Hamburg, where the species is now domiciled. But Mr. Gray suggests that as the animal is known to have the faculty of living for a very long time out of water, it is more probable that it was brought in Russian timber than borne uninjured through the salt water at the bottom of a vessel. A lobster, Astacus marinus, was lately taken alive, covered with living mussels, Mytilus edulis, and a large female crab, Cancer pagurus, covered with oysters, and bearing also Anomia ephipium and actinae, was taken in April 1832 off the English coast. The oysters, 7 in number, include individuals of 6 years' growth, and the 2 largest are 4 inches long and 3 inches and a half broad. Both the crab and the oysters were seen alive by Mr. Robert Brown. From this example we learn the manner in which oysters may be diffused over every part of the sea where the crab wanders, and if they are at length carried to a spot where there is nothing but fine mud, the foundation of a new oyster bank may be laid on the death of the crab. In this instance, the oysters survived the crab many days, and were killed at last only by long exposure to the air. Geographical distribution and migrations of zoophytes. Zoophytes are very imperfectly known, but there can be little doubt that each maritime region possesses species peculiar to itself. The madrepores, or lamelliferous polyparia, are found in their fullest development only in the tropical seas of Polynesia and the East and West Indies, and this family is represented only by a few species in our seas. The zoophytes of the Mediterranean, according to Ehrenberg, differ almost entirely from those of the Red Sea, although only 70 miles distant. Out of 120 species of Anthrozoa, only 2 are common to both seas. Perron and Lesueur, after studying the Holothuriae, Medusae, and other cogeners of delicate and changeable forms, came to the conclusion that each kind has its place of residence determined by the temperature necessary to support its existence. Thus, for example, they found the abode of Pyrosoma atlantica to be confined to one particular region of the Atlantic Ocean. Let us now inquire how the transportation of zoophytes from one part of the globe to another is effected. Many of them, as in the families Flustra and Sertularia, attach themselves to seaweed, and are occasionally drifted along with it. Many fix themselves to the shells of mollusca, and are thus borne along by them to short distances. Others, like some species of sea pens, float about in the ocean, and are usually believed to possess powers of spontaneous motion. But the most frequent mode of transportation consists in the buoyancy of their eggs, or certain small vesicles, which are detached and are capable of becoming the foundation of a new colony. These gems, as they are called, have in many instances a locomotive power of their own, by which they proceed in a determinate direction for several days after separation from the parent. They are propelled by means of numerous short threads or ciliae, which are in constant and rapid vibration, and when thus supported in the water, they may be borne along by currents to a great distance. That some zoophytes adhere to floating bodies is proved by their being found attached to the bottoms of ships, like certain testacea before alluded to. Geographical distribution and migration of insects. Before I conclude this sketch of the manner in which the habitable parts of the earth are shared out among particular assemblages of organic beings, I must offer a few remarks on insects, which, by their numbers and the variety of their powers and instincts, exert a prodigious influence in the economy of animate nature. As a large portion of these minute creatures are strictly dependent for their subsistence on certain species of vegetables, the entomological provinces must coincide in considerable degree with the botanical. All the insects, say Littrell, brought from the eastern parts of Asia and China, whatever be their latitude and temperature, are distinct from those of Europe and of Africa. The insects of the United States, although often approaching very close to our own, are, with very few exceptions, specifically distinguishable by some characters. In South America, the equinoctial lands of New Granada and Peru on the one side, and of Guiana on the other, contain for the most part distinct groups, the Andes forming the division, and interposing a narrow line of severe cold between climates otherwise very similar. Migratory instincts. Nearly all the insects of the United States and Canada differ specifically from the European, while those of Greenland appear to be in a great measure identical with our own. Some insects are very local, while a few, on the contrary, are common to remote countries between which the torrid zone and the ocean intervene. Thus our painted lady butterfly, Vanessa cardui, reappears at the Cape of Good Hope and in New Holland and Japan, with scarcely a varying streak. The same species is said to be one of the few insects which are universally dispersed over the earth, being found in Europe, Asia, Africa, and America, and its wide range is the more interesting because it seems explained by its migratory instinct, seconded, no doubt, by a capacity enjoyed by few species of enduring a great diversity of temperature. A vast swarm of this species, forming a column from 10 to 15 feet broad, was a few years since observed in the Canton de Vaud. They traversed the country with great rapidity from north to south, all flying onwards in regular order, close together, and not turning from their course on the approach of other objects. Professor Bonelli of Turin observed in March of the same year a similar swarm of the same species also directing their flight from north to south, in Piedmont, in such immense numbers that at night the flowers were literally covered with them. They had been traced from Coney, Racone, Susa, etc. A similar flight at the end of the last century is recorded by M. Leach in the Memoirs of the Academy of Turin. The fact is the more worthy of notice, because the caterpillars of this butterfly are not gregarious, but solitary from the moment that they are hatched, and this instinct remains dormant, while generation after generation passes away till it suddenly displays itself in full energy when their numbers happen to be in excess. Not only peculiar species, but certain types distinguish particular countries, and there are groups, observes Kirby, which represent each other in distant regions, whether in their form, their functions, or in both. Thus the honey and wax of Europe, Asia, and Africa are in each case prepared by bees congenerous with our common hive bee, while in America this genus is nowhere indigenous, but is replaced by Melipona, Trigona, and Euglossa, and in New Holland by a still different but undescribed type. The European bee, Apis mellifica, although not a native of the New World, is now established both in North and South America. It was introduced into the United States by some of the early settlers, and has since overspread the vast forests of the interior, building hives in the decayed trunks of trees. The Indians, says Irving, consider them as the harbinger of the white man, as the buffalo is of the red man, and say that in proportion as the bee advances, the Indian and the buffalo retire. It is said, continues the same writer, that the wild bee is seldom to be met with at any great distance from the frontier, and that they have always been the heralds of civilization, preceding it as it advanced from the Atlantic borders. Some of the ancient settlers of the West even pretend to give the very year when the honeybee first crossed the Mississippi. The same species is now also naturalized in Van Diemen's Land and New Zealand. As almost all insects are winged, they can readily spread themselves wherever their progress is not opposed by uncongenial climates, or by seas, mountains, and other physical impediments. And these barriers they can sometimes surmount by abandoning themselves to violent winds, which, as I have before stated when speaking of the dispersion of seeds, may in a few hours carry them to very considerable distances. On the Andes, some sphinxes and flies have been observed by Humboldt at the height of 19,180 feet above the sea, and which appear to him to have been involuntarily carried into these regions by ascending currents of air. White mentions a remarkable shower of aphids, which seem to have emigrated with an east wind from the great hop plantations of Kent and Sussex, and blackened the shrubs and vegetables where they alighted at Selborne, spreading at the same time in great clouds all along the vale from Farnham to Alton. These aphids are sometimes accompanied by vast numbers of the common ladybird, Coccinella septempunctata, which feed upon them. It is remarkable, says Kirby, that many of the insects which are occasionally observed to emigrate, as for instance the libellulae, coccinellae, caribi, cicadae, etc., are not usually social insects, but seem to congregate like swallows, merely for the purpose of emigration. Here, therefore, we have an example of an instinct developing itself on certain rare emergencies, causing unsocial species to become gregarious and to venture sometimes even to cross the ocean. The armies of locusts which darken the air in Africa and traverse the globe from Turkey to our southern counties in England are well known to all. When the western gales sweep over the pampas, they bear along with them myriads of insects of various kinds. As a proof of the manner in which species may be thus diffused, I may mention that when the Creole frigate was lying in the outer roads off Buenos Aires in 1819, at the distance of 6 miles from the land, her decks and rigging were suddenly covered by thousands of flies and grains of sand. The sides of the vessel had just received a fresh coat of paint, to which the insects adhered in such numbers as to spot and disfigure the vessel, and to render it necessary partially to renew the paint. Captain W. H. Smith was obliged to repaint his vessel, the Adventure, in the Mediterranean, from the same cause. He was on his way from Malta to Tripoli, when a southern wind blowing from the coast of Africa, then 100 miles distant, drove such myriads of flies upon the fresh paint that not the smallest point was left unoccupied by insects. To the southward of the River Plate, off Cape St. Antonio, and at the distance of 50 miles from land, several large dragonflies alighted on the Adventure frigate during Captain King's late expedition to the Straits of Magellan. If the wind abates, when insects are thus crossing the sea, the most delicate species are not necessarily drowned, for many can repose without sinking on the water. The slender, long-leaded tipulae, having been seen standing on the surface of the sea, when driven out far from our coast, and took wing immediately on being approached. Exotic beetles are sometimes thrown on our shore, which revive after having been long drenched in sea-water, and the periodical appearance of some conspicuous butterflies among us, after being unseen some for 5, others for 50 years, has been ascribed, not without probability, to the agency of the winds. Inundations of rivers, observes Kirby, if they happen at any season except in the depths of winter, always carry down a number of insects, floating on the surface of bits of stick, weeds, etc., so that when the waters subside, the entomologist may generally reap a plentiful harvest. In the dissemination, moreover, of these minute beings, as in that of plants, the larger animals play their part. Insects are, in numberless instances, borne along in the coats of animals, or the feathers of birds, and the eggs of some species are capable, like seeds, of resisting the digestive powers of the stomach, and after they are swallowed with herbage, may be ejected again unharmed in the dung. End of section 88. Chapter 39, Part 2 of Principles of Geology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Principles of Geology by Charles Lyell. Section 89. Chapter 39. Laws which regulate the geographical distribution of species, continued. Part 2. Geographical distribution and diffusion of man. I have reserved for the last some observations on the range and diffusion of the human species over the earth, and the influence of man in spreading other animals and plants, especially the terrestrial. Many naturalists have amused themselves in speculating on the probable birthplace of mankind, the point from which, if we assume the whole human race to have descended from a single pair, the tide of immigration must originally have proceeded. It has always been a favorite conjecture that this birthplace was situated within or near the tropics, where perpetual summer reigns, and where fruits, herbs, and roots are plentifully supplied throughout the year. The climate of these regions, it has been said, is suited to a being born without any covering, and who had not yet acquired the arts of building habitations or providing clothes. Progress of human population. The hunter state, it has been argued, which Montesquieu placed the first, was probably only the second stage to which mankind arrived, since so many arts must have been invented to catch a salmon or a deer, that society could no longer have been in its infancy when they came into use. When regions where the spontaneous fruits of the earth abound became overpeopled, men would naturally diffuse themselves over the neighboring parts of the temperate zone, but a considerable time would probably elapse before this event took place, and it is possible, as a writer before cited observes, that in the interval before the multiplication of their numbers and their increasing wants had compelled them to emigrate, some arts to take animals were invented, but far inferior to what we see practiced at this day among savages. As their habitations gradually advanced into the temperate zone, the new difficulties they had to encounter would call forth by degrees the spirit of invention, and the probability of such inventions always rises with the number of people involved in the same necessity. A distinguished modern writer, who coincides for the most part in the views above mentioned, has introduced one of the persons in his second dialogue, as objecting to the theory of the human race having gradually advanced from a savage to a civilized state, on the ground that the first man must have inevitably been destroyed by the elements, or devoured by savage beasts, so infinitely his superiors in physical force. He then contends against the difficulty here started by various arguments, all of which perhaps superfluous. For if a philosopher is pleased to indulge in conjectures on this subject, why should he not assign, as the original seat of man, some of those large islands within the tropics, which are as free from large beasts of prey as Van Diemen's Land or Australia? Here man may have remained for a period peculiar to a single island, just as some of the large anthropomorphous species are now limited to one island within the tropics. In such a situation, the newborn race might have lived in security, though far more helpless than the New Holland savages, and might have found abundance of vegetable food. Colonies may afterwards have been sent forth from this mother country, and then the peopling of the earth may have proceeded according to the hypothesis before alluded to. To form a probable conjecture respecting the country from whence the early civilization of India was derived has been found almost as difficult as to determine the original birthplace of the human race. That the dawn of Oriental civilization did not arise within the limits of the tropics is the conclusion to which Baron William von Humboldt has come after much patient research into the diversities of the structure of language and their influence on the mental development of the human race. According to him, the ancient Zend country, from whence the spread of knowledge and the arts has been traced in a southeasterly direction, lay to the northwest of the upper Indus. As to the time of the first appearance of man upon the earth, if we are to judge from the discordance of opinion amongst celebrated chronologists, not even a rude approximation has yet been made towards determining a point of so much interest. The problem seems hitherto to have baffled the curiosity of the antiquary, if possible, more completely than the fixing on a geographical site for the original habitation of the ancestors of the human race. The Chevalier Bunsen, in his elaborate and philosophical work on ancient Egypt, has satisfied not a few of the learned by an appeal to monumental inscriptions still extant, that the successive dynasties of kings may be traced back without a break to Menes, and that the date of his reign would correspond with the year 3640 B.C. He supposes, at the same time, what is most reasonable, that the Egyptian people must have existed for a long period, probably at least for 5 centuries, and their earlier and less settled state before they reached the point of civilization at which Menes consolidated them into a great and united empire. This would carry us back to upwards of 4,000 years B.C., or to an epoch coincident with that commonly set down for the creation of the world, in accordance with computations founded on the combined ages of the successive antediluvian patriarchs. It follows that the same epoch of Menes is anterior by a great many centuries to the most ancient of the dates usually fixed upon for the Mosaic deluge. The fact that no record or tradition of any great and overwhelming flood has been detected in the mythology or monumental annals of the Egyptians will suggest many reflections to a geologist who has weighed well the evidence we possess of a variety of partial deluges, which have happened in districts not free, like Egypt, for the last 3,000 years, from earthquakes and other causes of great aqueous catastrophes. The tales and legends of calamitous floods preserved in Greece, Asia Minor, the southern shores of the Baltic, China, Peru, and Chile have, as we have seen, been all of them handed down to us by the inhabitants of regions in which the operation of natural causes in modern times, and the recurrence of a succession of disastrous floods, afford us data for interpreting the meaning of the obscure traditions of an illiterate age. In his learned treatise on ancient chronology, Dr. Hales has selected from a much greater number a list of no less than 120 authors, all of whom give a different period for the epoch of the creation of the world, the extreme range of difference between them amounting to no less than 3,268 years. It appears that even amongst authorities who in England are generally regarded as orthodox, there is a variance, not of years or of 1 or 2 centuries, but upwards of a millennium, according as they have preferred to follow the Hebrew or the Samaritan or the Greek versions of the Mosaic writings. Can we then wonder that they who decipher the monuments of Egypt, or the geologists who interpret the earth's autobiography, should arrive at views respecting the date of an ancient empire or the age of our planet irreconcilable with every one of these numerous and conflicting chronologies? The want of agreement amongst the learned in regard to the probable date of the deluge of Noah is a source of far greater perplexity and confusion than our extreme uncertainty as to the epoch of the creation, the deluge being a comparatively modern event, from which the repeopling of the earth and the history of the present races of mankind is made to begin. Naturalists have long felt that to render probable the received opinion that all the leading varieties of the human family have originally sprung from a single pair, a doctrine against which there appears to me to be no sound objection, a much greater lapse of time is required for the slow and gradual formation of races, such as the Caucasian, Mongolian, and Negro, that is embraced in any of our popular systems of chronology. The existence of 2 of those marked varieties above mentioned can be traced back 3,000 years before the present time, or to the paintings of pictures preserved in the tombs or on the walls of buried temples in Egypt. In these we behold the Negro and Caucasian physiognomies portrayed as faithfully and in as strong contrast as if the likeness of those races had been taken yesterday. When we consider, therefore, the extreme slowness of the changes which climate and other modifying causes have produced in modern times, we must allow for a vast series of antecedent ages, in the course of which the long-continued influence of similar external circumstances gave rise to peculiarities, probably increased in many successive generations, until they were fixed by hereditary transmission. The characteristic forms and features thus acquired by certain tribes may have been afterwards diffused by migration for a few centers over wide continental spaces. The theory, therefore, that all the races of man have come from one common stock receives support from every investigation which forces us to expand our ideas of the duration of past time, or which multiplies the number of years that have passed away since the origin of man. Hitherto, geology has neither enlarged nor circumscribed the human period, but simply proved that in the history of animated nature it is comparatively modern, or the last of a long series of antecedent epochs in each of which the earth has been successively peopled by distinct species of animals and plants. In an early stage of society, the necessity of hunting acts as a principle of repulsion, causing men to spread with the greatest rapidity over a country until the whole is covered with scattered settlements. It has been calculated that 800 acres of hunting ground produce only as much food as half an acre of arable land. When the game has been in a great measure exhausted and a state of pasturage succeeds, the several hunter tribes, being already scattered, may multiply in a short time into the greatest number which the pastoral state is capable of sustaining. The necessity, says Brand, thus imposed upon the two savage states of dispersing themselves far and wide over the country, affords a reason why, at a very early period, the worst parts of the earth may have become inhabited. But this reason, it may be said, is only applicable in as far as regards the peopling of a continuous continent, whereas the smallest islands, however far remote from continents, have almost always been found inhabited by man. St. Helena, it is true, afforded an exception, for when that island was discovered in 1501 it was only inhabited by seafowl, and occasionally by seals and turtles, and was covered with a forest of trees and shrubs, all of species peculiar to it, with one or two exceptions, and which seems to have been expressly created for this remote and insulated spot. The islands also of Mauritius, Bourbon, Pitcairns, and Juan Fernandez, and those of the Galapagos archipelago, one of which is 70 miles long, were inhabited when first discovered, and what is more remarkable than all, the Falkland Islands, which together are 120 miles in length by 60 in breadth, and abounding in food fit for the support of man. Drifting of canoes to vast distances. But very few of the numerous coral islets and volcanoes of the vast Pacific, capable of sustaining a few families of men, have been found untenanted, and we have therefore to inquire whence and by what means, if all the members of the great human family have had one common source, could those savages have migrated. Cook, Foster, and others have remarked that parties of savages in their canoes must have often lost their way, and must have been driven on distant shores where they were forced to remain, deprived both of the means and of the requisite intelligence for returning to their country. Thus Captain Cook found on the island of Watio 3 inhabitants of Otaheite, who had been drifted thither in a canoe, although the distance between the two isles is 550 miles. In 1696, 2 canoes containing 30 persons who had left Ancorso were thrown by contrary winds and storms on the island of Samar, one of the Philippines, at a distance of 800 miles. In 1721, 2 canoes, one of which contained 24 and the other 6 persons, men, women, and children, were drifted from an island called Faroelep to the island of Guam, one of the Mariannes, a distance of 200 miles. Kotzebue, when investigating the coral isles of Radak at the eastern extremity of the Caroline Isles, became acquainted with a person of the name of Cadu, who was a native of Ulia, an isle 1,500 miles distant, from which he had been drifted with a party. Cadu and 3 of his countrymen one day left Ulia in a sailing boat, when a violent storm arose and drove them out of their course. They drifted about the open sea for 8 months, according to their reckoning by the moon, making a knot on a cord at every new moon. Being expert fishermen, they subsisted entirely on the produce of the sea, and when the rain fell, laid in as much fresh water as they had vessels to contain it. Kadu, says Kotzebue, who was the best diver, frequently went down to the bottom of the sea, where it is well known that the water is not so salt, with a coconut shell, with only a small opening. When these unfortunate men reached the Isles of Radak, every hope and almost every feeling had died within them. Their sail had long been destroyed, their canoe had long been the sport of winds and waves, and they were picked up by the inhabitants of Ore in a state of insensibility. But by the hospitable care of these islanders they soon recovered, and were restored to perfect health. Captain Beechey, in his voyage to the Pacific, fell in with some natives of the Coral Islands, who had in a similar manner been carried to a great distance from their native country. They had embarked, to the number of 150 souls, in 3 double canoes, from Ana, or Chain Island, situated about 300 miles to the eastward of Otaheite. They were overtaken by the monsoon, which dispersed the canoes, and after driving them about the ocean, left them becalmed, so that a great number of persons perished. 2 of the canoes were never heard of, but the other was drifted from one uninhabited island to another, at each of which the voyagers obtained a few provisions, and at length, after having wandered for a distance of 600 miles, they were found and carried to their home in the Blossom. Mr. Crawford informs me that there are several well-authenticated accounts of canoes having been drifted from Sumatra to Madagascar, and by such causes a portion of the Malayan language, with some useful plants, have been transferred to that island, which is principally peopled by Negroes. The space traversed in some of these instances was so great that similar accidents might suffice to transport canoes from various parts of Africa to the shores of South America, or from Spain to the Azores, and thence to North America, so that man, even in a rude state of society, is liable to be scattered involuntarily by the winds and waves over the globe, in a manner singularly analogous to that in which many plants and animals are diffused. We ought not then to wonder that during the ages required for some tribes of the human race to attain that advanced stage of civilization which empowers the navigator to cross the ocean in all directions with security, the whole earth should have become the abode of rude tribes of hunters and fishers. Were the whole of mankind now cut off, with the exception of one family, inhabiting the old or new continent, or Australia, or even some coral islet of the Pacific, we might expect their descendants, though they should never become more enlightened than the South Sea Islanders or the Eskimo, to spread in the course of ages over the whole earth, diffused partly by the tendency of population to increase, in a limited district, beyond the means of subsistence, and partly by the accidental drifting of canoes by tides and currents to distant shores. Involuntary influence of man in diffusing animals and plants. Many of the general remarks which have been made respecting the influence of man in spreading or in checking the diffusion of plants apply equally to his relations with the animal kingdom. On a future occasion I shall be led to speak of the instrumentality of our species in naturalizing useful animals and plants in new regions, when explaining my views of the effects which the spreading and increase of certain species exert in the extirpation of others. At present I shall confine myself to a few remarks on the involuntary aid which man lends to the dissemination of the species. In the mammiferous class, Our influence is chiefly displayed in increasing the number of quadrupeds which are serviceable to us, and in exterminating or reducing number of those which are noxious. Sometimes, however, we unintentionally promote the multiplication of inimical species, as when we introduced the rat, which was not indigenous in the New World, into all parts of America. They have been conveyed over in ships, and now infest a great multitude of islands and parts of that continent. In like manner, the Norway rat, Mus decumanus, has been imported into England, where it plunders our property in ships and houses. Among birds, the house sparrow may be cited as a species known to have extended its range with the tillage of the soil. During the last century it has spread gradually over Asiatic Russia, towards the north and east, always following the progress of cultivation. It made its first appearance on the Irtych in Tobolsk, soon after the Russians had plowed the land. It came in 1735 up the Obi to Beresau, and 4 years after to Narin, about 15 degrees of longitude farther east. In 1710 it had been seen in the higher parts of the coast of Lena, in the government of Irkutsk. In all these places it is now common, but is not yet found in the uncultivated regions of Kamchatka. The great viper, fer de lance, a species no less venomous than the rattlesnake, which now ravages Martinique and St. Lucia, was accidentally introduced by man, and exists in no other part of the West Indies. Many parasitic insects which attack our persons, and some of which are supposed to be peculiar to our species, have been carried into all parts of the earth and have as high a claim as man to a universal geographical distribution. A great variety of insects have been transported in ships from one country to another, especially in warmer latitudes. The European housefly has been introduced in this way into all the South Sea islands. Notwithstanding the coldness of our climate in England, we have been unable to prevent the cockroach, Blatta orientalis, from entering and diffusing itself in our ovens and kneading troughs, and availing itself of the artificial warmth which we afford. It is well known also that beetles, and many other kinds of lignipertus insects, have been introduced into Great Britain in timber, especially several North American species. The commercial relations, says Malte Brun, between France and India have transported from the latter country the aphis, which destroys the apple tree, and 2 sorts of Neuroptera, the lucifuga and flavicola, mostly confined to Provence and the neighborhood of Bordeaux, where they devour the timber in the houses and naval arsenals. Among mollusks we mention the Teredo nivalis, which is a native of equatorial seas, but which, by adhering to the bottom of ships, was transported to Holland, where it has been most destructive to vessels and piles. The same species has also been naturalized in England and other countries enjoying an extensive commerce. Bulimus undatus, a land species of considerable size, native of Jamaica and other West Indian islands, has been imported, adhering to tropical timber, into Liverpool, and, as I learned from Mr. Broderick, is now naturalized in the woods near that town. In all these and innumerable other instances we may regard the involuntary agency of man as strictly analogous to that of the inferior animals. Like them, we unconsciously contribute to extend or limit the geographical range and numbers of certain species in obedience to general rules in the economy of nature, which are for the most part beyond our control. End of section 89.
Chapter 40 of Principles of Geology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by deongines, Salt Lake City, Utah. Principles of Geology by Charles Lyell. Chapter 40, Part 1. Theories respecting the original introduction of species. Proposal of an hypothesis on this subject. Supposed centers or foci of creation. Why distinct provinces of animals and plants have not become more blended together. Brockie's speculation on the loss of species. Stations of plants and animals. Causes on which they depend. Stations of plants, how affected by animals. Equilibrium in the number of species, how preserved. Peculiar efficacy of insects in this task. Rapidity with which certain insects multiply or decrease in numbers. Effect of omnivorous animals in preserving the equilibrium of species. Reciprocal influence of aquatic and terrestrial species on each other. Theory of Linnaeus. It would be superfluous to examine the various attempts which were made to explain the phenomena of the distribution of species alluded to in the preceding chapters, in the infancy of the sciences of botany, zoology, and physical geography. The theories, or rather conjectures, then indulged, now stand refuted by a simple statement of facts, and if Linnaeus were living, he would be the first to renounce the notions which he promulgated, for he imagined the habitable world to have been for a certain time limited to one small tract, the only portion of the earth's surface that was as yet laid bare by the subsidence of the primeval ocean. In this fertile spot he supposed the originals of all the species of plants which exist on this globe to have been congregated together with the first ancestors of all animals and of the human race. In qua commode habitaverant animalia omnia et vegetablia late germina verant. In order to accommodate the various habitudes of so many creatures, and to provide a diversity of climate suited to their several natures, the tract in which the creation took place was supposed to have been situated in some warm region of the earth, but to have contained a lofty mountain range, on the heights and in the declivities of which were to be found all temperatures and every climate, from that of the torrid to that of the frozen zone. That there was never a universal ocean since the planet was inhabited, or rather since the oldest groups of strata yet known to contain organic remains were formed, is proved by the presence of terrestrial plants, or by indication of shores in all the older formations. And if this conclusion was not established, yet no geologist could deny that, since the first small portion of the earth was laid dry, there have been many entire changes in the species of plants and animals inhabiting the land. But without dwelling on the above and other refuted theories, let us inquire whether some hypothesis cannot be substituted, as simple as that of Linnaeus, to which the phenomena now ascertained in regard to the distribution both of aquatic and terrestrial species may be referred. The following may, perhaps, be reconcilable with known facts. Each species may have had its origin in a single pair or individual, where an individual was sufficient, and species may have been created in succession at such times and in such places as to enable them to multiply and endure for an appointed period, and occupy an appointed space on the globe. In order to explain this theory, let us suppose every living thing to be destroyed in the Western Hemisphere, both on the land and in the ocean, and permission to be given to man to people this great desert by transporting into it animals and plants from the Eastern Hemisphere, a strict prohibition being enforced against introducing two original stocks of the same species. Now, it is easy to show that the result of such a mode of colonizing would correspond exactly, so far as regards the grouping of animals and plants, with that now observed throughout the globe. In the first place, it would be necessary for naturalists, before they imported species into particular localities, to study attentively the climate and other physical conditions of each spot. It would be no less requisite to introduce the different species in succession, so that each plant and animal might have time and opportunity to multiply before the species destined to prey upon it was admitted. Many herbs and shrubs, for example, must spread far and wide before the sheep, the deer, and the goat could be allowed to enter, lest they should devour and annihilate the original stocks of many plants, and then perish themselves for want of food. The above-mentioned herbivorous animals, in their turn, must be permitted to make considerable progress before the entrance of the first pair of wolves or lions. Insects must be allowed to swarm before the swallow could be permitted to skim through the air and feast on thousands at one repast. It is evident that, however equally in this case our original stocks were distributed over the whole surface of land and water, there would nevertheless arise distinct botanical and zoological provinces, for there are a great many natural barriers which oppose common obstacles to the advance of a variety of species. Thus, for example, almost all the animals and plants naturalized by us towards the extremity of South America would be unable to spread beyond a certain limit towards the east, west, and south, because they would be stopped by the ocean, and a few of them only would succeed in reaching the cooler latitudes of the northern hemisphere, because they would be incapable of bearing the heat of the tropics, through which they must pass. In the course of ages, undoubtedly, exceptions would arise, and some species might become common to the temperate and polar regions, or both sides of the equator. For I have before shown that the powers of diffusion conferred on some classes are very great, but we might confidently predict that these exceptions would never become so numerous as to invalidate the general rule. Some of the plants and animals transplanted by us to the coast of Chile and Peru would never be able to cross the Andes so as to reach the eastern plains, nor for a similar reason would those first established in the Pampas or the valleys of the Amazon and the Orinoco ever arrive at the shores of the Pacific. In the ocean, an analogous state of things would prevail, for there also climate would exert a huge influence in limiting the range of species, and the land would stop the migrations of aquatic tribes as effectually as the sea arrests the dispersion of the terrestrial. As certain birds, insects, and the seeds of plants can never cross the direction of prevailing winds, so currents form natural barriers to the dissemination of many oceanic races. A line of shoals may be as impassable to deep water species as are the Alps and the Andes to plants and animals peculiar to plains, while deep abysses may prove insuperable obstacles to the migration of the inhabitants of shallow waters. Supposed centers or foci of creation. It is worthy of observation that one effect of the introduction of single pairs of each species must be the confined range of certain groups in spots, which, like small islands or solitary inland lakes, have few means of interchanging their inhabitants with adjoining regions. Now, this congregating in a small space of many peculiar species would give an appearance of centers or foci of creation, as they have been termed, as if they were favorite points where the creative energy has been in greater action than in others, and where the numbers of peculiar organic beings have consequently become more considerable. I do not mean to call in question the soundness of the inferences of some botanists as to the former existence of certain limited spots whence species of plants have been propagated, radiating, as it were, in all directions from a common center. On the contrary, I conceive these phenomena to be the necessary consequences of the plan of nature before suggested, operating during the successive mutations of the surface, some of which the geologist can prove to have taken place subsequently to the period when many species now existing were created. In order to exemplify how this arrangement of plants may have been produced, let us imagine that about 3 centuries before the discovery of St. Helena, itself of submarine volcanic origin, a multitude of new islands had been thrown up in the surrounding sea, and that these had each become clothed with plants emigrating from St. Helena, in the same manner as the wild plants of Campania have diffused themselves over Monte Nuovo. Whenever the first botanist investigated the new archipelago, he would, in all probability, find a different assemblage of plants in each of the islands of recent formation. But in St. Helena itself, he would meet with individuals of every species belonging to all parts of the archipelago, and some, in addition, peculiar to itself, that is, those which had not been able to obtain a passage into any one of the surrounding new-formed lands. In this case, it might be truly said that the original island was the primitive focus or center of a certain type of vegetation, whereas in the surrounding islands there would be a smaller number of species, yet all belonging to the same group. But this peculiar distribution of plants would not warrant the conclusion that, in the space occupied by St. Helena, there had been a greater exertion of creative power than in the spaces of equal area occupied by the new adjacent lands, because within the period in which St. Helena had acquired its peculiar vegetation, each of the spots supposed to be subsequently converted into land may have been the birthplace of a great number of marine animals and plants, which may have had time to scatter themselves far and wide over the southern Atlantic. Why distinct provinces, not more blended? Perhaps it may be objected to some parts of the foregoing train of reasoning that during the lapse of past ages, especially during many partial revolutions of the globe of comparatively modern date, different zoological and botanical provinces ought to have become more confounded and blended together, that the distribution of species approaches too nearly to what might have been expected if animals and plants had been introduced into the globe when its physical geography had already assumed the features which it now wears, whereas we know that, in certain districts, considerable geographical changes have taken place since species, identical with those now in being, were created. Brocchi's speculations on loss of species. These and many kindred topics cannot be fully discussed until we have considered not merely the general laws which may regulate the first introduction of species, but those which may limit their duration on the earth. Brockie remarked, when hazarding some interesting conjectures respecting the loss of species, that a modern naturalist had no small assurance who declared that individuals alone were capable of destruction, and that species were so perpetuated that nature could not annihilate them so long as the planet lasted, or at least that nothing less than the shock of a comet or some similar disaster could put an end to their existence. The Italian geologist, on the contrary, had satisfied himself that many species of Testacea, which formerly inhabited the Mediterranean, had become extinct, although a great number of others, which had been the contemporaries of those lost races, still survived. He came to the opinion that about half the species which peopled the waters when the sub-Apennine strata were deposited had gone out of existence, and in this inference he does not appear to have been far wrong. But instead of seeking a solution of this problem, like some other geologists of his time, in a violent and general catastrophe, Brockie endeavored to imagine some regular and constant law by which species might be made to disappear from the earth gradually and in succession. The death, he suggested, of a species might depend, like that of individuals, on certain peculiarities of constitution conferred upon them at their birth, and as the longevity of the one depends on a certain force of vitality, which, after a period, grows weaker and weaker, so the duration of the other may be governed by the quantity of prolific power bestowed upon the species, which, after a season, may decline in energy, so that the fecundity and multiplication of individuals may be gradually lessened from century to century, until that fatal term arrives when the embryo, incapable of extending and developing itself, abandons, almost at the instant of its formation, the slender principle of life by which it was scarcely animated, and so all dies with it. Now, we may coincide in opinion with the Italian naturalist as to the gradual extinction of species one after another by the operation of regular and constant causes, without admitting an inherent principle of deterioration in their physiological attributes. We might concede that many species are on the decline, and that the day is not far distant when they will cease to exist. Yet deem it consistent with what we know of the nature of organic beings to believe that the last individuals of each species retain their prolific powers in their full intensity. Brockie has himself speculated on the share which a change of climate may have had in rendering the Mediterranean unfit for the habitation of certain Testacea, which still continued to thrive in the Indian Ocean, and of others which were now only represented by analogous forms within the tropics. He must also have been aware that other extrinsic causes, such as the progress of human population, or the increase of some one of the inferior animals, might gradually lead to the extirpation of a particular species, although its fecundity might remain to the last unimpaired. If, therefore, amid the vicissitudes of the animate and inanimate world, there are known causes capable of bringing about the decline and extirpation of species, it became him thoroughly to investigate the full extent to which these might operate, before he speculated on any cause of so purely hypothetical a kind as the diminution of the prolific virtue. If it could have been shown that some wild plant had insensibly dwindled away and died out, as sometimes happens to cultivated varieties propagated by cuttings, even though climate, soil, and every other circumstance should continue identically the same, if any animal had perished while the physical condition of the earth and the number and force of its foes, with every other extrinsic cause, remain unaltered, then might we have some ground for suspecting that the infirmities of age creep on as naturally on species as upon individuals. But in the absence of such observations, let us turn to another class of facts, and examine attentively the circumstances which determine the stations of particular animals and plants, and perhaps we shall discover in the vicissitudes to which these stations are exposed a cause fully adequate to explain the phenomena under consideration. Stations of plants and animals. Stations comprehend all the circumstances, whether relating to the animate or inanimate world, which determine whether a given plant or animal can exist in a given place, so that if it be shown that stations can become essentially modified by the influence of known causes, it will follow that species, as well as individuals, are mortal. Every naturalist is familiar with the fact that although in a particular country, such as Great Britain, there may be more than 3,000 species of plants, 10,000 insects, and a great variety in each of the other classes, yet there will not be more than 100, perhaps not half that number, inhabiting any given locality. There may be no want of space in the supposed tract. It may be a large mountain, or an extensive moor, or a great river plain, containing room enough for individuals of every species in our island, yet the spot will be occupied by a few to the exclusion of many, and these few are enabled throughout long periods to maintain their ground successfully against every intruder, notwithstanding the facilities which species enjoy by virtue of their power of diffusion, of invading adjacent territories. The principal causes which enable a certain assemblage of plants thus to maintain their ground against all others depend, as is well known, on the relations between the physiological nature of each species and the climate, exposure, soil, and other physical conditions of the locality. Some plants live only on rocks, others in meadows, a third class in marshes. Of the latter, some delight in a freshwater morass, others in salt marshes, where their roots may copiously absorb saline particles. Some prefer an alpine region in a warm latitude, where during the heat of summer they are constantly irrigated by the cool waters of melting snows. To others, loose sand, so fatal to the generality of species, affords the most proper station. The Carex arenaria and the Elamus arenarius acquire their full vigor on a sandy dune, obtaining an ascendancy over the very plants which in a stiff clay would immediately stifle them. Where the soil of a district is of so peculiar a nature that it is extremely favorable to certain species, and agrees ill with every other, the former get exclusive possession of the ground, and, as in the case of heaths, live in societies. In like manner, the bog moss, sphagnum, is fully developed in peaty swamps, and becomes, like the heath, in the language of botanists, a social plant. Such monopolies, however, are not common, for they are checked by various causes. Not only are many species endowed with equal powers to obtain and keep possession of similar stations, but each plant, for reasons not fully explained by the physiologist, has the property of rendering the soil where it has grown less fitted for the support of other individuals of its own species, or even other species of the same family. Yet the same spot, so far from being impoverished, is improved for plants of another family. Oaks, for example, render the soil more fertile for the fir tribe, and firs prepare the soil for oaks. Every agriculturalist feels the force of this law of the organic world and regulates accordingly the rotation of his crops. Equilibrium in the number of species, how preserved. All the plants of a given country, says de Candolle in his usual spirited style, are at war one with another. The first which establish themselves by chance in a particular spot tend by the mere occupancy of space to exclude other species. The greater choke the smaller. The longest livers replace those which last for a shorter period. The more prolific gradually make themselves masters of the ground, which species, multiplying more slowly, would otherwise fill. In this continual strife, it is not always the resources of the plant itself which enable it to maintain or extend its ground. Its success depends, in a great measure, on the number of its foes or allies among the animals and plants inhabiting the same region. Thus, for example, a herb which loves the shade may multiply if some tree with spreading boughs and dense foliage flourish in the neighborhood. Another which, if unassisted, would be overpowered by the rank growth of some hardy competitor, is secure, because its leaves are unpalatable to cattle, which, on the other hand, annually crop down its antagonist, and rarely suffer it to ripen its seed. Oftentimes we see some herb which has flowered in the midst of a thorny shrub, when all the other individuals of the same species in the open fields around are eaten down, and cannot bring their seed to maturity. In this case, the shrub has lent his armor of spines and prickles to protect the defenseless herb against the mouths of the cattle, and thus a few individuals, which occupied, perhaps, the most unfavorable station in regard to exposure, soil, and other circumstances, may nevertheless, by the aid of an ally, become the principal source whereby the winds are supplied with seeds which perpetuate the species throughout the surrounding tract. Thus, in the New Forest in Hampshire, the young oaks which are not consumed by the deer or uprooted by the swine are indebted to the holly for their escape. In the above examples, we see one plant shielding another from the attacks of animals, but instances are, perhaps, still more numerous, where some animal defends a plant against the enmity of some other subject of the vegetable kingdom. Scarcely any beast, observes a Swedish naturalist, will touch the nettle, but 50 different kinds of insects are fed by it. Some of these seize upon the root, others upon the stem, some eat the leaves, others devour the seeds and flowers. But for this multitude of enemies, the nettle, Urtica doica, which is now found in all the 4 quarters of the globe, would annihilate a great number of plants. Linnaeus tells us in his Tour in Scania that goats were turned into an island which abounded with the Agrostis arundinacea, where they perished by famine. But horses which followed them grew fat on the same plant. The goat also, he says, thrives on the meadowsweet and water hemlock, plants which are injurious to cattle. End of chapter 40, part 1. Chapter 40, Part 2 of Principles of Geology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by deongines, Salt Lake City, Utah. Principles of Geology by Charles Lyell. Chapter 40, Part 2. Agency of Insects. Every plant, observes Wilkie, has its proper insect allotted to it to curb its luxuriancy and to prevent it from multiplying to the exclusion of others. Thus, grass in meadows sometimes flourishes so as to exclude all other plants. Here the Phalaena graminis, Bombyx gram, with her numerous progeny, finds a well-spread table. They multiply in immense numbers, and the farmer for some years laments the failure of his crop. But the grass being consumed, the moths die with hunger, or remove to another place. Now the quantity of grass being greatly diminished, the other plants, which were before choked by it, spring up, and the ground becomes variegated with a multitude of different species of flowers. Had not nature given a commission to this minister for that purpose, the grass would destroy a great number of species of vegetables, of which the equilibrium is now kept up. In the above passage, allusion is made to the ravages committed in 1740 and the 2 following years in many provinces of Sweden by a most destructive insect. The same moth is said never to touch the foxtail grass, so that it may be classed as a most active ally and benefactor of that species, and as peculiarly instrumental in preserving it in its present abundance. A discovery of Rolander, cited in the treatise of Wilkie above mentioned, affords a good illustration of the checks and counterchecks which nature has appointed to preserve the balance of power among species. The Phalaena strobila has the fir cone assigned to it to deposit its eggs upon. The young caterpillars coming out of the shell consume the cone and superfluous seed. But lest the destruction should be too general, the Ichneumon strobilellae lays its eggs in the caterpillar, inserting its long tail in the openings of the cone till it touches the included insect, for its body is too large to enter. Thus it fixes its minute egg upon the caterpillar, which, being hatched, destroys it. Entomologists enumerate many parallel cases where insects appropriated to certain plants are kept down by other insects, and these again by parasites expressly appointed to prey on them. Few perhaps are in the habit of duly appreciating the extent to which insects are active in preserving the balance of species among plants, and thus regulating indirectly the relative numbers of many of the higher orders of terrestrial animals. The peculiarity of their agency consists in their power of suddenly multiplying their numbers to a degree which could only be accomplished in a considerable lapse of time in any of the larger animals, and then as instantaneously relapsing, without the intervention of any violent disturbing cause, into their former insignificance. If, for the sake of employing, on different but rare occasions, a power of many hundred horses, we were under the necessity of feeding all these animals at great cost in the intervals when their services were not required, we should greatly admire the invention of a machine such as the steam engine, which was capable at any moment of exerting the same degree of strength without any consumption of food during periods of inaction. The same kind of admiration is strongly excited when we contemplate the powers of insect life, in the creation of which the author of nature has been so prodigal. A scanty number of minute individuals, to be detected only by careful research, are ready in a few days, weeks, or months to give birth to myriads, which may repress any degree of monopoly in another species, or remove nuisances such as dead carcasses, which might taint the air. But no sooner has the destroying commission been executed than the gigantic power becomes dormant.
each of the mighty host soon reaches the term of its transient existence, and the season arrives when the whole species passes naturally into the egg, and thence into the larva and pupa state. In this defenseless condition it may be destroyed either by the elements or by the augmentation of some of its numerous foes, which may prey upon it in the early stages of its transformation. Or it often happens that in the following year the season proves unfavorable to the hatching of the eggs or the development of the pupa. Thus the swarming myriads depart, which may have covered the vegetation like the aphids, or darkened the sky like locusts. In almost every season there are some species which in this manner put forth their strength, and then, like Milton's spirits, which thronged the spacious hall, reduce to smallest forms their shapes immense. So thick the airy crowd swarmed and were straitened, till the signal given, behold a wonder, they but how who seemed in bigness to surpass earth's giant sons, now less than smallest dwarfs. A few examples will illustrate the mode in which this force operates. It is well known that among the countless species of the insect creation, some feed on animal, others on vegetable matter. And upon considering a catalogue of 8,000 British insects and arachnidae, Mr. Kirby found that these two divisions were nearly a counterpoise to each other, the carnivorous being somewhat preponderant. There are also distinct species, some appointed to consume living, others dead or putrid animal and vegetable substances. One female of Musca carnaria will give birth to 20,000 young, and the larva of many flesh flies devour so much food in 24 hours and grow so quickly as to increase their weight 200-fold. In 5 days after being hatched, they arrive at their full growth and size, so that there was ground, says Kirby, for the assertion of Linnaeus that 3 flies of M. vomitoria could devour a dead horse as quickly as a lion. And another Swedish naturalist remarks that so great are the powers of propagation of a single species, even of the smallest insects, that each can commit, when required, more ravages than the elephant. Next to locusts, the aphids, perhaps, exert the greatest power over the vegetable world, and, like them, are sometimes so numerous as to darken the air. The multiplication of these little creatures is without parallel, and almost every plant has its peculiar species. Reaumur has proved that in 5 generations one aphis may be the progenitor of 5,904,900,000 descendants, and it is supposed that in 1 year there may be 20 generations. Mr. Curtis observes that, as among caterpillars, we find some that are constantly and unalterably attached to one or more particular species of plants, and others that feed indiscriminately on most sorts of herbage. So it is precisely with the aphids. Some are particular, others more general feeders, and as they resemble other insects in this respect, so they do also in being more abundant in some years than in others. In 1793 they were the chief, and in 1798 the sole cause of the failure of the hops. In 1794, a season almost unparalleled for drought, the hop was perfectly free from them, while peas and beans, especially the former, suffered very much from their depredations. The ravages of the caterpillars of some of our smaller moths afford a good illustration of the temporary increase of a species. The oak trees of a considerable wood have been stripped of their leaves, as bare as in winter, by the caterpillars of a small green moth, Tortrix veridana, which has been observed the year following not to abound. The silver Y moth, Plusia gamma, although one of our common species, is not dreaded by us for its devastations, but legions of their caterpillars have at times created alarm in France, as in 1735. Reaumur observes that the female moth lays about 400 eggs, so that if 20 caterpillars were distributed in a garden, and all lived through the winter and became moths in the succeeding May, the eggs laid by these, if half of them were female and all fertile, would in the next generation produce 800,000 caterpillars. A modern writer therefore justly observes that, did not Providence put causes in operation to keep them in due bounds, the caterpillars of this moth alone, leaving out of consideration the 2,000 other British species, might soon destroy more than half of our vegetation. In the latter part of the last century, an ant most destructive to the sugar cane, Formica saccharovora, appeared in such infinite hosts on the island of Grenada as to put a stop to the cultivation of that vegetable. Their numbers were incredible. The plantations and roads were filled with them. Many domestic quadrupeds, together with rats, mice, and reptiles, and even birds, perished in the consequence of this plague. It was not till 1780 that they were at length annihilated by torrents of rain, which accompanied a dreadful hurricane. Devastations caused by locusts. We may conclude by mentioning some instances of the devastations of locusts in various countries. Among other parts of Africa, Cyrenaica has been at different periods infested by myriads of these creatures, which have consumed nearly every green thing. The effect of the havoc committed by them may be estimated by the famine they occasioned. St. Augustine mentions a plague of this kind in Africa, which destroyed no less than 800,000 men in the kingdom of Massinissa alone, and many more upon the territories bordering upon the sea. It is also related that in the year 591, an infinite army of locusts migrated from Africa into Italy, and after grievously ravaging the country, were cast into the sea, when there arose a pestilence from their stench, which carried off nearly 1,000,000 of men and beasts. In the Venetian territory, also in 1748, more than 30,000 persons are said to have perished in a famine occasioned by this scourge, and other instances are recorded of their devastations in France, Spain, Italy, Germany, etc. In different parts of Russia also, Hungary and Poland, in Arabia and India, and other countries, their visitations have been periodically experienced. Although they have a preference for certain plants, yet when these are consumed, they will attack almost all the remainder. In the accounts of the invasion of locusts, the statements which appear most marvelous relate to the prodigious mass of matter which encumbers the sea whenever they are blown into it, and the pestilence arising from its putrefaction. Their dead bodies are said to have been, in some places, heaped one upon another to the depth of 4 feet, in Russia, Poland, and Lithuania, and when in southern Africa they were driven into the sea by a northwest wind, they formed, says Barrow, along the shore for 50 miles, a bank 3 or 4 feet high. But when we consider that forests are stripped of their foliage, and the earth of its green garment for thousands of square miles, it may well be supposed that the volume of animal matter produced may equal that of great herds of quadrupeds and flights of large birds suddenly precipitated into the sea. The occurrence of such events at certain intervals in hot countries, like the severe winters and damp summers returning after a series of years in the temperate zone, may affect the proportional numbers of almost all classes of animals and plants, and probably prove fatal to the existence of many which would otherwise thrive there, while, on the contrary, the same occurrences can scarcely fail to be favorable to certain species which, if deprived of such aid, might not maintain their ground, although it may usually be remarked that the extraordinary increase of some one species is immediately followed and checked by the multiplication of another. Yet this does not always happen, partly because many species feed in common on the same kinds of food, and partly because many kinds of food are often consumed indifferently by one and the same species. In the former case, where a variety of different animals have precisely the same taste, as, for example, when many insectivorous birds and reptiles devour alike some particular fly or beetle, the unusual numbers of these insects may cause only a slight and almost imperceptible augmentation of each of these species of bird and reptile. In the other instances, where one animal preys on others of almost every class, as for example, where our English buzzards devour not only small quadrupeds, as rabbits and field mice, but also birds, frogs, lizards, and insects, the profusion of any one of these last may cause all such general feeders to subsist more exclusively upon the species thus in excess, by which means the balance may be restored. Agency of omnivorous animals. The number of species which are nearly omnivorous is considerable, and although every animal has perhaps a predilection for some one description of food rather than another, yet some are not even confined to one of the great kingdoms of the organic world. Thus, when the raccoon of the West Indies can procure neither fowls, fish, snails, nor insects, it will attack the sugar canes and devour various kinds of grain. The civets, when animal food is scarce, maintain themselves on fruits and roots. Numerous birds which feed indiscriminately on insects and plants are perhaps more instrumental than any other of the terrestrial tribes in preserving a constant equilibrium between the relative numbers of different classes of animals and vegetables. If the insects become very numerous and devour the plants, these birds will immediately derive a larger portion of their subsistence from insects, just as the Arabians, Syrians, and Hottentots feed on locusts, when the locusts devour their crops. Reciprocal influence of aquatic and terrestrial species. The intimate relation of the inhabitants of the water to those of the land, and the influence exerted by each on the relative number of species, must not be overlooked amongst the complicated causes which determine the existence of animals and plants in certain regions. A large portion of the amphibious quadrupeds and reptiles prey partly on aquatic plants and animals, and in part on terrestrial, and a deficiency of one kind of prey causes them to have immediate recourse to the other. The voracity of certain insects, as the dragonfly for example, is confined to the water during one stage of their transformations, and in their perfect state to the air. Innumerable water birds, both of rivers and seas, derive in like manner their food indifferently from either element, so that the abundance or scarcity of prey in one induces them either to forsake or more constantly to haunt the other. Thus an intimate connection between the state of the animate creation in a lake or river and in the adjoining dry land is maintained, or between a continent with its lakes and rivers, and the ocean. It is well known that many birds migrate during stormy seasons from the seashore into the interior in search of food, while others, on the contrary, urged by like wants, forsake their inland haunts and live on substances rejected by the tide. The migration of fish into rivers during the spawning season supplies another link of the same kind. Suppose the salmon to be reduced in numbers by some marine foes, as by seals and grampuses. The consequence must often be that in the course of a few years the otters at the distance of several hundred miles inland will be lessened in number from the scarcity of fish. On the other hand, if there be a dearth of food for the young fry of the salmon in rivers and estuaries, so that few return to the sea, the sand eels and other marine species, which are usually kept down by the salmon, will swarm in greater profusion. It is unnecessary to accumulate a greater number of illustrations in order to prove that the stations of different plants and animals depend on a great complication of circumstances, on an immense variety of relations in the state of the inanimate worlds. Every plant requires a certain climate, soil, and other conditions, and often the aid of many animals in order to maintain its ground. Many animals feed on certain plants, being often restricted to a small number, and sometimes to one only. Other members of the animal kingdom feed on plant-eating species, and thus become dependent on the conditions of the stations, not only of their prey, but of the plants consumed by them. Having duly reflected on the nature and extent of these mutual relations in the different parts of the organic and inorganic worlds, we may next proceed to examine the results which may be anticipated from the fluctuations now continually in progress in the state of the earth's surface, and in the geographical distribution of its living productions. End of chapter 40, part 2.
Chapter 41 of Principles of Geology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Sycamore Rockwell. Principles of Geology by Charles Lyell. Extinction of species. Changes in the stations of animals. Extension of the range of one species alters the condition of many others. The first appearance of a new species causes the chief disturbance. Changes known to have resulted from the advance of human population. Whether man increases the productive powers of the earth. Indigenous quadrupeds and birds extirpated in Great Britain. Extinction of the dodo. Rapid propagation of domestic quadrupeds in America. Power of exterminating species no prerogative of man. Concluding remarks. We have seen that the stations of animals and plants depend not merely on the influence of external agents in the inanimate world, and the relations of that influence to the structure and habits of each species, but also on the state of the contemporary living beings which inhabit the same part of the globe. In other words, the possibility of the existence of a certain species in a given place, or of its thriving more or less therein, is determined not merely by temperature, humidity, soil elevation, and other circumstances of the like, but also by the existence or non-existence, the abundance or scarcity of a particular assemblage of other plants and animals in the region. If it be shown that both these classes of circumstances, whether relating to the animate or inanimate creation, are perpetually changing, it will follow that species are subject to incessant vicissitudes. And if the result of these mutations, in the course of ages, be so great as materially to affect the general condition of stations, it will follow that the successive destruction of species must now be part of the regular and constant order of nature. Extension of the range of one species alters the condition of the others. It will be desirable first to consider the effects which every extension of the numbers or geographical range of one species must produce on the condition of others inhabiting the same regions. When the necessary consequences of such extensions have been fully explained, the reader will be prepared to appreciate the important influence which slight modifications in the physical geography of the globe may exert on the condition of organic beings. In the first place, it is clear that when any region is stacked with as great a variety of animals and plants as the productive powers of that region will enable it to support, the addition of any new species, or the permanent numerical increase of one previously established, must always be attended either by the local extermination or the numerical decrease of some other species. There may undoubtedly be considerable fluctuations from year to year, and the equilibrium may be again resorted without any permanent alteration, for in particular seasons a great supply of heat, humidity, or other causes may augment the total quality of vegetable produce, in which case all the animals subsisting on vegetable food, and others which prey on them, may multiply without any one species giving way. But whilst the aggregate quantity of vegetable produce remains unaltered, the progressive increase of one animal or plant implies the decline of another. All agriculturists and gardeners are familiar with the fact that when weeds intrude themselves into the space appropriated to cultivate species, the latter are starved in their growth or stifled. If we abandon for a short time a field or garden, a host of indigenous plants pour in and obtain the mastery, extirpating the exotics or putting an end to the monopoly of some native plants. If we enclose a park and stock it with as many deer as the herbage will support, we cannot add sheep without lessening the number of the deer, nor can other herbivorous species be subsequently introduced unless the individuals of each species in the park become fewer in proportion. So, if there be an island where leopards are the only beasts of prey, and the lion, tiger, and hyena afterwards enter, the leopards, if they stand their ground, will be reduced in number. If the locusts then arrive and swarm greatly, they may deprive a large number of plant-eating animals of their food, and thereby cause a famine, not only among them, but among the beasts of prey. Certain species, perhaps, which had the weakest footing in the island, may thus be annihilated. We have seen how many distinct geographical provinces there are of aquatic and terrestrial species, and how great are the powers of migration conferred on different classes, whereby the inhabitants of one region may be enabled from time to time to invade another, and do actually so migrate and diffuse themselves over new countries. Now, although our knowledge of the history of the animate creation dates from so recent a period that we can scarcely trace the advance or decline of any animal or plant, except in those cases where the influence of man has intervened, yet we can easily conceive what must happen when some new colony of wild animals or plants enters a region for the first time and succeeds in establishing itself. Supposed effect of the first entrance of the polar bear into Iceland. Let us consider how great are the devastations committed at certain periods by the Greenland bears, when they are drifted to the shores of Iceland in considerable numbers on the ice. These periodical invasions are formidable even to man, so that when the bears arrive, the inhabitants collect together and go in pursuit of them with firearms, each native who slays one being rewarded by the King of Denmark. The Danes of old, when they landed in their marauding expeditions upon our coast, hardly excited more alarm, nor did our islanders muster more promptly for the defense of their lives and property against the common enemy, than the modern Icelanders against these formidable brutes. It often happens, says Henderson, that the natives are pursued by the bear when he has been long at sea, and when his natural ferocity has been heightened by the keenness of hunger. If unarmed, it is frequently by stratagem only that they make their escape. Let us cast our thoughts back to the period when the first polar bears reached Iceland, before it was colonized by the Norwegians in 1874. We may imagine the breaking up of an immense barrier of ice, like that which in 1816 and the following year disappeared from the east coast of Greenland, which it had surrounded for 4 centuries. By the aid of such means of transportation, a great number of these quadrupeds might effect a landing at the same time, and the havoc which they would make among the species previously settled in the island would be terrific. The deer, foxes, seals, and even birds on which these animals sometimes prey would be soon thinned down. But this would be a part only, and probably an insignificant portion of the aggregate amount of change brought about by the new invader. The plants on which the deer fed, being less consumed in consequence of the lessened numbers of that herbivorous species, would soon supply more food to several insects and probably to some terrestrial testacea, so that the latter would gain ground. The increase of these would furnish other insects and birds with food, so that the numbers of these last would be augmented. The diminution of the seals would afford a respite to some fish which they had persecuted, and these fish, in turn, would then multiply and press upon their peculiar prey. Many waterfowls, the eggs and young of which are devoured by foxes, would increase when the foxes were thinned down by the bears, and the fish on which the waterfowls subsided would then, in turn, be less numerous. Thus the numerical proportions of a great number of the inhabitants, both of the land and sea, might be permanently altered by the settling of one new species in the region, and the changes caused indirectly would ramify through all classes of the living creation and be almost endless. An actual illustration of what we have here only proposed hypothetically is in some degree afforded by the selection of small islands by the eider duck for its residence during the season of incubation, its nest being seldom, if ever, found on the shores of the mainland or even of a large island. The Icelanders are so well aware of this that they have expended a great deal of labor in forming artificial islands by separating from the mainland certain promontories joined to it by narrow isthmuses. This insular position is necessary to guard against the destruction of the eggs and young birds by foxes, dogs, and other animals. One year, says Hooker, it happened that in the small island of Vidau, adjoining the coast of Iceland, a fox got over upon the ice and caused great alarm, as an immense number of ducks were then sitting on their eggs and young ones. It was long before he was taken, which was at last, however, effected by bringing another fox to the island and fastening it by a string near the haunt of the former, by which he was allured within shot of the hunter. The first appearance of a new species causes the chief disturbance. It is usually the first appearance of an animal or plant in a region to which it was previously a stranger that gives rise to the chief alteration, since, after a time, an equilibrium is again established. But it must require ages before such an adjustment to the relative forces of so many conflicting agents can be definitely settled. The causes in simultaneous action are so numerous that they admit of an almost infinite number of combinations, and it is necessary that all these should have occurred once before the total amount of change capable of flowing from any new disturbing force can be estimated. Thus, for example, suppose that once in 2 centuries a frost of unusual intensity, or a volcanic eruption of great violence accomplished by floods from the melting of glaciers, should occur in Iceland, or an epidemic disease fatal to the larger number of individuals of some one species and not affecting others. These and a variety of other contingencies, all of which may occur at once or at periods separated by different intervals of time, ought to happen before it would be possible for us to declare what ultimate alteration the presence of any newcomer, such as the bear before mentioned, might occasion in the animal population of the isle. Every new condition in the state of the organic or inorganic creation, a new animal or plant, an additional snow-clad mountain, any permanent change, however slight in comparison to the whole, gives rise to a new order of things, and may make a material change in regard to some one or more species. Yet a swarm of locusts, or a frost of extreme intensity, or an epidemic disease may pass away without any great apparent derangement. No species may be lost, and all may soon recover their former relative numbers, because the same scourges may have visited the region again and again in preceding periods. Every plant that was incapable of resisting such a degree of cold, every animal which was exposed to be entirely cut off by an epidemic or by famine caused by the consumption of vegetation by the locusts may have perished already, so that the subsequent recurrence of similar catastrophes is attended only by a temporary change. Changes caused by man. We are best acquainted with the mutations brought about by the progress of human population and the growth of plants and animals favored by man. To these, therefore, we should in the first instance turn our attention. If we conclude from the concurrent testimony of history and of the evidence yielded by geological data that man is, comparatively speaking, of very modern origin, we must at once perceive how great a revolution in the state of the animate world the increase of the human race, considered merely as consumers of a certain quantity of organic matter, must necessarily cause. Whether man increases the productive powers of the earth. It may perhaps be said that man has in some degree compensated for the appropriation to himself of so much food by artificially improving the natural productiveness of soils, by irrigation, manure, and a judicious intermixture of mineral ingredients conveyed from different localities. But it admits of reasonable doubt whether upon the whole we fertilize or impoverish the lands which we occupy. This assertion may seem startling to many because they are so much in the habit of regarding the sterility or productiveness of land in relation to the wants of man, and not as regards the organic world generally. It is difficult at first to conceive if a morass is converted into arable land and made to yield a crop of grain, even of moderate abundance, that we have not improved the capabilities of the habitable surface, that we have not empowered it to support a larger quantity of organic life. In such cases, however, a tract before of no utility to man may be reclaimed and become of high agricultural importance, though it may nevertheless yield a scantier vegetation. If a lake be drained and turned into a meadow, the space will provide sustenance to man and many terrestrial animals serviceable to him, but not perhaps so much food as it previously yielded to the aquatic races. If the pestiferous pontine marshes were drained and covered with corn, like the plains of the Po, they might perhaps feed a smaller number of animals than they do now, for these morasses are filled with herds of buffaloes and swine, and they swarm with birds, reptiles, and insects. The felling of dense and lofty forests, which covered, even within the records of history, a considerable space on the globe, now tenanted by civilized men, must generally have lessened the amount of vegetable food throughout the space where these woods grew. We must also take into our account the area covered by towns, and a still larger surface occupied by roads. If we force the soil to bear extraordinary crops one year, we are perhaps compelled to let it lie fallow the next. But nothing so much counterbalances the fertilizing effect of human art as the extensive cultivation of foreign herbs and shrubs, which, although they are often more nutritious to man, seldom thrive with the same rank luxuriance as the native plants of a district. Man is, in truth, continually striving to diminish the natural diversity of the stations of animals and plants in every country, and to reduce them all to a small number fitted for species of economical use. He may succeed perfectly in attaining his object, even though the vegetation be comparatively meager and the total amount of animal life be greatly lessened. Spix and Maritus have given a lively description of the incredible number of insects which lay waste the crops of Brazil, besides swarms of monkeys, flocks of parrots, and other birds, as well as the paca godi and wild swine. They describe the torment which the planter and naturalists suffer from the mosquitoes and the devastation of the ants and blattae. They speak of the dangers to which they were exposed from the jaguar, the poisonous serpents, crocodiles, scorpions, centipedes, and spiders. But, with the increasing population and cultivation of the country, say these naturalists, these evils will gradually diminish. When the inhabitants have cut down the woods, drained the marshes, made roads in all directions, and founded villages and towns, man will by degrees triumph over the rank vegetation and noxious animals, and all the elements will second and amply recompense his activity. The number of human beings now peopling the earth is supposed to amount to 800 millions, so that we may easily understand how great a number of beasts of prey, birds, and animals of every class this prodigious population must have displaced, independently of the still more important consequences which have followed from the derangement brought about by man in the relative numerical strength of particular species. Indigenous quadrupeds and birds extirpated in Great Britain. Let us make some inquiries into the extent of the influence which the progress of society has exerted during the last 7 or 8 centuries in altering the distribution of indigenous British animals. Dr. Fleming has prosecuted this inquiry with his usual zeal and ability, and in a memoir on the subject has enumerated the best authenticated examples of the decrease or extirpation of certain species during a period when our population has made the most rapid advances. I shall offer a brief outline of his results. The stag, as well as the fallow deer and the roe, were formerly so abundant in our island that, according to Leslie, from 500 to 1,000 were sometimes slain at a hunting match. But the native races would already have been extinguished had they not been carefully preserved in certain forests. The otter, the marten, and the polecat were also in sufficient numbers to be pursued for the sake of their fur, but they have now been reduced within very narrow bounds. The wild cat and the fox have also been sacrificed throughout the greater part of the country for the security of the poultry yard or the fold. Badgers have been expelled from every district which at former periods they inhabited. Besides these which have been driven out from their favourite haunts and everywhere reduced in number, there are some which have been wholly extirpated, such as the ancient breed of indigenous horses and the wild boar. Of the wild oxen, a few remains are still preserved in some of the old English parks. The beaver, which is eagerly sought after for its fur, had become scarce at the close of the 9th century, and by the 12th century was only to be met with, according to Giraldus de Barry, in one river in Wales and another in Scotland. The wolf, once so much dreaded by our ancestors, is said to have maintained its ground in Ireland so late as the beginning of the 18th century, 1710, though it had been extirpated in Scotland 30 years before, and in England at a much earlier period. The bear, which in Wales was regarded as a beast of the chase equal to the hare or the boar, only perished as a native of Scotland in the year 1057. Many native birds of prey have also been the subjects of unremitting persecution. The eagles, larger hawks, and ravens have disappeared from the more cultivated districts. The haunts of the mallard, the snipe, the redshank, and the bittern have been drained equally with the summer dwellings of the lapwing and the curlew. But these species still linger in some portion of the British Isles, whereas the larger capercailzies, or wood grouse, formerly natives of the pine forests of Ireland and Scotland, have been destroyed within the last 60 years. The egret and the crane, which appear to have been formerly very common in Scotland, are now only occasional visitants. The bustard, Otis tarda, observes Graves, in his British Ornithology, was formerly seen in the dawns and heaths of various parts of our island, in flocks of 40 or 50 birds, whereas it is now a circumstance of rare occurrence to meet with a single individual. Bewick also remarks that they were formerly more common in this island than at present. They are now found only in the open counties of the south and east, in the plates of Wiltshire, Dorsetshire, and some parts of Yorkshire. In the few years that have elapsed since Bewick wrote, this bird has entirely disappeared from Wiltshire and Dorsetshire. These changes, it may be observed, are derived from very imperfect memorials, and relate only to the larger and more conspicuous animals inhabiting a small spot on the globe. But they cannot fail to exalt our conception of the enormous revolutions which, in the course of several thousand years, the whole human species must have effected. Extinction of the dodo. The kangaroo and the emu are retreating rapidly before the progress of colonization in Australia, and it is scarcely admits of doubt that the general cultivation of that country must lead to the extirpation of both. The most striking example of the loss, even within the last 2 centuries, of a remarkable species is that of the dodo. a bird first seen by the Dutch when they landed on the Isle of France, at that time uninhabited, immediately after the discovery of the passage to the East Indies by the Cape of Good Hope. It was of a large size and singular form, its wings short, like those of an ostrich, and wholly incapable of sustaining its heavy body, even for a short flight. In its general appearance, it differed from the ostrich, cassowary, or any known bird. Many naturalists gave figures of the dodo after the commencement of the 17th century, and there is a painting of it in the British Museum, which is said to have been taken from a living individual. Beneath the painting is a leg, in a fine state of preservation, which ornithologists are agreed cannot belong to any other known bird. In the museum at Oxford, also, there is a foot and a head in an imperfect state. In spite of the most active search during the last century, no information respecting the dodo was obtained, and some authors have gone so far as to pretend that it never existed. But a great mass of satisfactory evidence in favor of its recent existence has now been collected by Mr. Brodripp and by Mr. Strickland and Dr. Melville. Mr. Strickland, agreeing with Professor Reinhardt of Copenhagen in referring the dodo to the Columbidae, calls it a vulture-like frugivorous pigeon. It appears also that another short-winged bird of the same order, called the solitaire, inhabited the small island of Rodriguez 300 miles east of the Mauritius, and has been exterminated by man, as have one or two different but ally birds of the Isle of Bourbon. Rapid propagation of domestic quadrupeds over the American continent. Next to the direct agency of man, his indirect influence in multiplying the numbers of large herbivorous quadrupeds of domesticated races may be regarded as one of the most obvious causes of the extermination of species. On this and on several other grounds, the introduction of the horse, ox, and other mammalia into America and their rapid propagation over that continent within the last 3 centuries is a fact of great importance in natural history. The extraordinary herds of wild cattle and horses which overran the plains of South America sprung from a very few pairs first carried over by the Spaniards, and they prove that the wide geographical range of large species in great continents does not necessarily imply that they have existed there from remote periods. Humboldt observes in his travels on the authority of Azara that it is believed there exist in the pampas of Buenos Aires 12 million cows and 3 million horses, without comprising in this enumeration the cattle that have no acknowledged proprietor. In the llanos of Caracas, the rich hateros, or proprietors of pastoral farms, are entirely ignorant of the number of cattle they possess. The young are branded with the mark peculiar to each herd, and some of the most wealthy owners mark as many as 14,000 a year. In the northern plains from the Orinoco to the lake of Maracaibo, M. de Pons reckoned that 1,200,000 oxen, 180,000 horses, and 90,000 mules wandered at large. In some parts of the valley of the Mississippi, especially in the country of the Osage Islands, wild horses are immensely numerous. The establishment of black cattle in America dates from Columbus's second voyage to St. Domingo. They there multiplied rapidly, and that island presently became a kind of nursery from which these animals were successively transported to various parts of the continental coast and from thence into the interior. Notwithstanding these numerous exportations, in 27 years after the discovery of the island, herds of 4,000 head, as we learn from Oviedo, were not uncommon, and there were even some that amounted to 8,000. In 1587, the number of hides exported from St. Domingo alone, according to Acosta's report, was 35,444. And in the same year there were exported 64,350 from the ports of New Spain. This was in the 65th year after the taking of Mexico, previous to which event the Spaniards, who came into that country, had not been able to engage in anything else than war. Everyone is aware that these animals are now established throughout the American continent, from Canada to the Straits of Magellan. The ass has thriven very generally in the New World, and we learn from Ulloa that in Quito they ran wild and multiplied in amazing numbers, so as to become a nuisance. They grazed together in herds and when attacked defended themselves with their mouths. If a horse happened to stray into the place where they fed, they all fell upon him and did not cease biting and kicking till they left him dead. The first hogs were carried to America by Columbus and established in the island of St. Domingo the year following its discovery, in November 1493. In succeeding years, they were introduced into other places where the Spaniards settled, and in the space of half a century they were found established in the New World from the latitude of 25 degrees north to the 40th degree of south latitude. Sheep also and goats were multiplied enormously in the New World, as have also the cat and the rat, which last, as before stated, has been imported unintentionally in ships. The dogs introduced by man, which have at different periods become wild in America, hunted in packs like the wolf and the jackal, destroying not only hogs, but the calves and foals of the wild cattle and horses. Ulloa in his voyage and Buffon on the authority of old writers relate a fact which illustrates very clearly the principle before explained, of the check which the increase of one animal necessarily offers to that of another. The Spaniards had introduced goats into the island of Juan Fernandez, where they became so prolific as to furnish the pirates who infested these seas with provisions. In order to cut off this resource from the buccaneers, a number of dogs were turned loose into the island, and so numerous did they become in their turn that they destroyed the goats in every accessible part, after which the number of wild dogs again decreased. Increase of reindeer imported into Iceland. As an example of the rapidity with which a large tract may become peopled by the offspring of a single pair of quadrupeds, it may be mentioned that in the year 1773, 13 reindeer were exported from Norway, only 3 of which reached Iceland. These were turned loose into the mountains of Goldbridge-Sicel, where they multiplied so greatly in the course of 40 years that it was not uncommon to meet with herds consisting of from 40 to 100 in various districts. The reindeer, observes a modern writer, is in Lapland a loser by his connection with man, but Iceland will be this creature's paradise. There is in the interior a tract which Sir G. Mackenzie computes at not less than 40,000 square miles, without a single human habitation, and almost entirely unknown to the natives themselves. There are no wolves, the Icelanders will keep out the bears, and the reindeer, being almost unmolested by man, will have no enemy whatever, unless it has brought with it its own tormenting gadfly. Besides the quadrupeds before enumerated, our domestic foals have also succeeded in the West Indies and America, where they have the common fowl, the goose, the duck, the peacock, the pigeon, and the guinea fowl. As these were often taken suddenly from the temperate to very hot regions, they were not reared at first without much difficulty, but after a few generations they became familiarized to the climate, which in many cases approached much nearer than that of Europe to the temperature of their original native countries. The fact of so many millions of wild and tamed individuals of our domestic species, almost all of them the largest quadrupeds and birds, having been propagated throughout the new continent within the short period that has elapsed since the discovery of America, while no appreciable improvement can have been made in the productive powers of that vast continent, affords abundant evidence of the extraordinary changes which accompany the diffusion and progressive advancement of the human race over the globe. That it should have remained for us to witness such mighty revolutions is a proof, even if there was no other evidence, that the entrance of man into the planet is, comparatively speaking, of extremely modern date, and that the effects of his agency are only beginning to be felt. Population which the globe is capable of supporting. A modern writer has estimated that there are in America upwards of 4 million square miles of useful soil, each capable of supporting 200 persons, and nearly 6 million, each mile capable of supporting 490 persons. If this conjecture be true, it will follow, as that author observes, that if the natural resources of America were fully developed, it would afford sustenance to 5 times as great a number of inhabitants as the entire mass of human beings existing at present upon the globe. The new continent, he thinks, though less than half the size of the old, contains an equal quantity of useful soil and much more than an equal amount of productive power. Be this as it may, we may safely conclude that the amount of human population now existing constitutes but a small proportion of that which the globe is capable of supporting, or which it is destined to sustain at no distant period by the rapid progress of society, especially in America, Australia, and certain parts of the old continent. Power of exterminating species, no prerogative of man. But if we reflect that many millions of square miles of the most fertile land, occupied originally by a boundless variety of animal and vegetable forms, have been already brought under the dominion of man and compelled, in a great measure, to yield nourishment to him, and to a limited number of plants and animals which he has caused to increase, we must at once be convinced that the annihilation of a multitude of species has already been effected, and will continue to go on hereafter, in certain regions, in a still more rapid ratio as the colonies of highly civilized nations spread themselves over unoccupied lands. Yet, if we wield the sword of extermination as we advance, we have no reason to repine at the havoc committed, nor to fancy, with the Scottish poet, that we violate the social union of nature, or complain, with the melancholy Jacques, that we are mere usurpers, tyrants, and what's worse, to fright the animals and to kill them up in their assigned and native dwelling place. We have only to reflect that in thus obtaining possession of the earth by conquest and defending our acquisitions by force, we exercise no exclusive prerogative. Every species which has spread itself from a small point over a wide area must, in like manner, have marked its progress by the diminution or the entire extirpation of some other, and must maintain its ground by a successful struggle against the encroachments of other plants and animals. That minute parasitic plant, called the rust in wheat, has, like the Hessian fly, the locust, and the aphis, caused famines ere now amongst the lords of the creation. The most insignificant and diminutive species, whether in the animal or vegetable kingdom, have each slaughtered their thousands as they disseminated themselves over the globe, as well as the lion when first it spread itself over the tropical regions of Africa. Concluding remarks. Although we have as yet considered one class only of the causes, the organic, by which species may become exterminated, yet it cannot but appear evident that the continued action of these alone, throughout myriads of future ages, must work an entire change in the state of the organic creation, not merely on the continents and islands, where the power of man is chiefly exerted, but in the great ocean, where his control is almost unknown. The mind is prepared by the contemplation of such future revolutions to look for the signs of others, of an analogous nature, in the monuments of the past. Instead of being astonished at the proofs there manifested of endless mutations in the animate world, they will appear to one who has thought profoundly of the fluctuations now in progress to afford evidence in favor of the uniformity of the system, unless indeed we are precluded from speaking of uniformity when we characterize a principle of endless variation. End of chapter 41. Recording by Sycamore Rockwell. www.voinovvoiceovers.com.
Chapter 42, Part 1 of Principles of Geology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Availle in March 2018. Principles of Geology by Charles Lyell. Chapter 42. Extinction of Species. Influence of Inorganic Causes. Part 1. Powers of diffusion indispensable that each species may maintain its ground. How changes in physical geography affect the distribution of species. Rate of the change of species due to this cause cannot be uniform. Every change in the physical geography of large regions tends to the extinction of species. Effects of a general alteration of climate on the migration of species. Gradual refrigeration would cause species in the northern and southern hemispheres to become distinct. Elevation of temperature the reverse. Effects on the condition of species which must result from inorganic changes inconsistent with the theory of transmutation. Powers of diffusion indispensable that each species may maintain its ground. Having shown in the last chapter how considerably the numerical increase or the extension of the geographical range of any one species must derange the numbers and distribution of others, let us now direct our attention to the influence which the inorganic causes described in the second book are continually exerting on the habitations of species. So great is the instability of the earth's surface that if nature were not continually engaged in the task of sowing seeds and colonizing animals, the depopulation of a certain portion of the habitable sea and land would in a few years be considerable. Whenever a river transports sediment into a lake or sea, so as materially to diminish its depth, the aquatic animals and plants which delight in deep water are expelled. The tract, however, is not allowed to remain useless, but is soon peopled by species which require more light and heat and thrive where the water is shallow. Every addition made to the land by the encroachment of the delta of a river banishes many subaqueous species from their native abodes, but the new formed plain is not permitted to lie unoccupied, being instantly covered with terrestrial vegetation. The ocean devours continuous lines of sea coasts and precipitates forests or rich pasture land into the waves, but this space is not lost to the animate creation, for shells and seaweeds soon adhere to the new-made cliffs, and numerous fish people the channel which the current has scooped out for itself. No sooner has a volcanic island been thrown up that some lichens begin to grow upon it, and it is sometimes clothed with verdure, while smoke and ashes are still occasionally thrown from the crater. The cocoa, pandanus, and mangrove take root upon the coral reef before it has fairly risen above the waters. The burning stream of lava that descends from Etna rolls through the stately forest, and converts to ashes every tree and herb which stands in its way, but the black strip of land thus desolated is covered again in the course of time, with oaks, pines, and chestnuts, as luxuriant as those which the fiery torrent swept away. Every flood and landslip, every wave which a hurricane or earthquake throws upon the shore, every shower of volcanic dust and ashes which buries a country far and wide to the depth of many feet, every advance of the sand flood, every conversion of salt water into fresh when rivers alter their main channel of discharge, every permanent variation in the rise or fall of tides in an estuary, these and countless other causes displace, in the course of a few centuries, certain plants and animals from stations which they previously occupied. If, therefore, the author of nature had not been prodigal to those numerous contrivances before alluded to, for spreading all classes of organic beings over the earth, if he had not ordained that the fluctuations of the animate and inanimate creation should be in perfect harmony with each other, it is evident that considerable spaces, now the most habitable on the globe, would soon be as devoid of life as are the alpine snows, or the dark abysses of the ocean, or the moving sands of the Sahara. The powers, then, of migration and diffusion conferred on animals and plants are indispensable to enable them to maintain their ground, and would be necessary, even though it were never intended that a species should gradually extend its geographical range. But a facility of shifting their quarters being once given, it cannot fail to happen that the inhabitants of one province should occasionally penetrate into some other, since the strongest of those barriers, which I before described as separating distinct regions, are all liable to be thrown down, one after the other, during the vicissitudes of the earth's surface. How changes in physical geography affect the distribution of species. The numbers and distribution of particular species are affected in two ways by changes in the physical geography of the earth. First, these changes promote or retard the migrations of species. Secondly, they alter the physical conditions of the localities which species inhabit. If the ocean should gradually wear its way through an isthmus, like that of Suez, it would open a passage for the intermixture of the aquatic tribes of two seas previously disjoined, and at the same time close a free communication which the terrestrial plants and animals of two continents had before enjoyed. These would be, perhaps, the most important consequences in regard to the distribution of species, which would result from the breach made by the sea in such a spot. But there would be others of a distinct nature, such as the conversion of a certain tract of land, which formed the isthmus, into sea. This space, previously occupied by terrestrial plants and animals, would be immediately delivered over to the aquatic, a local revolution which might have happened in innumerable other parts of the globe, without being attended by any alteration in the blending together of species of two distinct provinces. Rate of change of species cannot be uniform. This observation leads me to point out one of the most interesting conclusions to which we are led by the contemplation of the vicissitudes of the inanimate world in relation to those of the animate. It is clear that, if the agency of inorganic causes be uniform, as I have supposed, they must operate very irregularly on the state of organic beings, so that the rate according to which these will change in particular regions will not be equal in equal periods of time. I am not about to advocate the doctrine of general catastrophes recurring at certain intervals, as in the ancient Oriental cosmogonies, nor do I doubt that, if very considerable periods of equal duration could be compared one with another, the rate of change in the living, as well as in the inorganic world, might be nearly uniform. But if we regard each of the causes separately, which we know to be at present the most instrumental in remodeling the state of the surface, we shall find that we must expect each to be in action for thousands of years, without producing any extensive alterations in the habitable surface, and then to give rise, during a very brief period, to important revolutions. Illustration derived from subsidences. I shall illustrate this principle by a few of the most remarkable examples which present themselves. In the course of the last century, as we have seen, a considerable number of instances are recorded of the solid surface, whether covered by water or not, having been permanently sunk or upraised by subterranean movements. Most of these convulsions are only accompanied by temporary fluctuations in the state of limited districts, and a continued repetition of these events for thousands of years might not produce any decided change in the state of many of those great zoological or botanical provinces of which I have sketched the boundaries. When, for example, large parts of the ocean and even of inland seas are 1,000 fathoms or upwards in depth, it is a matter of no moment to the animate creation that vast tracts should be heaved up many fathoms at certain intervals, or should subside to the same amount. Neither can any material revolution be produced in South America, either in the terrestrial or the marine plants or animals, by a series of shocks on the coast of Chile, each of which, like that of Penco in 1751, should uplift the coast about 25 feet. Nor if the ground sinks 50 feet at a time, as in the harbor of Port Royal in Jamaica in 1692, will such alterations of level work any general fluctuations in the state of organic beings inhabiting the West Indian Islands or the Caribbean Sea. It is only when the subterranean powers, by shifting gradually the points where their principal force is developed, happen to strike upon some particular region, where a slight change of level immediately affects the distribution of land and water, or the state of the climate, or the barriers between distinct groups of species over extensive areas, that the rate of fluctuation becomes accelerated, and may, in the course of a few years or centuries, work mightier changes than had been experienced in myriads of antecedent years. Thus, for example, a repetition of subsidences causing the narrow isthmus of Panama to sink down a few hundred feet would, in a few centuries, bring about a great revolution in the state of the animate creation in the Western Hemisphere. Thousands of aquatic species would pass, for the first time, from the Caribbean Sea into the Pacific, and thousands of others, before peculiar to the Pacific Ocean, would make their way into the Caribbean Sea, the Gulf of Mexico, and the Atlantic. A considerable modification would probably be occasioned by the same event in the direction or volume of the Gulf Stream, and thereby the temperature of the sea and the contiguous lands may be altered as far as the influence of that current extends. A change of climate might thus be produced in the ocean from Florida to Spitzbergen, and in many countries of North America, Europe, and Greenland. Not merely the heat, but the quantity of rain which falls would be altered in certain districts, so that many species would be excluded from tracts where they before flourished. Others would be reduced in number, and some would thrive more and multiply. The seeds also and the fruits of plants would no longer be drifted in precisely the same directions, nor the eggs of aquatic animals. Neither would species be any longer impeded in their migrations towards particular stations before shut out from them by their inability to cross the mighty current. Let us take another example from a part of the globe which is at present liable to suffer by earthquakes, namely the low sandy tract which intervenes between the Sea of Azov and the Caspian. If there should occur a sinking down to a trifling amount, and such ravines should be formed as might be produced by a few earthquakes, not more considerable than have fallen within our limited observation during the last 150 years, the waters of the Sea of Azov would pour rapidly into the Caspian, which, according to the measurements lately made by the Academy of St. Petersburg, is 84 feet below the level of the Black Sea. The Sea of Azov would immediately borrow from the Black Sea, that sea again from the Mediterranean, and the Mediterranean from the Atlantic, so that an inexhaustible current would pour down into the low tracts of Asia bordering the Caspian, by which all the sandy salt steppes adjacent to that sea would be inundated. An area of several thousand square leagues, now below the level of the Mediterranean, would be converted from land into sea. Illustration derived from the elevation of land. Let us next imagine a few cases of the elevation of land of small extent at certain critical points, as, for example, in the shallowest part of the Straits of Gibraltar, where the deepest soundings from the African to the European side give only 220 fathoms. In proportion as this submarine barrier of rock was upheaved, the whole channel would be contracted in width and depth, and the volume of water which the current constantly flowing from the Atlantic pours into the Mediterranean would be lessened. But the loss of the inland sea by evaporation would remain the same, so that being no longer able to draw on the ocean for a supply sufficient to restore its equilibrium, it must sink, and leave dry a certain portion of land around its borders. The current which now flows constantly out of the Black Sea into the Mediterranean would then rush in more rapidly, and the level of the Mediterranean would be thereby prevented from falling so low, but the level of the Black Sea would, for the same reason, sink, so that when, by a continued series of elevatory movements, the Straits of Gibraltar had become completely closed up, we might expect large and level sandy steppes to surround both the Black Sea and Mediterranean, like those occurring at present on the skirts of the Caspian and the Lake of Aral. The geographical range of hundreds of aquatic species would be thereby circumcised, and that of hundreds of terrestrial plants and animals extended. A line of submarine volcanoes crossing the channel of some strait, and gradually choking it up with ashes and lava, might produce a new barrier as effectually as a series of earthquakes, especially if thermal springs, charged with carbonate of lime, silica, and other mineral ingredients, should promote the rapid multiplication of corals and shells, and cement them together with solid matter precipitated during the intervals between eruptions. Suppose in this manner a stoppage to be caused of the Bahama Channel between the bank of that name and the coast of Florida. This insignificant revolution, confined to a mere spot in the bottom of the ocean, would, by diverting the main current of the Gulf Stream, give rise to extensive changes in the climate and distribution of animals and plants inhabiting the northern hemisphere. Illustration from the formation of new islands. A repetition of elevatory movements of earthquakes might continue over an area as extensive as Europe for thousands of ages at the bottom of the ocean in certain regions and produce no visible effects, whereas, if they should operate in some shallow parts of the Pacific amid the coral archipelagos, they would soon give birth to a new continent. Hundreds of volcanic islands may be thrown up and become covered with vegetation, without causing more than local fluctuations in the animate world. But if a chain like the Aleutian Archipelago or the Kurile Isles run for a distance of many hundred miles, so as to form an almost uninterrupted communication between two continents or two distant islands, the migration of plants, birds, insects, and even of some quadrupeds may cause, in a short term, an extraordinary series of revolutions tending to augment the range of some animals and plants and to limit that of others. A new archipelago might be formed in the Mediterranean, the Bay of Biscay, and 1,000 other places, and might produce less important events than one rock which should rise up between Australia and Java, so placed that winds and currents might cause an interchange of the plants, insects, and birds. From the wearing through of an isthmus. If we turn from the igneous to the aqueous agents, we find the same tendency to an irregular rate of change, naturally connected with the strictest uniformity in the energy of those causes. When the sea, for example, gradually encroaches upon both sides of a narrow isthmus, as that of Schleswig, separating the North Sea from the Baltic, where, as before stated, the cliffs on both the opposite coasts are wasting away, no material alteration results for thousands of years, save only that there is a progressive conversion of a small strip of land into water. A few feet only, or a few yards, are annually removed, but if, at last, the partition should be broken down, and the tides of the ocean should enter by a direct passage into the inland sea, instead of going by a circuitous route through the Kattegat, a body of salt water would sweep up as far as the gulfs of Bothnia and Finland, the waters of which are now brackish or almost fresh, and this revolution would be attended by the local annihilation of many species. Similar consequences must have resulted on a small scale when the sea opened its way through the isthmus of Staveren in the 13th century, forming a union between an inland lake and the ocean, and opening, in the course of 1 century, a shallow strait more than half as wide as the narrowest part of that which divides England from France. Changes in physical geography which must occasion extinction of species. It will almost seem superfluous, after I have thus traced the important modifications in the condition of living beings which flow from changes of trifling extent, to argue that entire revolutions might be brought about if the climate and physical geography of the whole globe were greatly altered. It has been stated that species are in general local, some being confined to extremely small spots, and depending for their existence on a combination of causes, which, if they are to be met with elsewhere, occur only in some very remote region. Hence it must happen that, when the nature of these localities is changed, the species will perish, for it will rarely happen that the cause which alters the character of the district will afford new facilities to the species to establish itself elsewhere. End of Chapter 42, Part 1. Chapter 42, Part 2 of Principles of Geology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Availle in March 2018. Principles of Geology by Charles Lyell. Chapter 42, Part 2. African Deserts. If we attribute the origin of a great part of the desert of Africa to the gradual progress of moving sands driven eastward by the westerly winds, we may safely infer that a variety of species must have been annihilated by this cause alone. The sand flood has been inundating, from time immemorial, some of the rich lands on the west of the Nile, and we have only to multiply this effect a sufficient number of times in order to understand how, in the lapse of ages, a whole group of terrestrial animals and plants may become extinct. The African desert, without including Bornu and Darfur, extends, according to the calculation of Humboldt, over 194,000 square leagues, an area nearly 3 times as great as that of France. In a small portion of so vast a space, we may infer from analogy that there were many peculiar species of plants and animals which must have been banished by the sand, and their habitations invaded by the camel, and by birds and insects formed for the arid sands. There is evidently nothing in the nature of the catastrophe to favor the escape of the former inhabitants to some adjoining province, nothing to weaken, in the bordering lands, that powerful barrier against emigration, pre-occupancy. Nor, even if the exclusion of a certain group of species from a given tract were compensated by an extension of their range over a new country, would that circumstance tend to the conservation of species in general, for the extirpation would merely then be transferred to the region so invaded. If it be imagined, for example, that the aboriginal quadrupeds, birds, and other animals of Africa emigrated in consequence of the advance of drift sand and colonized Arabia, the indigenous Arabian species must have given way before them and have been reduced in number or destroyed. Let us next suppose that, in some central or more elevated parts of the great African desert, the upheaving power of subterranean movements should be exerted throughout an immense series of ages, accompanied, at certain intervals, by volcanic eruptions, such as gave rise at once, in 1755, to a mountain 1,600 feet high on the Mexican plateau. When the continued repetition of these events had caused a mountain chain, it is obvious that a complete transformation in the state of the climate would be brought about throughout a vast area. We may imagine the summits of the new chain to rise so high as to be covered, like Mount Atlas, for several thousand feet with snow during a great part of the year. The melting of these snows during the greatest heat would cause the rivers to swell in the season when the greatest drought now prevails. The waters, moreover, derived from this source, would always be of lower temperature than the surrounding atmosphere, and would thus contribute to cool the climate. During the numerous earthquakes and volcanic eruptions supposed to accompany the gradual formation of the chain, there would be many floods caused by the bursting of temporary lakes and by the melting of snows by lava. These inundations might deposit alluvial matter far and wide over the original sands, as the country assumed varied shapes and was modified again and again by the moving power from below and the aqueous erosion of the surface above. At length the Sahara might be fertilized, irrigated by rivers, and streamlets intersecting it in every direction, and covered by jungle and morasses, so that the animals and plants which now people northern Africa would disappear, and the region would gradually become fitted for the reception of a population of species perfectly dissimilar in their forms, habits, and organization. There are always some peculiar and characteristic features in the physical geography of each large division of the globe, and on these peculiarities the state of animal and vegetable life is dependent. If, therefore, we admit incessant fluctuations in the physical geography, we must, at the same time, concede the successive extinction of terrestrial and aquatic species to be part of the economy of our system. When some great class of stations is in excess in certain latitudes, as, for example, in wide savannas, arid sands, lofty mountains, or inland seas, we find a corresponding development of species adapted for such circumstances. In North America, where there is a chain of vast inland lakes of fresh water, we find an extraordinary abundance and variety of aquatic birds, freshwater fish, testacea, and small amphibious reptiles, fitted for such a climate. The greater part of these would perish if the lakes were destroyed, an event that might be brought about by some of the least of those important revolutions contemplated in geology. It might happen that no freshwater lakes of corresponding magnitude might then exist on the globe, or that, if they occurred elsewhere, they might be situated in New Holland, Southern Africa, Eastern Asia, or some region so distant as to be quite inaccessible to the North American species. Or they might be situated within the tropics, in a climate uninhabitable by creatures fitted for a temperate zone. Or, finally, we may presume that they would be preoccupied by indigenous tribes. A vivid description has been given by Mr. Darwin and Sir W. Parrish of the great droughts which have sometimes visited the pampas of South America, for 3 or 4 years in succession, during which an incredible number of wild animals, cattle, horses, and birds have perished from want of food and water. Several 100,000 animals were drowned in the Parana alone, having rushed into the river to drink, and being too much exhausted by hunger to escape. Such droughts are often attended in South America and other hot climates by wide-spreading conflagrations caused by lightning, which fires the dried grass and brushwood. Thus quadrupeds, birds, insects, and other creatures are destroyed by myriads. How many species, both of the animal and vegetable world, which once flourished in the country between the valley of the Parana and the Straits of Magellan, may not have been annihilated since the first drought or first conflagration began? To pursue this train of reasoning farther is unnecessary. The geologist has only to reflect on what has been said of the habitations and stations of organic beings in general, and to consider them in relation to those effects which were contemplated in the second book, as resulting from the igneous and aqueous causes now in action, and he will immediately perceive that, amidst the vicissitudes of the earth's surface, species cannot be immortal, but must perish, one after the other, like the individuals which compose them. There is no possibility of escaping from this conclusion without resorting to some hypothesis as violent as that of Lamarck, who imagined, as we have before seen, that species are each of them endowed with indefinite powers of modifying their organization, in conformity to the endless changes of circumstances to which they are exposed. Effects of a general alteration in climate on the distribution of species. Some of the effects which must attend every general alteration of climate are sufficiently peculiar to claim a separate consideration before concluding the present chapter. I have before stated that, during seasons of extraordinary severity, many northern birds, and in some countries many quadrupeds, migrate southwards. If these cold seasons were to become frequent, in consequence of a gradual and general refrigeration of the atmosphere, such migrations would be more and more regular, until, at length, many animals, now confined to the Arctic regions, would become the tenants of the temperate zone, while the inhabitants of the temperate zone would approach nearer to the equator. At the same time, many species previously established on high mountains would begin to descend, in every latitude, towards the middle regions, and those which were confined to the flanks of mountains would make their way into the plains. Analogous changes would also take place in the vegetable kingdom. If, on the contrary, the heat of the atmosphere be on the increase, the plants and animals of low grounds would ascend to higher levels, the equatorial species would migrate into the temperate zone, and those of the temperate into the Arctic Circle. But although some species might thus be preserved, every great change of climate must be fatal to many which can find no place of retreat when their original habitations become unfit for them. For if the general temperature be on the rise, then there is no cooler region whither the polar species can take refuge. If it be on the decline, then the animals and plants previously established between the tropics have no resource. Suppose the general heat of the atmosphere to increase, so that even the Arctic region became too warm for the musk ox and reindeer, it is clear that they must perish. So if the torrid zone should lose so much of its heat by the progressive refrigeration of the earth's surface as to be an unfit habitation for apes, boas, bamboos, and palms, these tribes of animals and plants, or at least most of the species now belonging to them, would become extinct, for there would be no warmer latitudes for their reception. It will follow, therefore, that as often as the climates of the globe are passing from the extreme of heat to that of cold, from the summer to the winter of the great year before alluded to, the migratory movement will be directed constantly from the poles towards the equator, and for this reason the species inhabiting parallel latitudes, in the northern and southern hemispheres, must become widely different. For I assume, on grounds before explained, that the original stock of each species is introduced into one spot of the earth only, and consequently no species can be at once indigenous in the Arctic and Antarctic circles. But when, on the contrary, a series of changes in the physical geography of the globe, or any other supposed cause, occasions an elevation of the general temperature, when there is a passage from the winter to one of the vernal or summer seasons of the great cycle of climate, then the order of the migratory movement is inverted. The different species of animals and plants direct their course from the equator towards the poles, and the northern and southern hemispheres may become peopled to a certain limited extent by identical species. I say limited, because we cannot speculate on the entire transposition of a group of animals and plants from tropical to polar latitudes, or the reverse, as a probable or even possible event. We may believe the mean annual temperature of one zone to be transferable to another, but we know that the same climate cannot be so transferred. Whatever be the general temperature of the Earth's surface, comparative equability of heat will characterize the tropical regions, while great periodical variations will belong to the temperate and still more to the polar latitudes. These and many other peculiarities connected with heat and light depend on fixed astronomical causes, such as the motion of the Earth and its position in relation to the Sun, and not on those fluctuations of its surface which may influence the general temperature. Among many obstacles to such extensive transference of habitations, we must not forget the immense lapse of time required, according to the hypotheses before suggested, to bring about a considerable change in climate. During a period so vast, the other cause of extirpation, before enumerated, would exert so powerful an ignorance as to prevent all, save a very few hardy species, from passing from equatorial to polar regions, or from the tropics to the pole. But the power of accommodation to new circumstances is great in certain species, and might enable many to pass from one zone to another if the mean annual heat of the atmosphere and the ocean were greatly altered. To the marine tribes especially such a passage would be possible, for they are less impeded in their migrations by barriers of land than are the terrestrial by the ocean. Add to this that the temperature of the ocean is much more uniform than that of the atmosphere investing the land, so that we may easily suppose that most of the testacea, fish, and other classes might pass from the equatorial into the temperate regions, if the mean temperature of those regions were transposed, although a second expatriation of these species of tropical origin into the Arctic and Antarctic circles would probably be impossible. Let us now consider more particularly the effect of vicissitudes of climate in causing one species to give way before the increasing numbers of some other. When temperature forms the barrier which arrests the progress of an animal or plant in a particular direction, the individuals are fewer and less vigorous as they approach the extreme confines of the geographical range of the species. But these stragglers are ready to multiply rapidly on the slightest increase or diminution of heat that may be favorable to them, just as particular insects increase during a hot summer, and certain plants and animals gain ground after a series of congenial seasons. In almost every district, especially if it be mountainous, there are a variety of species, the limits of whose habitations are conterminous, some being unable to proceed farther without encountering too much heat, others too much cold. Individuals which are thus on the borders of the regions proper to their respective species are like the outposts of hostile armies, ready to profit by every slight change of circumstances in their favor, and to advance upon the ground occupied by their neighbors and opponents. The proximity of distinct climates produced by the inequalities of the earth's surface brings species possessing very different constitutions into such immediate contact that their naturalizations are very speedy whenever opportunities of advancing present themselves. Many insects and plants, for example, are common to low plains within the Arctic Circle and to lofty mountains in Scotland and other parts of Europe. If the climate, therefore, of the polar regions were transferred to our own latitudes, the species in question would immediately descend from these elevated stations to overrun the low grounds. Invasions of these kind, attended by the expulsion of the pre-occupants, are almost instantaneous, because the change of temperature not only places the one species in a more favorable position, but renders the others sickly and almost incapable of defense. These changes inconsistent with the theory of transmutation. Lamarck, when speculating on the transmutation of species, supposed every modification in organization and instinct to be brought about slowly and insensibly in an indefinite lapse of ages. But he does not appear to have sufficiently considered how much every alteration in the physical condition of the habitable surface changes the relations of a great number of coexisting species, and that some of these would be ready instantly to avail themselves of the slightest change in their favor, and to multiply to the injury of others. Even if we thought it possible that the palm or the elephant, which now flourish in equatorial regions, could ever learn to bear the variable seasons of our temperate zone, or the rigors of an Arctic winter, we might with no less confidence affirm that they must perish before they had time to become habituated to such new circumstances. That they would be displaced by other species as often as the climate varied may be inferred from the data before explained respecting the local extermination of species produced by the multiplication of others. Suppose the climate of the highest part of the woody zone of Etna to be transferred to the seashore of the base of the mountain. No botanist would anticipate that the olive, lemon tree, and prickly pear, Cactus opuntia, would be able to contend with the oak and chestnut, which would begin forthwith to descend to a lower level, or that these last would be able to stand their ground against the pine, which would also, in the space of a few years, begin to occupy a lower position. We might form some kind of estimate of the time which might be required for the migrations of these plants, whereas we have no data for concluding that any number of thousands of years would be sufficient for one step in the pretended metamorphosis of one species into another, possessing distinct attributes and qualities. This argument is applicable not merely to climate, but to any other cause of mutation. However slowly a lake may be converted into a marsh, or a marsh into a meadow, it is evident that before the lacustrine plants can acquire the power of living in marshes, or the marsh plants of living in a less humid soil, other species, already existing in the region and fitted for these several stations, will intrude and keep possession of the ground. So, if a tract of salt water becomes fresh by passing through every intermediate degree of brackishness, still the marine mollusks will never be permitted to be gradually metamorphosed into fluviatile species, because long before any such transformation can take place by slow and insensible degrees, other tribes, already formed to delight in brackish or fresh water, will avail themselves of the change in the fluid, and will, each in their turn, monopolize the space. It is idle, therefore, to dispute about the abstract possibility of the conversion of one species into another, when there are known causes so much more active in their nature, which must always intervene and prevent the actual accomplishment of such conversions. A faint image of the certain doom of a species less fitted to struggle with some new condition in a region which it previously inhabited, and where it has to contend with a more vigorous species, is presented by the extirpation of savage tribes of men by the advancing colony of some civilized nation. In this case, the contest is merely between two different races, two varieties, moreover, of a species which exceeds all others in its aptitude to accommodate its habits to the most extraordinary variations of circumstances. Yet few future events are more certain than the speedy extermination of the Indians of North America and the savages of New Holland in the course of a few centuries, when these tribes will be remembered only in poetry or history. Concluding remarks. We often hear astonishment expressed at the disappearance from the earth in times comparatively modern of many small as well as large animals, the remains of which have been found in a fossil state, under circumstances implying that neither any great geographical revolution nor the exterminating influence of man has intervened to account for their extinction. But in all such cases we should inquire whether we are sufficiently acquainted with the numerous and complicated conditions on which the perpetuation of each species depends, to entitle us to wonder if it should be suddenly cut off. Mr. Darwin, when calling attention to the fact that the horse, Megatherium, Megalonyx, and many contemporary mammalia had perished in South America after that continent had acquired its present configuration, and when, if we may judge by the Testacea, the climate very nearly resembled the present, observes, quote, that in the living creation one species is often extremely rare in a given region, while another of the same genus and with closely allied habits is exceedingly common. A zoologist familiar with such phenomena, if asked to explain them, usually replies that some slight difference in climate, food, or the number of its enemies must determine the relative strength of the two species in question, although we may be unable to point out the precise manner of the action of the check. We are, therefore, driven to the conclusion that causes, generally quite inappreciable by us, determine whether a given species shall be abundant or scanty in numbers. Why, then, should we feel astonishment if the rarity is occasionally carried a step farther, to extinction? End quote. End of Chapter 42, Part 2.
Chapter 43 of Principles of Geology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by deongines, Salt Lake City, Utah. Principles of Geology by Charles Lyell. Chapter 43. Extinction and Creation of Species. Theory of the successive extinction of species consistent with a limited geographical distribution. Opinions of botanists respecting the centers from which plants have been diffused. Whether there are grounds for inferring that the loss, from time to time, of certain animals and plants is compensated by the introduction of new species. Whether any evidence of such new creations could be expected within the historical era. The question whether the existing species have been created in succession must be decided by geological monuments. Successive extinction of species consistent with their limited geographical distribution. In the preceding chapters, I have pointed out the strict dependence of each species of animal and plant on certain physical conditions in the state of the earth's surface, and on the number and attributes of other organic beings inhabiting the same region. I have also endeavored to show that all these conditions are in a state of continual fluctuation, the igneous and aqueous agents remodeling from time to time the physical geography of the globe, and the migrations of species causing new relations to spring up successively between different organic beings. I have deduced as a corollary that the species existing at any particular period must, in the course of ages, become extinct one after the other. They must die out, to borrow an emphatical expression from Buffon, because time fights against them. If the views which I have taken are just, there will be no difficulty in explaining why the habitations of so many species are now restrained within exceedingly narrow limits. Every local revolution, such as those contemplated in the preceding chapter, tends to circumscribe the range of some species, while it enlarges that of others, and if we are led to infer that new species originate in one spot only, each must require time to diffuse itself over a wide area. It will follow, therefore, from the adoption of this hypothesis, that the recent origin of some species and the high antiquity of others are equally consistent with the general fact of their limited distribution, some being local because they have not existed long enough to admit of their wide dissemination, others because circumstances in the animate or inanimate world have occurred to restrict the range which they may once have obtained. As a general rule, however, species common to many distant provinces, or those now found to inhabit very distant parts of the globe, are to be regarded as the most ancient. Numerically speaking, they may not perhaps be largely represented, but their wide diffusion shows that they have had a long time to spread themselves, and have been able to survive many important revolutions in physical geography. After so much evidence has been brought to light by the geologist of land and sea having changed places in various regions since the existing species were in being, we can feel no surprise that the zoologist and botanist have hitherto found it difficult to refer the geographical distribution of species to any clear and determinate principles, since they have usually speculated on the phenomena upon the assumption that the physical geography of the globe had undergone no material alteration since the introduction of the species now living. So long as this assumption was made, the facts relating to the geography of plants and animals appeared capricious in the extreme, and by many the subject was pronounced to be so full of mystery and anomalies that the establishment of a satisfactory theory was hopeless. Centers from which plants have been diffused. Some botanists conceived, in accordance with the hypothesis of Willdenow, that mountains were the centers of creation from which the plants, now inhabiting large continents, have radiated, to which De Candolle and others, with much reason, objected that mountains, on the contrary, are often the barriers between two provinces of distinct vegetation. The geologist who is acquainted with the extensive modifications which the surface of the earth has undergone in very recent geological epochs may be able, perhaps, to reconcile both these theories in their application to different regions. A lofty range of mountains, which is so ancient as to date from a period when the species of animals and plants differed from those now living, will naturally form a barrier between contiguous provinces, but a chain which has been raised, in great part, within the epoch of existing species, and around which new lands have arisen from the sea within that period, will be a centre of peculiar vegetation. In France, observes De Candolle, the Alps and Cevennes prevent a great number of the plants of the south from spreading themselves to the northward. But it has been remarked that some species have made their way through the gorges of these chains, and are found on their northern sides, principally in those places where they are lower and more interrupted. Now, the chains here alluded to have probably been of considerable height ever since the era when the existing vegetation began to appear, and were it not for the deep fissures which divide them, they might have caused much more abrupt terminations to the extension of distinct assemblages of species. Parts of the Italian peninsula, on the other hand, have gained a considerable portion of their present height, since a majority of the marine species now inhabiting the Mediterranean, and probably also since the terrestrial plants of the same region were in being, large tracts of land have been added, both on the Adriatic and Mediterranean side, to what originally constituted a much narrower range of mountains, if not a chain of islands running nearly north and south, like Corsica and Sardinia. It may therefore be presumed that the Apennines have been a centre whence species have diffused themselves over the contiguous lower and newer regions. In this and all analogous situations, the doctrine of Willdenow, that species have radiated from the mountains as from centres, may be well founded. Introduction of new species. If the reader should infer from the facts laid before him in the preceding chapters that the successive extinction of animals and plants may be part of the constant and regular course of nature, he will naturally inquire whether there are any means provided for the repair of these losses. Is it part of the economy of our system that the habitable globe should, to a certain extent, become depopulated
both in the ocean and on the land, or that the variety of species should diminish until some new era arrives when a new and extraordinary effort of creative energy is to be displayed? Or is it possible that new species can be called into being from time to time, and yet that so astonishing a phenomenon can escape the observation of naturalists? Humboldt has characterized these subjects as among the mysteries which natural science cannot reach, and he observes that the investigation of the origin of beings does not belong to zoological or botanical geography. To geology, however, these topics do strictly appertain, and this science is chiefly interested in inquiries into the state of the animate creation as it now exists, with a view of pointing out its relations to antecedent periods when its condition was different. Before offering any hypothesis towards the solution of so difficult a problem, let us consider what kind of evidence we ought to expect, in the present state of science, of the first appearance of new animals or plants, if we could imagine the successive creation of species to constitute, like their gradual extinction, a regular part of the economy of nature. In the first place, it is obviously more easy to prove that a species, once numerously represented in a given district, has ceased to be, than that some other, which did not pre-exist, has made its appearance, assuming always, for reasons before stated, that single stocks only of each animal and plant are originally created, and that individuals of new species do not suddenly start up in many different places at once. So imperfect has the science of natural history remained down to our own times, that within the memory of persons now living, the numbers of known animals and plants have been doubled, or even quadrupled in many classes. New and often conspicuous species are annually discovered in parts of the old continent, long inhabited by the most civilized nations. Conscious, therefore, of the limited extent of our information, we always infer, when such discoveries are made, that the beings in question had previously eluded our research, or had at least existed elsewhere, and only migrated at a recent period into the territories where we now find them. It is difficult, even in contemplation, to anticipate the time when we shall be entitled to make any other hypothesis in regard to all the marine tribes, and to by far the greater number of the terrestrial, such as birds, which possess such unlimited powers of migration. Insects, which, besides the variability of each species in number, are also so capable of being diffused to vast distances. And cryptogamous plants, to which, as to many other classes, both of the animal and vegetable kingdom, similar observations are applicable. What kind of evidence of new creations could be expected? What kind of proofs, therefore, could we reasonably expect to find of the origin, at a particular period, of a new species? Perhaps it may be said in reply that within the last 2 or 3 centuries some forest tree or new quadruped might have been observed to appear suddenly in those parts of England or France which had been most thoroughly investigated, that naturalists might have been able to show that no such living being inhabited any other region of the globe, and that there was no tradition of anything similar having been before observed in the district where it had made its appearance. Now, although this objection may seem plausible, yet its force will be found to depend entirely on the rate of fluctuation which we suppose to prevail in the animate world, and on the proportion which such conspicuous subjects of the animal and vegetable kingdoms
bear to those which are less known and escape our observation. There are perhaps more than 1,000,000 species of plants and animals, exclusive of the microscopic and infusory animalcules now inhabiting the terraqueous globe. The terrestrial plants may amount, says de Candolle, to somewhere between 110,000 and 120,000, but the data on which this conjecture is founded are considered by many botanists to be vague and unsatisfactory. Sprengel only enumerated in 1827 about 31,000 known phenogamous and 6,000 cryptogamous plants, but that naturalist omitted many, perhaps 7,000 phenogamous and 1,000 cryptogamous species. Mr. Lindley, in a letter to the author in 1836, expressed his opinion that it would be rash to speculate on the existence of more than 80,000 phenogamous and 10,000 cryptogamous plants. If we take, he says, in a letter to the author on this subject, 37,000 as the number of published phenogamous species, and then add for the undiscovered species in Asia and New Holland 15,000, in Africa 10,000, and in America 18,000, we have 80,000 species. And if 7,000 be the number of published cryptogamous plants, and we allow 3,000 for the undiscovered species, making 10,000, there would then be, on the whole, 90,000 species. But since that period, one catalogue, as I learned from Dr. J. Hooker, contains a list of the names of 78,000 phenogamous plants which had been published before 1841. It was supposed by Linnaeus that there were 4 or 5 species of insects in the world for each phenogamous plant. But if we may judge from the relative proportion of the two classes in Great Britain, the number of insects must be still greater, for the total number of British insects, according to the last census, is about 12,500, whereas there are only 1,500 phenogamous plants indigenous to our island. As the insects are much more numerous in hot countries than in our temperate latitudes, it seems difficult to avoid the conclusion that there are more than 500,000 species in the world. The number of known mammifers, when Temminck wrote, exceeded 800, and Mr. Waterhouse informs me that more than 1,200 are now, 1850, ascertained to exist. Baron Cuvier estimated the amount of known fishes at 6,000, and Mr. G. Gray, in his Genera of Birds, enumerates 8,000 species. We have still to add the reptiles and all the invertebrated animals, exclusive of insects. It remains, in a great degree, mere matter of conjecture what proportion the aquatic tribes may bear to the denizens of the land, but the habitable surface beneath the waters can hardly be estimated at less than double that of the continents and islands, even admitting that a very considerable area is destitute of life in consequence of great depth, cold, darkness, and other circumstances. In the late polar expedition, it was found that in some regions, as in Baffin's Bay, there were marine animals inhabiting the bottom at great depths, where the temperature of the water was below the freezing point. That there is life at much greater profundities in warmer regions may be confidently inferred. The ocean teems with life. The class of polyps alone are conjectured by Lamarck to be as strong in individuals as insects. Every tropical reef is described as covered with corals and sponges, and swarming with crustacea, echini, and testacea, while almost every tide-washed rock in the world is carpeted with fuci, and supports some corallines, actinae, and mollusca. There are innumerable forms in the seas of the warmer zones which have scarcely begun to attract the attention of the naturalist. And there are parasitic animals without number, 3 or 4 of which are sometimes appropriated to one genus, as to the whale, Balena, for example. Even though we concede, therefore, that the geographical range of marine species is more extensive in general than that of the terrestrial, the temperature of the sea being more uniform, and the land impeding less the migrations of the oceanic than the ocean those of the terrestrial species, yet it seems probable that the aquatic tribes far exceed in number the inhabitants of the land. Without insisting on this point, it may be safe to assume that, exclusive of microscopic beings, there are between 1 and 2 millions of species now inhabiting the terraqueous globe, so that if only one of these were to become extinct annually, and one new one were to be every year called into being, much more than 1 million of years might be required to bring about a complete revolution in organic life. I am not hazarding at present any hypothesis as to the probable rate of change, but none will deny that when the annual birth and the annual death of one species on the globe is proposed as a mere speculation, this, at least, is to imagine no slight degree of instability in the animate creation. If we divide the surface of the earth into 20 regions of equal area, one of these might comprehend a space of land and water about equal in dimensions to Europe, and might contain a 20th part of the million of species which may be assumed to exist in the animal kingdom. In this region, one species only would, according to the rate of mortality before assumed, perish in 20 years, or only 5 out of 50,000 in the course of a century. But as a considerable proportion of the whole would belong to the aquatic classes, with which we have a very imperfect acquaintance, we must exclude them from our consideration. And if they constitute half of the entire number, then one species only might be lost in 40 years among the terrestrial tribes. Now, the mammalia, whether terrestrial or aquatic, bear so small a proportion to other classes of animals, forming less, perhaps, than 1,000th part of the whole, that if the longevity of species in the different orders were equal, a vast period must elapse before it would come to the turn of this conspicuous class to lose one of their number. If one species only of the whole animal kingdom died out in 40 years, no more than one mammifer might disappear in 40,000 years in a region of the dimensions of Europe. It is easy, therefore, to see that in a small portion of such an area, in countries, for example, of the size of England and France, periods of much greater duration must elapse before it would be possible to authenticate the first appearance of one of the larger plants and animals, assuming the annual birth and death of one species to be the rate of vicissitude in the animate creation throughout the world. The observations of naturalists upon living species may, in the course of future centuries, accumulate positive data, from which an insight into the laws which govern this part of our terrestrial system may be derived. But in the present deficiency of historical records, we have traced up the subject to that point where geological monuments alone are capable of leading us on to the discovery of ulterior truths. To these, therefore, we must appeal, carefully examining the strata of recent formation, wherein the remains of living species, both animal and vegetable, are known to occur. We must study these strata in strict reference to their chronological order, as deduced from their superposition and other relations.
From these sources we may learn which of the species, now our contemporaries, have survived the greatest revolutions of the earth's surface, which of them have coexisted with the greatest number of animals and plants now extinct, and which have made their appearance only when the animate world had nearly attained its present condition. From such data we may be enabled to infer whether species have been called into existence in succession, or all at one period, whether singly or by groups simultaneously, whether the antiquity of man may be as high as that of any of the inferior beings which now share the planet with him, or whether the human species is one of the most recent of the whole. To some of these questions we can even now return a satisfactory answer, and with regard to the rest we have some data to guide conjecture, and to enable us to speculate with advantage. But in order to be fully qualified to enter upon such discussions, the reader must study the ample body of materials amassed by the industry of modern geologists. End of chapter 43.
Chapter 44 of Principles of Geology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Principles of Geology by Charles Lyell, Book 3, Chapter 44. Effects produced by the powers of vitality on the state of the Earth's surface. Modifications in physical geography caused by organic beings. Why the vegetable soil does not augment in thickness. The theory that vegetation is an antagonistic power counterbalancing the degradation caused by running water untenable. Conservative influence of vegetation. Rain diminished by felling of forests. Distribution of American forests dependent on direction of predominant winds. Influence of man in modifying the physical geography of the globe. The second branch of our inquiry, respecting the changes of the organic world, relates to the processes by which the remains of animals and plants become fossil, or to speak still more generally, to all the effects produced by the powers of vitality on the surface and shell of the earth. Before entering on the principal division of this subject, the embedding and preservation of animal and vegetable remains, I shall offer a few remarks on the superficial modifications caused directly by the agency of organic beings, as when the growth of certain plants covers the slope of a mountain with peat, or converts a swamp into dry land, or when vegetation prevents the soil in certain localities from being washed away by running water. In considering alterations of this kind, brought about in the physical geography of particular tracts, we are too apt to think exclusively of that part of the earth's surface which has emerged from beneath the waters, and with which alone as terrestrial beings we are familiar. Here the direct power of animals and plants to cause any important variation is of necessity very limited, except in checking the progress of that decay of which the land is the chief theater. But if we extend our views, and instead of contemplating the dry land, consider that larger portion which is assigned to the aquatic tribes, we discover the great influence of the living creation in imparting varieties of conformation to the solid exterior, which the agency of inanimate causes alone could not produce. Thus, when timber is floated into the sea, it is often drifted to vast distances, and subsides in spots where there might have been no deposit at that time and place, if the earth had not been tenanted by living beings. If therefore in the course of ages a hill of wood or lignite be thus formed in the subaqueous regions, a change in the submarine geography may be said to have resulted from the action of organic powers. So in regard to the growth of coral reefs. It is probable that a large portion of the matter of which they are composed is supplied by mineral springs, which often rise up at the bottom of the sea and which, on land, abound throughout volcanic regions hundreds of leagues in extent. The matter thus constantly given out could not go on accumulating forever in the waters, but would be precipitated in the abysses of the sea, even if there were no polyps and testacea. But these animals arrest and secrete the carbonate of lime on the summits of submarine mountains, and form reefs many 100 feet in thickness and hundreds of miles in length, where but for them none might ever have existed. Why the vegetable soil does not augment in thickness. If no such voluminous masses are formed on the land, it is not from the want of solid matter in the structure of terrestrial animals and plants, but merely because, as I have so often stated, the continents are those parts of the globe where ascensions of matter can scarcely ever take place, where, on the contrary, the most solid parts already formed are each in their turn exposed to gradual degradation. The quantity of timber and vegetable matter which grows in a tropical forest in the course of a century is enormous, and multitudes of animal skeletons are scattered there during the same period, besides innumerable land shells and other organic substances. The aggregate of these materials, therefore, might constitute a mass greater in volume than that which is produced in any coral reef during the same lapse of years. But although this process should continue on the land forever, no mountains of wood or bone would be seen stretching far and wide over the country or pushing out bold promontories into the sea. The whole solid mass is either devoured by animals or decomposes, as does a portion of the rock and soil on which the animals and plants are supported. The waste of the strata themselves, accompanied by the decomposition of their organic remains, and the setting free of their alkaline ingredients, is one source from whence running water and the atmosphere may derive the materials which are absorbed by the roots and leaves of plants. Another source is the passage into a gaseous form of even the hardest parts of animals and plants which die and putrefy in the air, where they are soon resolved into the elements of which they are composed, and while a portion of these constituents is volatilized, the rest is taken up by rainwater and sinks into the earth, or flows towards the sea, so that they enter again and again into the composition of different organic beings. The principal element found in plants are hydrogen, carbon, and oxygen, so that water and the atmosphere contain all of them, either in their own composition or in solution. The constant supply of these elements is maintained not only by the putrefaction of animal and vegetable substances and the decay of rocks, but also by the copious evolution of carbonic acid and other gases from volcanoes and mineral springs, and by the effects of ordinary evaporation, whereby aqueous vapors are made to rise from the ocean and to circulate round the globe. It is well known that when two gases of different specific gravity are brought into contact, even though the heavier be the lowermost, they soon become uniformly diffused by mutual absorption through the whole space which they occupy. By virtue of this law, the heavy carbonic acid finds its way upwards through the lighter air of the atmosphere and conveys nourishment to the lichen which covers the mountain top. If the quantity of food consumed by terrestrial animals and the elements imbibed by the roots and leaves of plants were derived entirely from that supply of hydrogen, carbon, oxygen, nitrogen, and other elements given out into the atmosphere and the waters by the putrescence of organic substances, then we might imagine that the vegetable mold would, after a series of years, neither gain nor lose a single particle by the action of organic beings. And this conclusion is not far from the truth, But the operation which renovates the vegetable and animal mold is by no means so simple as that here supposed. Thousands of carcasses of terrestrial animals are floated down every century into the sea, and together with forests of drift timber, are embedded in the subaqueous deposits, where their elements are imprisoned in solid strata, and may there remain locked up throughout whole geological epochs before they again become subservient to the purposes of life. On the other hand, fresh supplies are derived by the atmosphere and by running water, as before stated, from the disintegration of rocks and their organic contents, and through the agency of mineral springs from the interior of the earth, from whence all the elements before mentioned, which enter principally into the composition of animals and vegetables, are continually evolved. Even nitrogen is found by chemists to be contained very generally in the waters of mineral springs. Vegetation not an antagonistic power counterbalancing the action of running water. If we suppose that the copious supply from the nether regions, by springs and volcanic vents, of carbonic acid and other gases, together with the decomposition of rocks, may be just sufficient to counterbalance that loss of matter, which, having already served for the nourishment of animals and plants, is annually carried down in organized forms and buried in subaqueous strata, we concede the utmost that is consistent with probability. An opinion, however, has been expressed that the processes of vegetable life, by absorbing various gases from the atmosphere, cause so large a mass of solid matter to accumulate on the surface of the land that this mass alone may constitute a great counterpoise to all the matter transported to lower levels by the aqueous agents of decay. Torrents and rivers, it is said, the waves of the sea and marine currents, act upon lines only, but the power of vegetation to absorb the elastic and non-elastic fluids circulating round the earth extends over the whole surface of the continents. But the silent but universal action of this great antagonistic power, the spoliation of waste caused by running water on the land and by the movements of the ocean, are neutralized and even counterbalanced. In opposition to these views, I conceive that we shall form a juster estimate of the influence of vegetation if we consider it as being in a slight degree conservative and capable of retarding the waste of land, but not of acting as an antagonistic power. The vegetable mold is seldom more than a few feet in thickness, and frequently does not exceed a few inches, and we by no means find that its volume is more considerable in those parts of our continents which we can prove by geological data to have been elevated at more ancient periods, and where consequently there has been the greatest time for the accumulation of vegetable matter produced throughout successive zoological epochs. On the contrary, these higher and older regions are more frequently denuded so as to expose the bare rock to the action of the sun and air. We find in the torrid zone, where the growth of plants is most rank and luxurious, that accessions of matter due to their agency are by no means the most conspicuous. Indeed, it is in these latitudes where the vegetation is most active, that for reasons to be explained in the next chapter, even those superficial peat mosses are unknown which cover a large area in some parts of our temperate zone. If the operation of animal and vegetable life could restore to the general surface of the continents a portion of the elements of those disintegrated rocks, of which such enormous masses are swept down annually into the sea, the effects would long ere this have constituted one of the most striking features in the structure and composition of our continents. All the great steppes and tablelands of the world, where the action of running water is feeble, would have become the grand repositories of organic matter accumulated without the intermixture of earthy sediment, which so generally characterizes the subaqueous strata. I have already stated that in the known operation of the igneous causes, a real antagonistic power is found which may counterbalance the leveling action of running water, and there seems no good reason for presuming that the upheaving and depressing force of earthquakes, together with the ejection of matter by volcanoes, may not be fully adequate to restore that inequality of the surface which rivers and the waves and currents of the ocean annually tend to lessen. If a counterpoise be derived from this source, the quantity and elevation of land above the sea may forever remain the same, in spite of the action of the aqueous causes, which, if thus counteracted, may never be able to reduce the surface of the earth more nearly to a state of equilibrium than that which it has now attained, and on the other hand, the force of the aqueous agents themselves might thus continue forever unimpaired. Conservative influence of vegetation. If then vegetation cannot act as an antagonistic power amid the mighty agents of change, which are always modifying the surface of the globe, let us next inquire how far its influence is conservative, how far it may retard the leveling effects of running water, which it cannot oppose, much less counterbalance. It is well known that a covering of herbage and shrubs may protect a loose soil from being carried away by rain or even by the ordinary action of a river, and may prevent hills of loose sand from being blown away by the wind, for the roots bind together the separate particles into a firm mass, and the leaves intercept the rainwater, so that it dries up gradually instead of flowing off in a mass and with great velocity. The old Italian hydrographers made frequent mention of the increased degradation which has followed the clearing away of natural woods in several parts of Italy. A remarkable example was afforded in the upper Val di Arno in Tuscany, on the removal of the woods, clothing the steep declivities of the hills by which that valley is bounded. When the ancient forest laws were abolished by the Grand Duke Joseph during the last century, a considerable tract of surface in the Casentina, the Clausentinium of the Romans, was denuded, and immediately the quantity of sand and soil washed down into the Arno increased enormously. Frissi, alluding to such occurrences, observes that as soon as the bushes and plants were removed, the waters flowed off more rapidly and in the manner of floods swept away the vegetable soil. This effect of vegetation is of high interest to the geologist when he is considering the formation of those valleys, which have been principally due to the action of rivers. The spaces intervening between the valleys, whether they be flat or ridgy, when covered with vegetation, may scarcely undergo the slightest waste, as the surface may be protected by the green sward of grass, and this may be renewed in the manner before described from elements derived from rainwater and the atmosphere. Hence, while the river is continually bearing down matter in the alluvial plain, and undermining the cliffs on each side of every valley, the height of the intervening rising grounds may remain stationary. In this manner, a cone of loose scoriae sand and ashes such as Monte Nuovo may, when it has once become densely clothed with herbage and shrubs, suffer scarcely any further dilapidation, and the perfect state of the cones of hundreds of extinct volcanoes in France, the Neapolitan territory, Sicily, and elsewhere, may prove nothing whatever, either as to their relative or absolute antiquity. We may be able to infer, from the integrity of such conical hills of incoherent materials, that no flood can have passed over the countries where they are situated since their formation, but the atmospheric action alone, in spots where there happened to be no torrents, and where the surface was clothed with vegetation, could scarcely in any lapse of ages have destroyed them. During a tour in Spain in 1830, I was surprised to see a district of gently undulating ground in Catalonia, consisting of red and gray sandstone, and in some parts of red marl almost entirely denuded of herbage, while the roots of the pines, holm oaks, and some other trees were half exposed, as if the soil had been washed away by a flood. Such is the state of the forests, for example, between Oristo and Vich, and near San Lorenzo. But being overtaken by a violent thunderstorm in the month of August, I saw the whole surface, even the highest levels of some flat-topped hills, streaming with mud, while on every declivity the devastation of torrents was terrific. The peculiarities in the physiognomy of the district were at once explained, and I was taught that in speculating on the greater effects which the direct action of rain may once have produced on the surface of certain parts of England, we need not revert to periods when the heat of the climate was tropical. In the torrid zone, the degradation of land is generally more rapid, but the waste is by no means proportioned to the superior quantity of rain or the suddenness of its fall, the transporting power of water being counteracted by a greater luxuriance of vegetation. A geologist who is no stranger to tropical countries observes that the softer rocks would speedily be washed away in such regions, if the numerous roots of plants were not matted together in such a manner as to produce considerable resistance to the destructive power of the rains. The parasitical and creeping plants also entwine in every possible direction so as to render the forests nearly impervious, and the trees possess forms and leaves best calculated to shoot off the heavy rains, which, when they have thus been broken in their fall, are quickly absorbed by the ground beneath, or when thrown into the drainage depressions, give rise to furious torrents. Influence of man in modifying the physical geography of the globe. Before concluding this chapter, I shall offer a few observations on the influence of man in modifying the physical geography of the globe, for we must class his agency among the powers of organic nature. Felling of forests. The felling of forests has been attended in many countries by a diminution of rain, as in Barbados and Jamaica. For in tropical countries, where the quantity of aqueous vapor in the atmosphere is great, but where, on the other hand, the direct rays of the sun are most powerful, any impediment to the free circulation of air, or any screen which shades the earth from the solar rays, becomes a source of humidity, and wherever dampness and cold have begun to be generated by such causes, the condensation of vapor continues. The leaves, moreover, of all plants are alembics, and some of those in the torrid zone have the remarkable property of distilling water, thus contributing to prevent the earth from becoming parched up. Distribution of the American forests. There can be no doubt then that the state of the climate, especially the humidity of the atmosphere, influences vegetation, in that in its turn vegetation reacts upon the climate. But some writers seem to have attributed too much importance to the influence of forests, particularly those of America, as if they were the primary cause of the moisture of the climate. The theory of a modern author on this subject, that forests exist in those parts of America only where the predominant winds carry with them a considerable quantity of moisture from the ocean, seems far more rational. In all countries, he says, having a summer heat exceeding 70 degrees, the presence or absence of natural woods, and their greater or less luxuriance may be taken as a measure of the amount of humidity and of the fertility of the soil. Short and heavy rains in a warm country will produce grass, which, having its roots near to the surface, springs up in a few days and withers when the moisture is exhausted. But transitory rains, however heavy, will not nourish trees, because after the surface is saturated, the remainder of the water runs off, and the moisture lodged in the soil neither sinks deep enough nor is sufficient quantity to furnish the giants of the forest with the necessary sustenance. It may be assumed that 20 inches of rain falling moderately, or at intervals, will leave a greater permanent supply in the soil than 40 inches falling, as it sometimes does in the torrid zone, in as many hours. In all regions, he continues, where ranges of mountains intercept the course of the constant or predominant winds, the country on the windward side of the mountains will be moist, and that on the leeward dry, and hence parched deserts will generally be found on the west side of countries within the tropics, and on the east side of those beyond them, the prevailing winds in these cases being generally in opposite directions. On this principle, the position of forests in North and South America may be explained. Thus, for example, in the region within the 30th parallel, the moisture swept up by the trade wind from the Atlantic is precipitated in part upon the mountains of Brazil, which are but low and so distributed as to extend far into the interior. The portion which remains is borne westward, and, losing a little as it proceeds, is at length arrested by the Andes, where it falls down in showers on their summits. The aerial current, now deprived of all the humidity with which it can part, arrives in a state of complete exsication at Peru, where consequently no rain falls. But in the region of America beyond the 30th parallel, the Andes serve as a screen to intercept the moisture brought by the prevailing winds from the Pacific Ocean. Rains are copious on their summits and in Chile on their western declivities, but none falls on the plains to the eastward, except occasionally when the wind blows from the Atlantic. I have been more particular in explaining these views because they appear to place in a true light the dependence of vegetation on climate, the humidity being increased and more uniformly diffused throughout the year by the gradual spreading of wood. It has been affirmed that formerly, when France and England were covered with wood, Europe was much colder than at present, that the winters in Italy were longer, and that the Seine and many other rivers froze more regularly every winter than now. Mr. Arago, in an essay on this subject, has endeavored to show by tables of observations on the congelation of the Rhine, Danube, Rhone, Po, Seine, and other rivers at different periods that there is no reason to believe the cold to have been in general more intense in ancient times. He admits, however, that the climate of Tuscany has been so far modified by the removal of wood as that the winters are less cold, but the summers also, he contends, are less hot than of old, and the summers, according to him, were formerly hotter in France than in our own times. His evidence is derived chiefly from documents showing that wine was made 3 centuries ago in the Ware and several other provinces at an earlier season, at greater elevation, and in higher latitudes than are now found suitable to the vine. There seems little doubt that in the United States of North America, the rapid clearing of the country has rendered the winters less severe and the summers less hot. In other words, the extreme temperatures of January and July have been observed from year to year to approach somewhat nearer to each other. Whether in this case or in France the mean temperature has been raised seems by no means as yet decided, but there is no doubt that the climate has become, as Buffon would have said, less excessive. I have before shown, when treating of the excavation of new estuaries in Holland by inroads of the ocean, as also of the changes on our own coasts, that although the conversion of sea into land by artificial labors may be great, yet it must always be in subordination to the power of the tides and currents, or to the great movements which alter the relative level of the land and sea. Chapter 20. If in addition to the assistance obtained by parliamentary grants for defending Dunwich from the waves, all the resources of Europe had been directed to the same end, the existence of that port might perhaps have been prolonged by several centuries. Page 310. But in the meantime, the current would have continued to sweep away portions from the adjoining cliffs on each side, giving to the whole line of coast its present form, until at length the town projecting as a narrow promontory must have become exposed to the irresistible fury of the waves. It is scarcely necessary to observe that the control which man can obtain over the igneous agents is less even than that which he may exert over the aqueous. He cannot modify the upheaving or depressing force of earthquakes, or the periods or degree of violence of volcanic eruptions, and on these causes the inequalities of the earth's surface, and consequently the shape of the sea and land, appear mainly to depend. The utmost that man can hope to effect in this respect is occasionally to divert the course of a lava stream, and to prevent the burning matter for a season from overwhelming a city or some other of the proudest works of human industry. If all the nations of the earth should attempt to quarry away the lava which flowed during one eruption from the Icelandic volcanoes in 1783 and the 2 following years, and should attempt to consign it to the deepest abysses of the ocean, they might toil for thousands of years and not accomplish their task. Yet the matter borne down to the sea by 2 great rivers, the Ganges and the Burrampooter, in each quarter of a century, probably equals in weight and volume the mass of Icelandic lava produced by that great eruption. Page 282. So insignificant is the aggregate force exerted by man when contrasted with the ordinary operations of aqueous or igneous agents in the natural world. No application, perhaps, of human skill and labor tends so greatly to vary the state of the habitable surface as that employed in the drainage of lakes and marshes, since not only the stations of many animals and plants, but the general climate of a district may thus be modified. It is also a kind of alteration to which it is difficult to find anything analogous in the agency of inferior beings, for we ought always, before we decide that any part of the influence of man is novel and anomalous, carefully to consider the powers of all other animated agents which may be limited or superseded by him. Many who have reasoned on these subjects seem to have forgotten that the human race often succeeds to the discharge of functions previously fulfilled by other species. Suppose the growth of some of the larger terrestrial plants, or in other words, the extent of forest, to be diminished by man, and the climate to be thereby modified. It does not follow that this kind of innovation is unprecedented. It is a change in the state of vegetation, and such may often have been the result of the appearance of new species upon the earth. The multiplication, for example, of certain insects in parts of Germany during the last century destroyed more trees than man perhaps could have felled during an equal period. It would be rash, however, to affirm that the power of man to modify the surface may not differ in kind or degree from that of other living beings, although the problem is certainly more complex than many who speculated on such topics have imagined. If land be raised from the sea, the greatest alteration in its physical condition which could ever arise from the influence of organic beings would probably be produced by the first immigration of terrestrial plants, whereby the new tract would become covered with vegetation. The change next in importance would seem to be when animals first enter and modify the proportionate numbers of certain species of plants. If there be any anomaly in the intervention of man in farther varying the relative numbers in the vegetable kingdom, it may not so much consist in the kind or absolute quantity of alteration as in the circumstance that a single species in this case would exert by its superior power and universal distribution an influence equal to that of hundreds of other terrestrial animals. If we inquire whether man by his direct power or by the changes which he may give rise to indirectly tends upon the whole to lessen or increase the inequalities of the earth's surface, we shall incline perhaps to the opinion that he is a leveling agent. In mining operations, he conveys upwards a certain quantity of materials from the bowels of the earth. But on the other hand, much rock is taken annually from the land in the shape of ballast, and afterwards thrown into the sea, and by this means, in spite of prohibitory laws, many harbors in various parts of the world have been blocked up. We rarely transport heavy materials to higher levels, and our pyramids and cities are chiefly constructed of stone brought down from more elevated situations. By plowing up thousands of square miles and exposing a surface for part of the year to the action of the elements, we assist the abrading force of rain and diminish the conservative effects of vegetation. End of chapter 44. Chapter 45 of Principles of Geology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Principles of Geology by Charles Lyell. Chapter 45. Enclosing of fossils in peat, brown sand, and volcanic ejections. Division of the subject. Embedding of organic remains in deposits on emerged land. Growth of peat. Site of ancient forests in Europe now occupied by peat. Bog iron ore. Preservation of animal substances in peat. Miring of quadrupeds. Bursting of the Solway moss. Great dismissal swamp. Embedding of organic bodies and human remains in blown sand. Moving sands of African deserts. Diluc on their recent origin. Buried temple of Ipsambul. Dried carcasses in the sands. Towns overwhelmed by sand floods. Embedding of organic and other remains in volcanic formations on the land. Division of the subject. The next subject of inquiry is the mode in which the remains of animals and plants become fossil, or are buried in the earth by natural causes. Mr. Constant Prevost has observed that the effects of geological causes are divisible in two great classes: those produced during the submersion of land beneath the waters, and those which take place after its immersion. Agreeably to this classification, I shall consider, first, in what manner animal and vegetable remains become included and preserved in deposits on emerged land, or that part of the surface which is not permanently covered by water, whether of seas or lakes. Secondly, the manner in which organic remains become embedded in subaqueous deposits. Under the first division, I shall treat of the following topics. First, the growth of peat and the preservation of vegetable and animal remains therein. Secondly, the burying of organic remains in blown sand. Thirdly, of the same in the ejections and alluviums of volcanoes. Fourthly, in alluviums generally, and in the ruins of landslips. Fifthly, in the mud and stalagmite of caves and fissures. Growth of peat and preservation of vegetable and animal remains therein. The generation of peat, when not completely under water, is confined to moist situations where the temperature is low and where vegetables may decompose without putrefying. It may consist of any of the numerous plants which are capable of growing in such stations, but a species of moss, sphagnum, constitutes a considerable part of the peat found in marshes of the north of Europe. This plant having the property of throwing up new shoots in its upper part, while its lower extremities are decaying. Reeds, rushes, and other aquatic plants may usually be traced in peat, and their organization is often so entire that there is no difficulty in discriminating the distinct species. Analysis of peat. In general, says Sir H. Davy, 100 parts of dry peat contain from 60 to 99 parts of matter destructible by fire, and the residuum consists of earths usually of the same kind as the substratum of clay, marl, gravel, or rock on which they are found, together with oxide of iron. The peat of the chalk counties of England, observes the same writer, contains much gypsum, but I have found very little in any specimens from Ireland or Scotland, and in general these peats contain very little saline matter. From the researches of Dr. McCulloch, it appears that peat is intermediate between simple vegetable matter and lignite, the conversion of peat to lignite being gradual and being brought about by a prolonged action of water. Peat abundant in cold and humid climates. Peat is sometimes formed on a declivity in mountainous regions, where there is much moisture, but in such situations it rarely, if ever, exceeds 4 feet in thickness. In bogs, and in low grounds into which alluvial peat is drifted, it is found 40 feet thick and upwards, but in such cases it generally owes 1/2 of its volume to the water which it contains. It has seldom, if ever, been discovered within the tropics, and it rarely occurs in the valleys, even in the south of France and Spain. It abounds more and more in proportion as we advance farther from the equator, and becomes not only more frequent, but more inflammable in northern latitudes. The same phenomenon is repeated in the southern hemisphere. No peat is found in Brazil, nor even in the swampy parts of the country drained by the La Plata on the east side of South America, or in the island of Chiloé on the west. Yet when we reach the 45th degree of latitude and examine the Chonos archipelago, or the Falkland Islands, and Tierra del Fuego, we meet with an abundant growth of this substance. Almost all plants contribute here by their decay to the production of peat, even the grasses. But it is a singular fact, says Mr. Darwin, as contrasted with what occurs in Europe, that no kind of moss enters into the composition of the South American peat, which is formed by many plants, but chiefly by that called by Brown Astelia pumila. I learned from Dr. Forchhammer, 1849, that water charged with vegetable matter in solution does not throw down a deposit of peat in countries where the mean temperatures of the year is above 43 or 44 degrees Fahrenheit. Frost causes the precipitation of such peaty matter, but in warm climates the attraction of the carbon for the oxygen of the air mechanically mixed with the water increases with the increasing temperature, and the dissolved vegetable matter, or humic acid, which is organic matter in a progressive state of decomposition, being converted into carbonic acid, rises and is absorbed into the atmosphere and thus disappears. Extent of surface covered by peat. There is a vast extent of surface in Europe covered with peat, which in Ireland is said to extend over 1/10 of the whole island. One of the mosses on the Shannon is described as being 50 miles long by 2 or 3 broad, and the great marsh of Montiori near the mouth of the Lorry is mentioned by Blavier as being more than 50 leagues in circumference. It is a curious and well ascertained fact that many of these mosses of the north of Europe occupy the place of forests of pine and oak, which have, many of them, disappeared within the historical era. Such changes are brought about by the fall of trees and the stagnation of water, caused by their trunks and branches obstructing the free drainage of the atmospheric waters and giving rise to a marsh. In warm climate, such decayed timber would immediately be removed by insects or by putrefaction, But in the cold temperature now prevailing in our latitudes, many examples are recorded of marches originating in this source. Thus, in Mar Forest in Aberdeenshire, large trunks of Scotch fir, which had fallen from age and decay, were soon immured in peat, formed partly out of their perishing leaves and branches, and in part from the growth of other plants. We also learn that the overthrow of a forest by a storm, about the middle of the 17th century, gave rise to a peat moss near Lochbroom in Rossshire, where in less than half a century after the fall of the trees, the inhabitants dug peat. Dr. Walker mentions a similar change, when in the year 1756 the whole wood of Dromloric in Dumfriesshire was overset by the wind. Such events explain the occurrence, both in Britain and on the continent, of mosses, where the trees are all broken within 2 or 3 feet of the original surface, and where their trunks all lie in the same direction. It may, however, be suggested in these cases that the soil had become exhausted for trees, and that on the principle of that natural rotation which prevails in the vegetable world, one set of plants died out and another succeeded. It is certainly a remarkable fact that in the Danish islands and in Jutland and Holstein, fir wood of various species, especially Scotch fir, is found at the bottom of the peat mosses, although it is well ascertained that for the last 5 centuries no coniferae have grown wild in these countries, the coniferous trees which now flourish there having been all planted toward the close of the last century. Nothing is more common than the occurrence of buried trees at the bottom of the Irish peat mosses, as also in most of those of England, France, and Holland, and they have been so often observed with parts of their trunks standing erect and with their roots fixed to the subsoil, that no doubt can be entertained of their having generally grown on the spot. They consist, for the most part, of the fir, the oak, and the birch, where the subsoil is clay. The remains of oak are the most abundant. Where sand is the substratum, fir prevails. In the marsh of Curragh, in the Isle of Man, vast trees are discovered standing firm on their roots, though at the depth of 18 or 20 feet below the surface. Some naturalists have desired to refer the embedding of timber in peat mosses to aqueous transportation, since rivers are well known to float wood into lakes. But the facts above mentioned show that in numerous instances such a hypothesis is inadmissible. It has, moreover, been observed that in Scotland, as also in many parts of the continent, the largest trees are found in those peat mosses which lie in the least elevated regions, and that the trees are proportionately smaller in those which lie at higher levels. From which fact, De Luc and Walker have both inferred that the trees grow on the spot, for they would naturally attain a greater size in lower and warmer levels. The leaves also and fruits of each species are continually found immersed in the moss along with the parent trees, as for example the leaves and acorns of the oak, the cones and leaves of the fir, and the nuts of the hazel. Recent origin of some peat mosses. In Hatfield moss, in Yorkshire, which appears clearly to have been a forest 1800 years ago, fir trees have been found 90 feet long and sold for masts and keels of ships. Oaks have also been discovered there above 100 feet long. The dimensions of an oak from this moss are given in the Philosophical Transactions No. 275, which must have been larger than any tree now existing in the British dominions. In this same moss of Hatfield, as well as in that of Kincardine in Scotland, and several others, Roman roads have been found covered to the depth of 8 feet by peat. All the coins, axes, arms, and other utensils found in British and French mosses are also Roman, so that a considerable portion of the peat in European peat bogs is evidently not more ancient than the age of Julius Caesar. Nor can any vestiges of the ancient forests described by that general along the lines of the great Roman way in Britain be discovered, except in the ruined trunks of trees and peat. De Luc ascertained that the very sites of the aboriginal forests of Hercynia, Cimana, Ardennes, and several others are now occupied by mosses and fens, and a great part of these changes have with much probability been attributed to the strict orders given by Severus and other emperors to destroy all the wood in the conquered provinces. Several of the British forests, however, which are now mosses, were cut at different periods by order of the English Parliament because they harbored wolves or outlaws. Thus the Welsh woods were cut and burned in the reign of Edward I, as were many of those in Ireland by Henry II, to prevent the natives from harboring in them and harassing his troops. It is curious to reflect that considerable tracts have by these accidents been permanently sterilized, and that during a period when civilization has been making great progress, large areas in Europe have by human agency been rendered less capable of administering to the wants of man. Rennie observes, with truth, that in those regions alone which the Roman eagle never reached, in the remote circles of the German Empire, in Poland and Prussia, and still more in Norway, Sweden, and the vast empire of Russia, can we see what Europe was before it yielded to the power of Rome. Desolation now reigns where stately forests of pine and oak once flourished, such as might now have supplied all the navies of Europe with timber. Sources of bog iron ore. At the bottom of peat mosses, there is sometimes found a cake, or pan, as it is termed, of oxide of iron, and the frequency of bog iron ore is familiar to the mineralogist. The oak, which is so often dyed black in peat, owes its color to the same metal. From what source the iron is derived has often been a subject of discussion, until the discoveries of Ehrenberg seem at length to have removed the difficulty. He had observed, in the marshes about Berlin, a substance of a deep ochre yellow passing into red, which covered the bottom of the ditches, and which, where it had become dry after the evaporation of water, appeared exactly like oxide of iron. But under the microscope it was found to consist of slender articulated threads or plates, partly siliceous and partly ferruginous, of what he considered an animalcule, Gallionella ferruginea, but which most naturalists now regard as a plant. There can be little doubt, therefore, that bog iron ore consists of an aggregate of millions of these organic bodies invisible to the naked eye. Preservation of animal substances in peat. One interesting circumstance attending the history of peat mosses is the high state of preservation of animal substances buried in them for periods of many years. In June 1747, the body of a woman was found 6 feet deep in a peat moor in the Isle of Axholme in Lincolnshire. The antique sandals on her feet afforded evidence of her having been buried there for many ages. Yet her nails, hair, and skin are described as having shown hardly any marks of decay. On the estate of the Earl of Moira in Ireland, a human body was dug up, a foot deep in gravel, covered with 11 feet of moss. The body was completely clothed, and the garments seemed all to be made of hair. Before the use of wool was known in that country, the clothing of the inhabitants was made of hair, so that it would appear that this body had been buried at the early period. Yet it was fresh and unimpaired. In the Philosophical Transactions we find an example recorded of the bodies of 2 persons having been buried in moist peat, in Derbyshire in 1674, about a yard deep, which were examined 28 years and 9 months afterward. The colors of their skin was fair and natural, the flesh soft as that of persons newly dead. Among other analogous facts, we may mention that in digging a pit for a well near Dulverton in Somersetshire, many pigs were found in various postures, still entire. Their shape was well preserved, the skin which retained the hair having assumed a dry, membranous appearance. Their whole substance was converted into a white, friable, laminated, inodorous, and tasteless substance, but which, when exposed to heat, emitted an odor precisely similar to broiled bacon. Cause of the antiseptic property of peat. We naturally ask whence peat derives this antiseptic property. It has been attributed by some to the carbonic and gallic acids which issued from decayed wood, as also to the presence of charred wood in the lowest strata of many peat mosses. For charcoal is a powerful antiseptic and capable of purifying water already putrid. Vegetable gums and resins also may operate in the same way. The tannin occasionally present in peat is the produce, says Dr. McCulloch, of tormentilla and some other plants, but the quantity he thinks too small and its occurrence too casual to give rise to effects of any importance. He hints that the soft parts of animal bodies preserved in peat bogs may have been converted into adiposura by the action of water merely, an explanation which appears clearly applicable to some of the cases above enumerated. Miring of quadrupeds. The manner, however, in which peat contributes to preserve for indefinite periods the hotter parts of terrestrial animals is a subject of more immediate interest to the geologist. There are two ways in which animals become occasionally buried in the peat of marshy grounds. They either sink down into the semi-fluid mud underlying a turfy surface upon which they have rashly ventured, or at other times, as we shall see in the sequel, a bog bursts, and animals may be involved in the peaty alluvium. In the extensive bogs of Newfoundland, cattle are sometimes found buried with only their heads and necks above ground, and after having remained for days in this situation, they have been drawn out by ropes and saved. In Scotland, also, cattle venturing on the quaking moss are often mired, or laired, as it is termed, and in Ireland Mr. King asserts that the number of cattle which are lost in sloughs is quite incredible. Solway moss. The description given of the Solway moss will serve to illustrate the general character of these boggy grounds. That moss, observes Gilpin, is a flat area, about 7 miles in circumference, situated on the western confines of England and Scotland. Its surface is covered with grass and rushes, presenting a dry crust and a fair appearance, but it shakes under the least pressure, the bottom being unsound and semi-fluid. The adventurous passenger, therefore, who sometimes in dry seasons traverses this perilous waste to save a few miles, picks his cautious way over the rushy tussocks as they appear before him, for here the soil is firmest. If his foot slip, or if he venture to desert this mark of security, it is possible he may never more be heard of. At the Battle of Solway in the time of Henry VIII, 1542, when the Scotch army, commanded by Oliver Sinclair, was routed, an unfortunate troop of horse, driven by their fears, plunged into this morass, which instantly closed upon them. The tale was traditional, but it is now authenticated, a man and horse in complete armor having been found by peat diggers in the place where it was always supposed the affair had happened. The skeleton of each was well preserved, and the different parts of the armor easily distinguished. The same moss, on the 16th of December, 1772, having been filled like a great sponge with water during heavy rains, swelled to an unusual height above the surrounding country and then burst. The turfy covering seemed for a time to act like the skin of a bladder, retaining the fluid within, till it forced a passage for itself, when a stream of black, half-consolidated mud began at first to creep over the plain, resembling, in the rate of its progress, an ordinary lava current. No lives were lost, but the deluge totally overwhelmed some cottages and covered 400 acres. The highest parts of that original moss subsided to the depth of about 25 feet, and the height of the moss on the lowest parts of the country which it invaded was at least 15 feet. Bursting of a peat moss in Ireland. A recent inundation in Sligo, January 1831, affords another example of this phenomenon. After a sudden thaw of snow, the bog between Bloomfield and Giva gave way, and a black deluge, carrying with it the contents of 100 acres of bog, took the direction of a small stream and rolled on with the violence of a torrent, sweeping along heath, timber, mud, and stones, and overwhelming many meadows and arable land. On passing through some boggy land, the flood swept out a wide and deep ravine, and part of the road leading from Bloomfield to St. James Well was completely carried away from below the foundation for the breadth of 200 yards. Great Dismal Swamp. I have described in my travels in North America an extensive swamp or morass 40 miles long from north to south and 25 wide between the towns of Norfolk in Virginia and Weldon in North Carolina. It is called the Great Dismal, and has somewhat the appearance of an inundated river plain covered with aquatic trees and shrubs, the soil being as black as that of a peat bog. It is higher on all sides, except one, than the surrounding country, towards which it sends forth streams of water to the north, east, and south, receiving a supply from the west only. In its center it rises 12 feet above the flat region which bounds it. The soil, to the depth of 15 feet, is formed of vegetable matter without any admixture, of earthy particles, and offers an exception to general rule before alluded to, namely, that such peaty accumulations scarcely ever occur so far south as latitude 36 degrees, or in any region where the summer heat is so great as in Virginia. In digging canals through the morass for the purpose of obtaining timber, much of the black soil has been thrown out from time to time and exposed to the sun and air, in which case it soon rots away so that nothing remains behind, showing clearly that it owes its preservation to the shade afforded by a luxuriant vegetation, and to the constant evaporation of the spongy soil by which the air is cooled during the hot months. The surface of the bog is carpeted with mosses, and densely covered with ferns and reeds, above which many evergreen shrubs and trees flourish, especially the white cedar, Cupressus thyoides, which stands firmly supported by its long tap roots in the softest parts of the quagmire. Over the whole, the deciduous cypress, Taxodium disticum, is seen to tower with its spreading top in full leaf in the season when the sun's rays are hottest, and when, if not intercepted by a screen of foliage, they might soon cause the fallen leaves and dead plants of the preceding autumn to decompose, instead of adding their contributions to the peaty mass. On the surface of the wide morass lie innumerable trunks of large and tall trees, while thousands of others, blown down by the winds, are buried at various depths in the black mire below. They remind the geologist of the prostrate position of large stems of Siglaria and Lepidodendron, converted into coal in ancient carboniferous rocks. Bones of herbivorous quadrupeds in peat. The antlers of large and full-grown stags are amongst the most common and conspicuous remains of animals in peat. They are not horns, which have been shed, for portions of the skull are found attached, proving that the whole animal perished. Bones of the ox, hog, horse, sheep, and other herbivorous animals also occur. Mr. Morin had discovered in the peat of Flanders the bones of otters and beavers, but no remains have been met with belonging to those extinct quadrupeds of which the living congeners inhabit warmer latitudes, such as the elephant, rhinoceros, hippopotamus, hyena, and tiger, though these are so common in superficial deposits of silt, mud, and sand, or stalactite, in various districts throughout Great Britain. Their absence seems to imply that they had ceased to live before the atmosphere of this part of the world acquired that cold and humid character which favors the growth of peat. Remains of ships, etc., in peat mosses. From the facts before mentioned, that mosses occasionally burst and descend in a fluid state to lower levels, it will readily be seen that lakes and arms of the sea may occasionally become the receptacles of drift peat. Of this, accordingly, there are numerous examples, and hence the alternations of clay and sand with different deposits of peat so frequent on some coasts as on those of the Baltic and German Ocean. We are informed by de Guer that remains of ships, nautical instruments, and oars have been found in many of the Dutch mosses, and Gerard, in the history of the valley of the Somme, mentions that in the lowest tier of that moss was found a boat loaded with bricks, proving that these mosses were at one period navigable lakes and arms of the sea, as were also many mosses on the coast of Picardy, Zealand, and Friesland, from which soda and salt are procured. The canoes, stone hatchets, and stone arrow heads found in peat in different parts of Great Britain lead to similar conclusions. Embedding of human and other remains and works of art in blown sand. The drifting of sand may next be considered among the causes capable of preserving organic remains and works of art on the emerged land. African sands. The sands of the African deserts have been driven by the west winds over part of the arable land of Egypt on the western bank of the Nile, in those places where valleys open into the plain, or where there are gorges through the Libyan mountains. By similar sand drifts, the ruins of ancient cities have been buried between the temple of Jupiter Ammon and Nubia. Mr. G. A. Deluc attempted to infer the recent origin of our continents from the fact that these moving sands have arrived only in modern times at the fertile plains of the Nile. The same scourge, he said, would have afflicted Egypt for ages anterior to the times of history had the continents risen above the level of the sea several hundred centuries before our era. But the author proceeded in this, as in all his other chronological computations, on a multitude of gratuitous assumptions. He ought, in the first place, to have demonstrated that the whole continent of Africa was raised above the level of the sea at one period, for until this point was established, the region from whence the sands began to move might have been the last addition made to Africa, and the commencement of the sand flood might have been long posterior to the laying dry of a greater portion of that continent. That the different parts of Europe were not all elevated at one time is now generally admitted. Deluc should have also pointed out the depth of drift sand in various parts of the great Libyan deserts, and have shown whether any valleys of large dimension had been filled up, how long these may have arrested the progress of the sands, and how far the flood had upon the whole advanced since the times of history. We have seen that Sir J. G. Wilkinson, is of opinion that while the sand drift is making aggressions at certain points upon the fertile soil of Egypt, the alluvial deposit of the Nile is advancing very generally upon the desert, and that, upon the whole, the balance is greatly in favor of the fertilizing mud. No mode of interment can be conceived more favorable to the conservation of monuments for indefinite periods than that now so common in the region immediately westward of the Nile. The sand which surrounded and filled the great temple of Ipsambol, first discovered by Burckhardt, and afterwards partially uncovered by Belzoni and Beechey, was so fine as to resemble a fluid when put in motion. Neither the features of the colossal figures, nor the color of the stucco with which some were covered, nor the paintings on the walls, had received any injury from being enveloped for ages in this dry, impalpable dust. At some future period, perhaps when the pyramids shall have perished, the action of the sea or an earthquake may lay open to the day some of these buried temples, or we may suppose the desert to remain undisturbed, and changes in the surrounding sea and land to modify the climate and the direction of the prevailing winds, so that these may then waft away the Libyan sands as gradually as they once brought them to those regions. Thus many a town and temple of higher antiquity than Thebes or Memphis may reappear in their original antiquity, and a part of the gloom which overhangs the history of the earlier nations be dispelled. Whole caravans are said to have been overwhelmed by the Libyan sands, and Burckhardt informs us that after passing the Aqaba near the head of the Red Sea, the bones of dead camels are the only guides of the pilgrim through the wastes of sand. We did not see, says Captain Lyon, speaking of a plain near the Suda Mountains in North Africa, the least appearance of vegetation, but observed many skeletons of animals which had died of fatigue on the desert, and occasionally the grave of some human being. All these bodies were so dried by the heat of the sun that putrefaction appears not to have taken place after death. In recent expired animals I could not perceive the slightest offensive smell, and in those long dead the skin with the hair on it remained unbroken and perfect, although so brittle as to break with a slight blow. The sand winds never cause these carcasses to change their places, for in a short time a slight mound is formed round them, and they become stationary. Towns overwhelmed by sand floods. The burying of several towns and villages in England, France, and Jutland by blown sand is on record. Thus, for example, near St. Paul de Leon, in Brittany, a whole village was completely buried beneath drift sand, so that nothing was seen but the spire of a church. In Jutland, marine shells adhering to seaweed are sometimes blown by the violence of the wind to the height of 100 feet, and buried in similar hills of sand. In Suffolk, in the year 1688, part of Downham was overwhelmed by sands which had broken loose about 100 years before from a warren 5 miles to the southwest. This sand had in the course of a century traveled 5 miles and covered more than 1,000 acres of land. A considerable tract of cultivated land on the north coast of Cornwall has been inundated by drift sand, forming hills several hundred feet above the level of the sea, and composed of comminuted marine shells, in which some terrestrial shells are enclosed entire. By the shifting of these sands, the ruins of ancient buildings have been discovered, and in some cases where wells had been bored to a great depth, distinct strata, separated by a vegetable crust, are visible. In some places, as at Newquay, large masses have become sufficiently indurated to be used for architectural purposes. The lapidification, which is still in progress, appears to be due to oxide of iron held in solution by the water, which percolates the sand. Embedding of organic and other remains in volcanic formations on the land. I have in some degree anticipated the subject of this section in former chapters, when speaking of the buried cities around Naples and those on the flanks of Etna. From the facts referred to, it appeared that the preservation of human remains and works of art is frequently due to the descent of floods caused by the copious rains which accompany eruptions. These aqueous lavas, as they are called in Campania, flow with great rapidity, and in 1822 surprised and suffocated, as was stated, 7 persons in the village of St. Sebastian and Massa on the flanks of Vesuvius. In the tuffs, moreover, or solidified mud, deposited by these aqueous lavas, impressions of leaves and of trees have been observed. Some of those, formed after the eruption of Vesuvius in 1822, are now preserved in the museum at Naples. Lava itself may become indirectly the means of preserving terrestrial remains by overflowing beds of ash, pumice, and ejected matter, which may have been showered down upon animals and plants or upon human remains. Few substances are better non-conductors of heat than volcanic dust and scoriae, so that a bed of such materials is rarely melted by a superimposed lava current. After consolidation, the lava affords secure protection to the lighter and more removable mass below, in which the organic relics may be enveloped. The Herculanean tuffs, containing the rolls of papyrus, of which the characters are still legible, have, as was before remarked, been for ages covered by lava. Another mode by which lava may tend to the conservation of embedded remains, at least of works of human art, is by its overflowing them when it is not intensely heated, in which case they sometimes suffer little or no injury. Thus, when the Etnian lava current of 1669 covered 14 towns and villages and part of the city of Catania, it did not melt down a great number of statues and other articles in the vaults of Catania, and at depth of 35 feet in the same current, on the site of Montpellier, one of the buried towns, the bell of a church and some statues were found uninjured. We read of several buried cities in central India, and among others of Uigean or Ujjain, which about 50 years before the Christian era was the seat of empire, of art, and of learning, but which in the time of Raja Vikramaditya was overwhelmed, according to tradition, together with more than 80 other large towns in the provinces of Malwa and Bagur, by a shower of earth. The city which now bears the name is situated a mile to the southward of the ancient town. On digging on the spot where the latter is supposed to have stood, to the depth of 15 or 18 feet, there are frequently discovered, says Mr. Hunter, entire brick walls, pillars of stone, and pieces of wood of an extraordinary hardness, besides utensils of various kinds, ancient coins, and occasionally buried wheat in a state resembling charcoal. The soil which covers Uigean is described as being of an ash-gray color with minute specks of black sand, and the shower of earth, said to have fallen from heaven, has been attributed by some travelers to volcanic agency. There are, however, no active volcanoes in central India, the nearest to Uigean being Danador Hill, near Bhuj, the capital of Kutch, 300 geographical miles distant, if indeed that hill has ever poured out lava in historical times, which is doubted by many. The latest writers on Uigean avow their suspicion that the supposed catastrophe was nothing more than the political decline and final abandonment of a great city, which, like Nineveh or Babylon, and many an ancient seat of empire in the East, after losing its importance as a metropolis, became a heap of ruins. The rapidity with which the sun-dried bricks, of which even the most splendid Oriental palaces are often constructed, crumble down when exposed to rain and sun, and are converted into mounds of ordinary earth and clay, is well known. According to Captain Dangerfield, trap tuff and columnar basalt constitute the rocks in the environs of Uigean, and the volcanic nature of these formations, from which the materials of the bricks were originally derived, may have led to the idea of the city having been overwhelmed by a volcanic eruption. End of chapter 45. End of section 97. Chapter 46 of Principles of Geology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Principles of Geology by Charles Lyell. Chapter 46. Burying of fossils in alluvial deposits and in caves. Fossils in alluvium. Effects of sudden inundations. Terrestrial animals most abundantly preserved in alluvium where earthquakes prevail. Marine alluvium. Buried town. Effects of landslips. Organic remains in fissures and caves. Form and dimensions of caverns. Their probable origin. Closed basins and subterranean rivers of the Morea. Catavothra. Formation of breccias with red cement. Human remains embedded in Morea. Intermixture in caves of south of France and elsewhere of human remains and bones of extinct quadrupeds. No proof of former coexistence of man with those lost species. Fossils in alluvium. The next subject for our consideration, according to the division before proposed, is the embedding of organic bodies in alluvium. The gravel, sand, and mud in the bed of a river does not often contain any animal or vegetable remains, for the whole mass is so continually shifting in place, and the attrition of the various parts is so great, that even the hardest rocks contained in it are at length ground down to powder. But when sand and sediment are suddenly swept by a flood and then let fall upon the land, such an alluvium may envelop trees or the remains of animals, which in this manner are often permanently preserved. In the mud and sand produced by the floods in Scotland in 1829, the dead and mutilated bodies of hares, rabbits, moles, mice, partridges, and even the bodies of men were found partially buried, but in these and similar cases one flood usually effaces the memorials left by another, and there is rarely a sufficient depth of undisturbed transported matter in any one spot to preserve the organic remains for ages from destruction. Where earthquakes prevail, and the levels of a country are changed from time to time, the remains of animals may more easily be inhumed and protected from disintegration. Portions of plains loaded with alluvial accumulations by transient floods may be gradually upraised, and if any organic remains have been embedded in the transported materials, they may, after such elevation, be placed beyond the reach of the erosive power of streams. In districts where the drainage is repeatedly deranged by subterranean movements, every fissure, every hollow caused by the sinking in of land, becomes a depository of organic and inorganic substances hurried along by transient floods. Marine alluvium. In May 1787, a dreadful inundation of the sea was caused at Coringa, Ingham, and other places on the coast of Coromandel, in the East Indies, by a hurricane blowing from the northeast, which raised the waters so that they rolled inland to the distance of about 20 miles from the shore, swept away many villages, drowned more 731 than 10,000 people, and left the country covered with marine mud, on which the carcasses of about 100,000 head of cattle were strewed. An old tradition of the natives of a similar flood, said to have happened about a century before, was till this event regarded as fabulous by the European settlers. The same coast of Coromandel was, so late as May 1832, the scene of another catastrophe of the same kind, and when the inundation subsided, several vessels were seen grounded in the fields of the low country about Coringa. Many of the storms termed hurricanes have evidently been connected with submarine earthquakes, as is shown by the atmospheric phenomena attendant on them, and by the sounds heard in the ground and the odors emitted. Such were the circumstances which accompanied the swell of the Sea of Jamaica in 1780, when a great wave desolated the western coast, and bursting upon Savannah La Mar, swept away the whole town in an instant, so that not a vestige of man, beast, or habitation was seen upon the surface. Houses and works of art in alluvial deposits. A very ancient subterranean town, apparently of Hindu origin, was discovered in India in 1833 in digging the Doab Canal. Its site is north of Saharanpur, near the town of Behat, and 17 feet below the present surface of the country. More than 170 coins of silver and copper have already been found, and many articles in metal and earthenware. The overlying deposit consisted of about 5 feet of river sand, with a substratum about 12 feet thick of red alluvial clay. In the neighborhood are several rivers and torrents, which descend from the mountains charged with vast quantities of mud, sand, and shingle, and within the memory of persons now living, the modern Behat has been threatened by an inundation, which, after retreating, left the neighboring country strewed over with a superficial covering of sand several feet thick. In sinking wells in the environs, masses of shingle and boulders have been reached resembling those now in the river channels of the same district under a deposit of 30 feet of reddish loam. Captain Cautley, therefore, who directed the excavations, supposes that the matter discharged by torrents has gradually raised the whole country skirting the base of the lower hills, and that the ancient town, having been originally built in a hollow, was submerged by floods and covered over with sediment 17 feet in thickness. We are informed by Mr. Bobley that in the Morea the formation termed céramique, consisting of pottery, tiles, and bricks intermixed with various works of art, enters so largely into the alluvium and vegetable soil upon the plains of Greece and into hard and crystalline breccias, which have been formed at the foot of declivities, that it constitutes an important stratum which might, in the absence of zoological characters, serve to mark our epoch in a most indestructible manner. Land slips. The landslip, by suddenly precipitating large masses of rock and soil into a valley, overwhelms a multitude of animals and sometimes buries permanently whole villages, with their inhabitants, and large herds of cattle. Thus 3 villages with their entire population were covered when the mountain of Piz fell in 1772 in the district of Treviso in the state of Venice, and part of Mount Grenier, south of Chambéry in Savoy, which fell down in the year 1248, buried 5 parishes, including the town and church of St. André, the ruins occupying an extent of about 9 square miles. The number of lives lost by the slide of the Rossberg in Switzerland in 1806 was estimated at more than 800. A great number of the bodies, as well as several villages and scattered houses, being buried deep under mud and rock. In the same country, several hundred cottages with 18 of their inhabitants and a great number of cows, goats, and sheep were victim to the sudden fall of a bed of stones 30 yards deep, which descended from the summits of the Diableries in Valais. In the year 1618, a portion of Mount Canto fell, in the county of Chiavenna, in Switzerland, and buried the town of Pleurs, with all its inhabitants, to the number of 2,430. It is unnecessary to multiply examples of similar local catastrophes, which, however numerous they may have been in mountainous parts of Europe within the historical period, have been nevertheless of rare occurrence when compared to events of the same kind which have taken place in regions convulsed with earthquakes. It is then that enormous masses of rock and earth, even in comparatively low and level countries, are detached from the sides of valleys and cast down into the river courses, and often so unexpectedly that they overwhelm, even in the daytime, every living thing upon the plains. Preservation of organic remains in fissures and caves. In the history of earthquakes, it was shown that many hundreds of new fissures and chasms had opened up in certain regions during the last 150 years, some of which are described as being of unfathomable depth. We also perceive that mountain masses have been violently fractured and dislocated during their rise above the level of the sea, and thus we may account for the existence of many cavities in the interior of the earth by the simple agency of earthquakes. But there are some caverns, especially in limestone rocks, which, although usually, if not always, connected with rents, are nevertheless of such forms and dimensions, alternately expanding into spacious chambers and then contracting again into narrow passages, that it is difficult to conceive that they can owe their origin to the mere fracturing and displacement of solid masses. In the limestone of Kentucky, in the basin of Green River, one of the 733 tributaries of the Ohio, a line of underground cavities has been traced in one direction for a distance of 10 miles, without any termination, and one of the chambers, of which there are many, all connected by narrow tunnels, is no less than 10 acres in area and 150 feet in its greatest height. Besides the principal series of entrebâts, there are a great many lateral embranchments not yet explored. The cavernous structure here alluded to is not altogether confined to calcareous rocks, for it has lately been observed in micaceous and argillaceous schist, in the Grecian island of Thermia, Scythnos of the ancients, one of the Cyclades. Here also spacious halls with rounded and irregular walls are connected together by narrow passages or tunnels, and there are many lateral branches which have no outlet. A current of water is evidently at some period flowed through the hole and left a muddy deposit of bluish clay upon the floor, but the erosive action of the stream cannot be supposed to have given rise to the excavations in the first instance. Mr. Verlet suggests that fissures were first caused by earthquakes, and that these fissures became the chimneys or vents for the disengagement of gas, generated below by volcanic heat. Gases, he observes, such as muriatic, sulfuric, fluoric, and others, might, if raised to a high temperature, alter and decompose the rocks which they traverse. There are signs of the former action of such vapors in rents of the micaceous schist of Thermia, and thermal springs now issue from the grottos of that island. We may suppose that afterwards the elements of the decomposed rocks were gradually removed in a state of solution by mineral waters, a theory which, according to Mr. Verlet, is confirmed by the effect of heated gases which escape from rents in the isthmus of Corinth, and which have greatly altered and corroded the hard siliceous and jaspedious rocks. When we reflect on the quantity of carbonate of lime annually poured out by mineral waters, we are prepared to admit that large cavities must in the course of ages be formed at considerable depths below the surface in calcareous rocks. These rocks, it will be remembered, are at once more soluble, more permeable, and more fragile than any others. At least all the compact varieties are very easily broken by the movements of earthquakes, which would produce only flexures in argillaceous strata. Fissures once formed in limestone are not liable, as in many other formations, to become closed up by the impervious clayey matter, and hence a stream of acidulous water might for ages obtain a free and unobstructed passage. Morea. Nothing is more common in limestone districts than the engulfment of rivers, which, after holding a subterranean course for many miles, escape again by some new outlet. As they are usually charged with fine sediment, and often with sand and pebbles where they enter, whereas they are usually pure and limpid where they flow out again, they must deposit much matter in empty spaces in the interior of the earth. In addition to the materials thus introduced, stalagmite or carbonate of lime drops from the roofs of caverns, and in this mixture the bones of animals washed in by rivers are often entombed. In this manner we may account for those bony breccias which we often find in caves, some of which are of high antiquity, while others are very recent and in daily progress. In no district are engulfed streams more conspicuous than in the Morea, where the phenomena attending them have been lately studied and described in great detail by Mr. Bobley and his fellow laborers of the French expedition to Greece. Their account is peculiarly interesting to geologists, because it throws light on the red osseous breccias containing the bones of extinct quadrupeds, which are so common in almost all the countries bordering the Mediterranean. It appears that the numerous caverns of the Morea occur in a compact limestone of the age of the English chalk immediately below, which are arenaceous strata refer to the period of our greensand. In the more elevated districts of that peninsula there are many deep land-locked valleys, or basins, closed round on all sides by mountains of fissured and cavernous limestone. The year is divided almost as distinctly as between the tropics into a rainy season, which lasts upwards of 4 months, and a season of drought of nearly 8 months' duration. When the torrents are swollen by the rains, they rush from surrounding heights into the enclosed basins. But instead of giving rise to lakes, as would be the case in most other countries, they are received into gulfs, or chasms, called by the Greeks kataphora, and which correspond to what are termed swallow holes in the north of England. The water of these torrents is charged with pebbles and red ochreous earth, resembling precisely the well-known cement of the osseous breccias of the Mediterranean. It dissolves in acids with effervescence, and leaves a residue of hydrated oxide of iron, granular iron, impalpable grains of silex, and small crystals of quartz. Soil of the same description abounds everywhere on the surface of the decomposing limestone in Greece, that rock containing in it much siliceous and ferruginous matter. Many of the kataphora being insufficient to give passage to all the water in the rainy season, a temporary lake is formed round the mouth of the chasm, which then becomes still farther obstructed by pebbles, sand, and red mud, thrown down from the turbid waters. The lake being thus raised, its waters generally escape through the other openings at higher levels, around the borders of the plain, constituting the bottom of the closed basin. In some places, as at Kavaros and Tripolitza, where the principal discharge is by a gulf in the middle of the plain, nothing can be seen over the opening in summer, when the lake dries up, but a deposit of red mud, cracked in all directions. But the Kataphotron is more commonly situated at the foot of the surrounding escarpment of limestone, and in that case there is sometimes room enough to allow a person to enter in summer and even to penetrate far into the interior. Within is seen a suite of chambers, communicating with each other by narrow passages, and Mr. Verlet relates that in one instance he observed near the entrance human bones embedded in recent red mud, mingled with the remains of plants and animals of species now inhabiting the Morea. Is it not wonderful, he says, that the bones of man should be met with in such receptacles? For so murderous have been the late wars in Greece that skeletons are often seen lying exposed on the surface of the country. In summer, when no water is flowing into the Katavothron, its mouth, half closed up with red mud, is masked by a vigorous vegetation, which is cherished by the moisture of the place. It is then the favorite hiding place of den of foxes and jackals, so that the same cavity serves at one season of the year for the habitation of carnivorous beasts, and at the other as the channel of an engulfed river. Near the mouth of one chasm, Mr. Bobley and his companions saw the carcass of a horse, in part devoured, the size of which seems to have prevented the jackals from dragging it in. The marks of their teeth were observed on the bones, and it was evident that the floods of the ensuing winter would wash in whatsoever might remain of the skeleton. It has been stated that the waters of all these torrents of the Morea are turbid where they are engulfed, but when they come out again, often at the distance of many leagues, they are perfectly clear and limpid, being only charged occasionally with a slight quantity of calcareous sand. The points of efflux are usually near the seashores of the Morea, but sometimes they are submarine, and when this is the case the sands are seen to boil up for a considerable space, and the surface of the sea, in calm weather, swells in large convex waves. It is curious to reflect that when this discharge fails in seasons of drought, the pressure of the sea may force its salt waters into subterraneous caverns, and carry in marine sands and shells to be mingled with ossiferous mud and the remains of terrestrial animals. In general, however, the efflux of water at these inferior openings is surprisingly uniform. It seems, therefore, that the large caverns in the interior must serve as reservoirs, and that the water escapes gradually from them, in consequence of the smallness of the rents and passages by which they communicate with the surface. The phenomena above described are not confined to the Morea, but occur in Greece generally, and in those parts of Italy, Spain, Asia Minor, and Syria where the formations of the Morea extend. The Copaic Lake in Boeotia has no outlet, except by underground channels, and hence can we explain those traditional and historical accounts of its having gained on the surrounding plains and overflowed towns, as such floods must have happened whenever the outlet was partially choked up by mud, gravel, or the subsidence of rocks caused by earthquakes. When speaking of the numerous fissures in the limestone of Greece, Mr. Bobley reminds us of the famous earthquake of 469 B.C., when, as we learn from Cicero, Plutarch, Strabo, and Pliny, Sparta was laid in ruins, part of the summit of Mount Taygetus torn off, and numerous gulfs and fissures caused in the rocks of Laconia. During the great earthquake of 1693 in Sicily, several thousand people were at once entombed in the ruins of caverns in limestone at Sartinio Vecchio, and at the same time a large stream, which had issued for ages from one of the grottos below that town, changed suddenly its subterranean course and came out from the mouth of a cave lower down the valley, where no water had previously flowed. To this new point the ancient water mills were transferred, as I learnt when I visited the spot in 1829. When the courses of engulfed rivers are thus liable to change from time to time by alternations in the levels of a country, and by the rending and shattering of mountain masses, we must suppose that the dens of wild beasts will sometimes be inundated by subterranean floods, and their carcasses buried under heaps of alluvium. The bones, moreover, of individuals which have died in the recesses of caves, or of animals which have been carried in for prey, may be drifted along and mixed up with the mud, sand, and fragments of rocks so as to form osseous breccias. In 1833 I had an opportunity of examining the celebrated caves of Franconia, and among others that of Rabenstein, newly discovered. Their general form and the nature and arrangement of their contents appear to me to agree perfectly with the notion of their having once served as the channels of subterranean rivers. This mode of accounting for the introduction of transported matter into the Franconian and other caves, filled up as they often are even to their roofs with osseous breccia, was long ago proposed by M.C. Prevost, and seems at length to be very generally adopted. But I do not doubt that bears inhabited some of the German caves, or that the cavern of Kirkdale in Yorkshire was once the den of hyenas. The abundance of bony dung associated with hyenas' bones has been pointed out by Dr. Buckland, and with reason, as confirmatory of this opinion. The same author observed in every cave examined by him in Germany that deposits of mud and sand, with or without rolled pebbles and angular fragments of rock, were covered over with a single crust of stalagmite. In the English caves he remarked a similar absence of alterations of alluvium and stalagmite. But Dr. Schmerling has discovered in a cavern at Chalkier, about 2 leagues from Leach, 3 distinct beds of stalagmite, and between each of them a mass of breccia, and mud mixed with quartz pebbles, and in the 3 deposits the bones of extinct quadrupeds. This exception does not invalidate the generality of the phenomenon pointed out by Dr. Buckland, one cause of which may perhaps be this, that if several floods pass at different intervals of time through a subterranean passage, the last, if it has power to drift along fragments of rock, will also tear up any alternating stalagmitic and alluvial beds that may have been previously formed. Another cause may be that a particular line of caverns will rarely be so situated in relation to the lowest levels of a country as to become, at 2 distinct epochs, the receptacle of engulfed rivers. And if this should happen, some of the caves, or at least the tunnels of communication, may at the first period be entirely choked up with transported matter, so as not to allow the subsequent passage of water in the same direction. As the same chasms may remain open throughout the periods of indefinite duration, the species inhabiting a country may in the meantime be greatly changed, and thus the remains of animals belonging to very different epochs may become mingled together in a common tomb. For this reason, it is often difficult to separate the monuments of the human epoch from those relating to periods long antecedent, and it was not without great care and skill that Dr. Buckland was enabled to guard against such anachronisms in his investigations of several of the English caves. He mentions that human skeletons were found in the cave of Wokie Hole, near Wells, in the Mendips, dispersed through reddish mud and clay, and some of them united by stalagmite into a firm osseous breccia. The spot on which they lie is within reach of the highest floods of the adjacent river, and the mud in which they are buried is evidently fluviatile. In speaking of the cave of Paviland on the coast of the Glamorganshire, the same author states that the entire mass through which bones were dispersed appears to have been disturbed by ancient diggings, so that the remains of extinct animals had become mixed with recent bones and shells. In the same cave was a human skeleton, and the remains of recent testacea of eatable species, which may have been carried in by man. In several caverns on the banks of the Meuse near Leach, Dr. Schermerling has found human bones in the same mud and breccia with those of the elephant, rhinoceros, bear, and other quadrupeds of extinct species. He has observed none of the dung of any of these animals, and from this circumstance, and the appearance of the mud and pebbles, he concludes that these caverns were never inhabited by wild beasts, but washed in by a current of water. As the human skulls and bones were in fragments, and no entire skeleton has been found, he does not believe that these caves were places of sepulture, but that the human remains were washed in at the same time as the bones of extinct quadrupeds, and that these lost species of mammalia coexisted on the earth with man. Caverns in the south of France. Similar associations in the south of France of human bones and works of art with remains of extinct quadrupeds have induced other geologists to maintain that man was an inhabitant of that part of Europe before the rhinoceros, hyena, tiger, and many fossil species disappeared. I may first mention the cavern of Baise, in the department of Aude, where M. Marcel Desiré met with a small number of human bones mixed with those of extinct animals and with land shells. They occur in a calcareous stony mass bound together by a cement of stalagmite. On examining the same caverns, M. Tournal found not only in these calcareous beds, but also in black mud, which overlies a red osseous mud, several human teeth, together with broken angular fragments of a rude kind of pottery, and also recent marine and terrestrial shells. The teeth preserve their enamel, but the fangs are so much altered as to adhere strongly when applied to the tongue. Of the terrestrial shells thus associated with the bones and pottery, the most common are Cyclostoma elegans, Bulimus decolatus, Helix memoralis, and H. nitida. Among the marine are found Pecten jacobius, Mytilus edulis, and Attica millipunctata, all of them eatable kinds, and which may have been brought there for food. Bones were found in the same mass belonging to 3 new species of deer, the brown bear, Ursus arctoideus, and the wild bull, Bos urus, formerly a native of Germany. In the same parts of France, M. de Cristol has found in caverns, in a tertiary limestone at Pondre and Sauvignargues, 2 leagues north of Lunelville, in the department of Hérault, human bones and pottery, confusedly mixed with remains of the rhinoceros, bear, hyena, and other terrestrial mammifers. They were embedded in alluvial mud, of the solidity of calcareous tufa, and containing some flint pebbles and fragments of the limestone of the country. Beneath this mixed accumulation, which sometimes attained a thickness of 13 feet, is the original floor of the cavern, about a foot thick, covered with bones and the dung of animals, album Graecum, in a sandy and tufaceous cement. The human bones in these caverns of Pondre and Sauvignargues were found, upon a careful analysis, to have parted with their animal matter to as great a degree as those of the hyena which accompany them, and are equally brittle, and adhere as strongly to the tongue. In order to compare the degrees of alteration of these bones with those known to be of high antiquity, M. Marcel Desiré and M. Ballet, chemists of Montpellier, procured some form of Gaulish sarcophagus in the plain of Lunel, supposed to have been buried for 14 or 15 centuries at least. In these, the cellular tissue was empty, but they were more solid than fresh bones. They did not adhere to the tongue in the same manner as those of the caverns of Pisa and Pondre, yet they had lost at least 3/4 of their original animal matter. The superior solidity of the Gaulish bones to those in a fresh skeleton is a fact in perfect accordance with the observations made by Dr. Mantell on bones taken from a Saxon tumulus near Lewes. M. Tessier has also described a cavern near Mialet in the department of Gard, where the remains of the bear and other animals were mingled confusedly with human bones, coarse pottery, teeth pierced for amulets, pointed fragments of bone, bracelets of bronze, and a Roman urn. Part of this deposit reached to the roof of the cavity and adhered firmly to it. The author suggests that the exterior portion of the grotto may at one period have been a den of bears, and that afterwards the aboriginal inhabitants of the country took possession of it either for a dwelling or a burial place, and left there the coarse pottery, amulets, and pointed pieces of bone. At a third period, the Romans may have used the cavern as a place of sepulture or concealment, and to them may have belonged the urn and bracelets of metal. If we then suppose the course of the neighboring river to be impeded by some temporary cause, a flood would be occasioned, which, rushing into the open grotto, may have washed all the remains into the interior caves and tunnels, heaping the whole confusedly together. In the controversy which has arisen on this subject, Messrs. Marcel de Serres, de Cristol, Tournal, and others have contended that the phenomena of this and other caverns in the south of France prove that the fossil rhinoceros, hyena, bear, and several other lost species were once contemporaneous inhabitants of the country, together with man. Desnoyers has supported the opposite opinion. The flint hatchets and arrowheads, he says, and the pointed bones and coarse pottery of many French and English caves agree precisely in character with those found in the tumuli and under the dolmens, rude altars of unhewn stone, of the primitive inhabitants of Gaul, Britain, and Germany. The human bones, therefore, in the caves which are associated with such fabricated objects must belong not to antediluvian periods, but to a people in the same stage of civilization as those who constructed the tumuli and altars. In the Gaulish monuments we find, together with the objects of industry above mentioned, the bones of wild and domestic animals of species now inhabiting Europe, particularly of deer, sheep, wild boar, dogs, horses, and oxen. This fact has been ascertained in Quercy and other provinces, and it is supposed to be antiquaries that the animals in question were placed beneath the Celtic altars in memory of sacrifices offered to the Gaulish divinity Hasus, and in the tombs to commemorate funeral repasts, and also from a supposition prevalent among savage nations which induces them to lay up provisions for the manes of the dead in a future life. But in none of these ancient monuments have any bones been found of the elephant, rhinoceros, hyena, tiger, and other quadrupeds such as are found in caves, as might certainly have been expected had these species continued to flourish at the time that this part of Gaul was inhabited by man. We are also reminded by M. Desnoyers of a passage in Florus, in which it is related that Caesar ordered the caves into which the Aquitanian Gauls had retreated to be closed up. It is also on record that so late as the 8th century the Aquitanians defended themselves in caverns against King Pepin. As many of these caverns, therefore, may have served in succession as temples and habitations, as places of sepulture, concealment, or defense, it is easy to conceive that human bones, and those of animals, in osseous breccias of much older date, may have been swept away together by inundations, and then buried in one promiscuous heap. It is not on the evidence of such intermixtures that we ought readily to admit either the high antiquity of the human race or the recent date of certain lost species of quadrupeds. Among the various modes in which the bones of animals become preserved independently of the agency of land floods and engulfed rivers, I may mention that open fissures often serve as natural pitfalls in which herbivorous animals perish. This may happen the more readily when they are chased by beasts of prey, or when surprised while carelessly browsing on the shrubs, which so often overgrow and conceal the edges of fissures. During the excavations recently made near Bharat in India, the bones of 2 deer were found at the bottom of an ancient well which had been filled up with alluvial loam. Their horns were broken to pieces, but the jawbones and other parts of the skeleton remained tolerably perfect. Their presence, says Captain Cautley, is easily accounted for, as a great number of these and other animals are constantly lost in galloping over the jungles and among the high grass by falling into deserted wells. Above the village of Selside, near Ingleborough in Yorkshire, a chasm of enormous but unknown depth occurs in the Scar limestone, a member of the Carboniferous series. The chasm, says Professor Sedgwick, is surrounded by grassy shelving banks, and many animals, tempted towards its brink, have fallen down and perished in it. The approach of the cattle is now prevented by a strong lofty wall, but there can be no doubt that during the last 2,000 or 3,000 years great masses of bony breccia must have accumulated in the lower parts of the great fissure, which probably descends through the whole thickness of the Scar limestone to the depth of perhaps 500 or 600 feet. When any of these natural pitfalls happen to communicate with lines of subterranean caverns, the bones, earth, and breccia may sink by their own weight, or be washed into the vaults below. At the north extremity of the Rock of Gibraltar are perpendicular fissures, on the ledges of which a number of hawks nestle and rear their young in the breeding season. They throw down from their nests the bones of small birds, mice, and other animals on which they feed, and these are gradually united into a breccia of angular fragments of the decomposing limestone with a cement of red earth. At the pass of Iscrenay in France, on the northern escarpment of the Corian Hills near Aubenas, I have seen a breccia in the act of forming. Small pieces of disintegrating limestone are transported during heavy rains by a streamlet to the foot of the declivity, where land shells are very abundant. The shells and pieces of stone soon become cemented together by a stalagmite into a compact mass, and the talus thus formed is in one place 50 feet deep and 500 yards wide. So firmly is the lowest portion consolidated that it is quarried for millstones. Recent stalagmitic limestone of Cuba. One of the most singular examples of the recent growth of stalagmitic limestone in caves and fissures is that described by Mr. R.C. Taylor as observable on the northeast part of the island of Cuba. The country there is composed of a white marble, in which are numerous cavities, partially filled with a calcareous deposit of a brick-red color. In this red deposit are shells, or often the hollow casts of shells, chiefly referable to 8 or 9 species of land snails, a few scattered bones of quadrupeds, and, what is still more singular, marine univalve shells, often at the height of many hundred or even 1,000 feet above the sea. The following explanation is given on the gradual increase of this deposit. Land snails of the genera Helix, Cyclostoma, Pupa, and Clausilia retire into the caves, the floors of which are strewed with myriads of their dead and unoccupied shells, at the same time that water, infiltered through the mountain, throws down carbonate of lime, enveloping the shells, together with fragments of the white limestone which occasionally falls from the roof. Multitudes of bats resort to the caves, and their dung, which is of a bright red color, probably derived from the berries on which they feed, imparts its red hue to the mass. Sometimes also the hutia, or great Indian rat of the island, dies and leaves its bones in the caves. At certain seasons the soldier crabs resort to the seashore and then return from their pilgrimage, each carrying with them, or rather dragging, the shell of some marine univalve for many a weary mile. They may be traced even at the distance of 8 or 10 miles from the shore, on the summit of mountains 1,200 feet high, like the pilgrims of the olden times, each bearing his shell to denote the character and extent of his wanderings. By this means, several species of marine testacea of the genera Trochus, Turbo, Litorina, and Monodonta are conveyed into inland caverns and enter into the composition of the newly formed rock. End of section 98.
Chapter 47 of Principles of Geology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Principles of Geology by Charles Lyell. Chapter 47. Embedding of Organic Remains in Subaqueous Deposits. Division of the subject. Embedding of terrestrial animals and plants. Increased specific gravity of wood sunk to great depths in the sea. Drift timber of the Mackenzie in Slave Lake and Polar Sea. Floating trees in the Mississippi, in the Gulf Stream, on the coast of Iceland, Spitzbergen, and Labrador. Submarine forests, example on coast of Hampshire. Mineralization of plants, embedding of marine plants, of insects, of reptiles. Bones of birds, Y. rare. Embedding of terrestrial quadrupeds by river floods. Skeletons in recent shell marl. Embedding of mammiferous remains in marine strata. Division of the subject. Having treated of the embedding of organic remains in deposits formed upon the land, I shall next consider the including of the same in deposits formed under water. It will be convenient to divide this branch of our subject into 3 parts, considering first the various modes whereby the relics of terrestrial species may be buried in subaqueous formations. Secondly, the modes whereby animals and plants inhabiting fresh water may be so entombed. Thirdly, how marine species may become preserved in new strata. The phenomena above enumerated demand a fuller share of attention than those previously examined, since the deposits which originate upon dry land are insignificant in thickness, superficial extent, and durability, when contrasted with those of subaqueous origin. At the same time, the study of the latter is beset with greater difficulties, for we are here concerned with the results of processes much farther removed from the sphere of ordinary observation. There is, indeed, no circumstance which so seriously impedes the acquisition of just views in our science as an habitual disregard of the important fact that the reproductive effects of the principal agents of change are confined to another element, to that larger portion of the globe from which by our very organization we are almost entirely excluded. Embedding of terrestrial plants. When a tree falls into a river from the undermining of the banks or from being washed in by a torrent or flood, it floats on the surface, not because the woody portion is specifically lighter than water, but because it is full of pores containing air. When soaked for a considerable time, the water makes its way into these pores, and the wood becomes waterlogged and sinks. The time required for this process varies in different woods, but several kinds may be drifted to great distances, sometimes across the ocean, before they lose their buoyancy. Wood sunk to a great depth in the sea. If wood be sunk to vast depths in the sea, it may be impregnated with water suddenly. Captain Scoresby informs us, in his account of the Arctic regions, that on one occasion a whale, on being harpooned, ran out all the lines in the boat, which it then dragged under water to a depth of several thousand feet, the men having just time to escape to a piece of ice. When the fish returned to the surface to blow, it was struck a second time, and soon afterwards killed. The moment it expired it began to sink, an unusual circumstance, which was found to be caused by the weight of the sunken boat, which still remained attached to it. By means of harpoons and ropes the fish was prevented from sinking, until it was released from the weight by connecting a rope to the lines of the attached boat, which was no sooner done than the fish rose again to the surface. The sunken boat was then hauled up with great labour, for so heavy was it that although before the accident it would have been buoyant when full of water, yet it now required a boat at each end to keep it from sinking. When it was hoisted into the ship, the paint came off the wood in large sheets, and the planks, which were of wainscot, were as completely soaked in every pore as if they had lain at the bottom of the sea since the flood. A wooden apparatus that accompanied the boat in its progress through the deep, consisting chiefly of a piece of thick deal about 15 inches square, happened to fall overboard, and, though it originally consisted of the lightest fur, sank in the water like a stone. The boat was rendered useless. Even the wood of which it was built, on being offered to the cook for fuel, was tried and rejected as incombustible. Captain Scoresby found that, by sinking pieces of fir, elm, ash, etc., to a depth of 4,000 and sometimes 6,000 feet, they became impregnated with sea water, and when drawn up again, after immersion for an hour, would no longer float. The effect of this impregnation was to increase the dimensions as well as the specific gravity of the wood, every solid inch having increased 1/20th in size and 21/25 in weight. Driftwood of the Mackenzie River. When timber is drifted down by a river, it is often arrested by lakes, and becoming waterlogged, it may sink and be embedded in lacustrine strata, if any be there forming. Sometimes a portion floats on until it reaches the sea. In the course of the Mackenzie River, we have an example of vast accumulations of vegetable matter now in progress under both these circumstances. In Slave Lake in particular, which vies in dimensions with some of the great freshwater seas of Canada, the quantity of drift timber brought down annually is enormous. As the trees, says Dr. Richardson, retain their roots, which are often loaded with earth and stones, they readily sink, especially when water-soaked, and, accumulating in the eddies, form shoals, which ultimately augment into islands. A thicket of small willows covers the new-formed island as soon as it appears above water, and their fibrous roots serve to bind the whole firmly together. Sections of these islands are annually made by the river, assisted by the frost, and it is interesting to study the diversity of appearances they present, according to their different ages. The trunks of the trees gradually decay until they are converted into a blackish-brown substance resembling peat, but which still retains more or less of the fibrous nature of the wood, and layers of this often alternate with layers of clay and sand, the whole being penetrated, to the depth of 4 or 5 yards or more, by the long fibrous roots of the willows. A deposition of this kind, with the aid of a little infiltration of bituminous matter, would produce an excellent imitation of coal, with vegetable impressions of the willow roots. What appeared most remarkable was the horizontal slatty structure that the old alluvial banks presented, or the regular curve that the strata assumed from unequal subsidence. It was in the rivers only that we could observe sections of these deposits, but the same operation goes on a much more significant scale, in the lakes. A shoal of many miles in extent is formed on the south side of Athabasca Lake by the drift timber and vegetable debris brought down by the Elk River, and the Slave Lake itself must in process of time be filled up by matters daily conveyed into it from Slave River. Vast quantities of drift timber are buried under the sand at the mouth of the river, and enormous piles of it are accumulated on the shores of every part of the lake. The banks of the Mackenzie display almost everywhere horizontal beds of wood coal, alternating with bituminous clay, gravel, sand, and friable sandstone. Sections, in short, of such deposits as are now evidently forming at the bottom of the lakes which it traverses. Notwithstanding the vast forests intercepted by the lakes, a still greater mass of driftwood is found where the Mackenzie reaches the sea, in a latitude where no wood grows at present except a few stunted willows. At the mouths of the river the alluvial matter has formed a barrier of islands and shoals, where we may expect a great formation of coal at some distant period. The abundance of floating timber on the Mackenzie is owing, as Dr. Richardson informs me, to the direction and to the length of the course of this river, which runs from south to north, so that the sources of the stream lie in much warmer latitudes than its mouths. In the country, therefore, where the sources are situated, the frost breaks up at an earlier season, while yet the rivers in the lower part of its course are ice-bound. Hence the current of water, rushing down northward, reaches a point where the thaw has not begun, and, finding the channel of the river blocked up with ice, it overflows the banks, sweeping through forests of pines and carrying away thousands of uprooted trees. Drift timber on coasts of Iceland, Spitzbergen, etc. The ancient forests of Iceland, observes Maltebrun, have been improvidently exhausted. But, although the Icelander can obtain no timber from the land, he is supplied with it abundantly by the ocean. An immense quantity of thick trunks of pines, firs, and other trees are thrown upon the northern coast of the island, especially upon the North Cape and Cape Longinus, and are then carried by the waves along these two promontories to other parts of the coast, so as to afford sufficiency of wood for fuel and for constructing boats. Timber is also carried to the shores of Labrador and Greenland, and Krantz assures us that the masses of floating wood thrown by the waves upon the island of John de Mayenne often equal the whole of that island in extent. In a similar manner, the bays of Spitzbergen are filled with driftwood, which accumulates also upon those parts of the coast of Siberia that are exposed to the east, consisting of larch trees, pines, Siberian cedars, firs, and Pernambuco and Campeche woods. These trunks appear to have been swept away by the great rivers of Asia and America. Some of them are brought from the Gulf of Mexico by the Bahama stream, while others are hurried forward by the current which, to the north of Siberia, constantly sets in from east to west. Some of these trees have been deprived of their bark by friction, but are in such a state of preservation as to form excellent building timber. Parts of the branches and almost all of the roots remain fixed to the pines which have been drifted into the North Sea into latitudes too cold for the growth of such timber, but the trunks are usually barked. The leaves and lighter parts of plants are seldom carried out to sea in any part of the globe, except during tropical hurricanes among islands, and during the agitations of the atmosphere which sometimes accompany earthquakes and volcanic eruptions. Comparative number of living and fossilized species of plants. It will appear from these observations that, although the remains of terrestrial vegetation, borne down by aqueous causes from the land, are chiefly deposited at the bottom of lakes or at the mouths of rivers, yet a considerable quantity is drifted about in all directions by currents, and may become embedded in any marine formation, or may sink down, when waterlogged, to the bottom of unfathomable abysses, and there accumulate without intermixture with other substances. It may be asked whether we have any data for inferring that the remains of a considerable proportion of the existing species of plants will be permanently preserved, so as to be hereafter recognizable, supposing the strata now in progress to be at some future period upraised. To this inquiry it may be answered that there are no reasons for expecting that more than a small number of the plants now flourishing on the globe will become fossilized, since the entire habitations of a great number of them are remote from lakes and seas, and even where they grow near to large bodies of water, the circumstances are quite accidental and partial which favor the embedding and conservation of vegetable remains. Suppose, for example, that the species of plants inhabiting the hydrographical basin of the Rhine, or that region extending from the Alps to the sea, which is watered by the Rhine and its numerous tributaries, to be about 2,500 in number, exclusive of the cryptogamic class. This estimate is by no means exaggerated. Yet if a geologist could explore the deposits which have resulted from the sediment of the Rhine in the Lake of Constance, and off the coast of Holland, he could scarcely expect to obtain from the recent strata the leaves, wood, and seeds of 50 species in such a state of preservation as to enable a botanist to determine their specific characters with certainty. Those naturalists, therefore, who infer that the ancient flora of the globe was, at certain periods, less varied than now, merely because they have as yet discovered only a few hundred fossil species of a particular epoch, while they can enumerate more than 100,000 living ones, are reasoning on a false basis, and their standard of comparison is not the same in the two cases. Submarine forests on coast of haunts. We have already seen that the submarine position of several forests, or the remains of trees standing in a vertical position on the British shores, has been due, in some instances, to the subsidence of land. There are some cases which require a different explanation. My friend, Mr. Charles Harris, discovered in 1831 evident traces of a fir wood beneath the mean level of the sea, at Barnmouth, in Hampshire, the formation having been laid open during a low spring tide. It is composed of peat and wood, and is situated between the beach and a bar of sand about 200 yards off, and extends 50 yards along the shore. It also lies in the direct line of the Bournemouth Valley, from the termination of which it is separated by 200 yards of shingle and drift sand. Down the valley flows a large brook, traversing near its mouth a considerable tract of rough, boggy, and heathy ground, which produces a few birch trees and a great abundance of the myrica gale. 76 rings of annual growth were counted in a transverse section of one of the buried fir trees, which was 14 inches in diameter. Besides the stumps and roots of fir, pieces of alder and birch are found in the peat, and it is a curious fact that a part of many of the trees have been converted into iron pyrites. The peat rests on pebbly strata, precisely similar to the sand and pebbles occurring on the adjoining heaths. As the sea is encroaching on this shore, we may suppose that at some former period the Bourne Valley extended farther, and that its extremity consisted, as at present, of boggy ground, partly clothed with fir trees. The bog rested on that bed of pebbles which we now see below the peat, and the sea, in its progressive encroachments, eventually laid bare, at low water, the sandy foundations, upon which a stream of fresh water, rushing through the sand at the fall of the tides, carried out loose sand with it. The superstratum of vegetable matter, being matted and bound together by the roots of trees, remained, but, being undermined, sank down below the level of the sea, and then the waves washed sand and shingle over it. In support of this hypothesis, it may be observed that small streams of fresh water often pass under the sands of the sea beach, so that they may be crossed dry-shod, and the water is seen, at the point where it issues, to carry out sand and even pebbles. Mineralization of plants. Although the botanist and chemist have as yet been unable to explain fully the manner in which wood becomes petrified, it is nevertheless ascertained that, under favorable circumstances, the lapidifying process is now continually going on. A piece of wood was lately procured by Mr. Stokes from an ancient Roman aqueduct in Westphalia, in which some portions were converted into spindle-shaped bodies consisting of carbonate of lime, while the rest of the wood remained in a comparatively unchanged state. It appears that in some cases the most perishable, in others the most durable, portions of plants are preserved, variations which doubtless depend on the time when the mineral matter was supplied. If introduced immediately, on the first commencement of decomposition, then the most destructible parts are lapidified, while the more durable do not waste away till afterwards, when the supply has failed, and so never become petrified. The converse of these circumstances gives rise to exactly opposite results. Professor Goppert, of Breslau, has instituted a series of curious experiments, in which he has succeeded in producing some very remarkable imitations of fossil petrifactions. He placed recent ferns between soft layers of clay, dried these in the shade, and then slowly and gradually heated them, till they were red hot. The result was the production of so perfect a counterpart of fossil plants as might have deceived an experienced geologist. According to the different degrees of heat applied, the plants were obtained in a brown or perfectly carbonized condition, and sometimes, but more rarely, they were in a black shining state, adhering closely to the layer of clay. If the red heat was sustained until all the organic matter was burnt up, only an impression of the plant remained. The same chemist steeped plants in a moderately strong solution of sulphate of iron, and left them immersed in it for several days, until they were thoroughly soaked in the liquid. They were then dried and kept heated until they could no longer shrink in volume, and until every trace of organic matter had disappeared. On cooling them, he found that the oxide formed by this process had taken the form of the plants. A variety of other experiments were made by steeping animal and vegetable substances in siliceous, calcareous, and metallic solutions, and all tended to prove that the mineralization of organic bodies can be carried much farther in a short time than had been previously supposed. Embedding of the remains of insects. I have observed the elytra and other parts of beetles in a band of fissile clay, separating two beds of recent shell marl, in the loch of Kinnordy in Forfarshire. Amongst these, Mr. Curtis recognized Elator lineatus and Atopa cervina, species still living in Scotland. These, as well as other remains which accompanied them, appear to belong to terrestrial, not aquatic species, and must have been carried down in muddy water during an inundation. In the lacustrine peat of the same locality, the elytra of beetles were not uncommon, but in the deposits of drained lakes generally, and in the silt of our estuaries, the relics of this class of the animal kingdom are rare. In the blue clay of very modern origin of Lewis Levels, Dr. Mantell has found the indusia, or cases of the larvae of Phrygiania, in abundance, with minute shells belonging to the genera Planorbis, Limnaea, etc., adhering to them. When speaking of the migrations of insects, I pointed out that an immense number are floated into lakes and seas by rivers, or blown by winds far from the land. But they are so buoyant that we can only suppose them, under very peculiar circumstances, to sink to the bottom before they are either devoured by insectivorous animals or decomposed. Remains of reptiles. As the bodies of several crocodiles were found in the mud brought down to the sea by the river inundation which attended an earthquake in Java in the year 1699, we may imagine that extraordinary floods of mud may stifle many individuals of the shoals of alligators and other reptiles which frequent lakes and the deltas of rivers in tropical climates. Thousands of frogs were found leaping about among the wreck, carried into the sea by the inundations in Morayshire in 1829, and it is evident that whenever a sea cliff is undermined, or land is swept by other violent causes into the sea, land reptiles may be carried in. Remains of birds. We might have anticipated that the embedding of the remains of birds in new strata would be a very rare occurrence, for their powers of flight ensure them against perishing by numerous casualties to which quadrupeds are exposed during floods, and if they chance to be drowned, or to die when swimming on the water, it will scarcely ever happen that they will be submerged so as to become preserved in sedimentary deposits. In consequence of the hollow tubular structure of their bones and the quantity of their feathers, they are extremely light in proportion to their volume, so that when first killed they do not sink to the bottom like quadrupeds, but float on the surface until the carcass either rots away or is devoured by predaceous animals. To these causes we may ascribe the absence of any vestige of the bones of birds in the recent marl formations of Scotland, although these lakes, until the moment when they were artificially drained, were frequented by a great abundance of waterfowl. Embedding of terrestrial quadrupeds. River inundations recur in most climates at very irregular intervals, and expend their fury on those rich alluvial plains where herds of herbivorous quadrupeds congregate together. These animals are often surprised, and, being unable to stem the current, are hurried along until they are drowned, when they sink at first immediately to the bottom. Here their bodies are drifted along, together with sediment, into lakes or seas, and may then be covered by a mass of mud, sand, and pebbles thrown down upon them. If there be no sediment superimposed, the gases generated by putrefaction usually cause the bodies to rise again to the surface about the 9th, or at latest the 14th day. The pressure of the thin covering of mud would not be sufficient to retain them at the bottom, for we see the putrid carcasses of dogs and cats, even in rivers, floating with considerable weights attached to them, and in sea water they would be still more buoyant. Where the body is so buried in drift sand, or mud accumulated upon it, as never to rise again, the skeleton may be preserved entire, but if it comes again to the surface while in the process of putrefaction, the bones commonly fall piecemeal from the floating carcass, and may in that case be scattered at random over the bottom of the lake, estuary, or sea, so that a jaw may afterwards be found in one place, a rib in another, a humerus in a third, all included perhaps in a matrix of fine materials, where there may be evidence of slight transporting power in the current, or even of none, but simply of some chemical precipitate. A large number of the bodies of drowned animals, if they float into the sea or a lake, especially in hot climates, are instantly devoured by sharks, alligators, and other carnivorous beasts, which may have power to digest even the bones. But during extraordinary floods, when the greatest number of land animals are destroyed, the waters are commonly so turbid, especially at the bottom of the channel, that even aquatic species are compelled to escape into some retreat where there is clearer water, lest they should be stifled. For this reason, as well as the rapidity of sedimentary deposition at such seasons, the probability of carcasses becoming permanently embedded is considerable. Flood in the Solway Firth, 1794. One of the most remarkable floods of modern date, in our island, is that which visited part of the southern borders of Scotland on the 24th of January, 1794, and which spread particular devastation over the country adjoining the Solway Firth. We learn from the account of Captain Napier that the heavy rains had swollen every stream which entered the Firth of Solway, so that the inundation not only carried away a great number of cattle and sheep, but many of the herdsmen and shepherds, washing down their bodies into the estuary. After the storm, when the flood subsided, an extraordinary spectacle was seen on a large sandbank called the Beds of Esk, where there is a meeting of the tidal waters, and where heavy bodies are usually left stranded after great floods. On this single bank were found collected together the bodies of 9 black cattle, 3 horses, 1,840 sheep, 45 dogs, 180 hares, besides a great number of smaller animals, and, mingled with the rest, the corpses of 2 men and 1 woman. Floods in Scotland, 1829. In these more recent floods in Scotland, in August 1829, whereby a fertile district on the east coast became a scene of dreadful desolation, a vast number of animals and plants were washed from the land, and found scattered about after the storm around the mouths of the principal rivers. An eyewitness thus describes the scene which presented itself at the mouth of the Spey in Morayshire. Quote, "For several miles along the beach crowds were employed in endeavouring to save the wood and other wreck with which the heavy rolling tide was loaded, whilst the margin of the sea was strewed with the carcasses of domestic animals, and with millions of dead hares and rabbits." End quote. Savannas of South America. We are informed by Humboldt that during the periodical swellings of the large rivers in South America, great numbers of quadrupeds are annually drowned. Of the wild horses, for example, which graze in immense troops in the savannas, thousands are said to perish when the river Apure, a tributary of the Orinoco, is swollen, before they have time to reach the rising ground of the llanos. The mares, during the season of high water, may be seen, followed by their colts, swimming about and feeding on the grass, of which the top alone waves above the waters. In this state they are pursued by crocodiles, and their thighs frequently bear the prints of the teeth of these carnivorous reptiles. Such is the pliability, observes the celebrated traveller, of the organization of the animals which man has subjected to his sway, that horses, cows, and other species of European origin lead for a time an amphibious life, surrounded by crocodiles, water serpents, and manatees. When the rivers return again into their beds, they roam in the savanna, which is then spread over with a fine odoriferous grass, and enjoy, as in their native climate, the renewed vegetation of spring. Floods of the Paraná. The great number of animals which are drowned in seasons of drought in the tributaries of the Plata was before mentioned. Sir W. Parrish states that the Paraná, flowing from the mountains of Brazil to the estuary of the Plata, is liable to great floods, and during one of these, in the year 1812, vast quantities of cattle were carried away, "and when the waters began to subside, and the islands which they had covered became again visible, the whole atmosphere for a time was poisoned by the effluvia from the innumerable carcasses of skunks, capybaras, tigers, and other wild beasts which had been drowned." Floods of the Ganges. We find it continually stated, by those who describe the Ganges and Burrampooter, that these rivers carry before them, during the flood season, not only floats of reeds and timber, but dead bodies of men, deer, and oxen. In Java, 1699. I have already referred to the effects of a flood which attended an earthquake in Java in 1699, when the turbid waters of the Batavian River destroyed all the fish except the carp, and when drowned buffaloes, tigers, rhinoceroses, deer, apes, and other wild beasts were brought down to the sea-coast by the current, with several crocodiles which had been stifled in the mud. On the western side of the same island, in the territory of Galangoon, in the Regencies, a more recent volcanic eruption, that of 1822 before described, was attended by a flood, during which the river Tandoi bore down hundreds of carcasses of rhinoceroses and buffaloes, and swept away more than 100 men and women from a multitude assembled on its banks to celebrate a festival. Whether the bodies reached the sea, or were deposited, with drift matter, in some large intervening alluvial plains, we are not informed. Sumatra. On the coast of Orissa, says Haynes, I have seen tigers and whole herds of black cattle carried along by what are called freshes, and trees of immense size. In Virginia, 1771. I might enumerate a great number of local deluges that have swept through the fertile lands bordering on large rivers, especially in tropical countries, but I should surpass the limits assigned to this work. I may observe, however, that the destruction of the islands in rivers is often attended with great loss of lives. Thus, when the principal river in Virginia rose in 1771 to the height of 25 feet above its ordinary level, it swept entirely away Elk Island, on which were 700 head of quadrupeds, horses, oxen, sheep, and hogs, and nearly 100 houses. The reader will gather from what was before said respecting the deposition of sediment by aqueous causes, that the greater number of the remains of quadrupeds drifted away by rivers must be intercepted by lakes before they reach the sea, or buried in freshwater formations near the mouths of rivers. If they are carried still farther, the probabilities are increased of their rising to the surface in a state of putrefaction, and, in that case, of being there devoured by aquatic beasts of prey, or of subsiding into some spots whither no sediment is conveyed, and, consequently, where every vestige of them will, in the course of time, disappear. Skeletons of animals in recent shell marl, Scotland. In some instances, the skeletons of quadrupeds are met with abundantly in recent shell marls in Scotland, where we cannot suppose them to have been embedded by the action of rivers or floods. They all belong to species which now inhabit, or are known to have been indigenous, in Scotland. The remains of several hundred skeletons have been procured within the last century from 5 or 6 small lakes in Forfarshire, where shell marl has been worked. Those of the stag, Cervus elephas, are most numerous, and if the others be arranged in the order of their relative abundance, they will nearly follow thus: the ox, the boar, the horse, the sheep, the dog, the hare, the fox, the wolf, and the cat. The beaver seems extremely rare, but it has been found in the shell marl of Loch Marlie, in Perthshire, and in the parish of Edrum, in Berwickshire. In the greater part of these lake deposits there are no signs of floods, and the expanse of water was originally so confined that the smallest of the above-mentioned quadrupeds could have crossed, by swimming from one shore to the other. Deer, and such species as take readily to the water, may often have been mired in trying to land, where the bottom was soft and quaggy, and in their efforts to escape may have plunged deeper into the marly bottom. Some individuals, I suspect, of different species, have fallen in when crossing the frozen surface in winter, for nothing can be more treacherous than the ice when covered with snow, in consequence of the springs, which are numerous, and which, retaining always an equal temperature, cause the ice in certain spots to be extremely thin, while in every other part of the lake it is strong enough to bear the heaviest weights. Mammiferous remains in marine strata. As the bones of mammalia are often so abundantly preserved in peat, and such lakes as have just been described, the encroachments of a sea upon a coast may sometimes throw down the embedded skeletons, so that they may be carried away by tides and currents, and entombed in submarine formations. Some of the smaller quadrupeds also, which burrow in the ground, as well as reptiles and every species of plant, are liable to be cast down into the waves by this cause, which must not be overlooked, although probably of comparatively small importance amongst the numerous agents whereby terrestrial organic remains are included in submarine strata. During the great earthquake of Conception in 1835, some cattle, which were standing on the steep sides of the island of Kirikina, were rolled by the shock into the sea, while on a low island at the head of the Bay of Conception 70 animals were washed off by a great wave and drowned. End of chapter 47.